Hello everyone, and welcome to the quick introduction to Unity through the creation of a simple 2D space shooter. My name is Jason Busby from 3DBuzz.com, and joining me on this video series is Mr. Zach Parrish.
What's up?
Not much, man. Sitting here at 4:17 in the morning, recording the intro and wrapping this series up.
We always do the intros last, don't we?
We do, but that gives us something to show everyone.
Something to talk about.
Because we kind of make it up as we're going along,
Yeah.
I guess. No, actually, in this video series, we're going to be creating a game that has been previously created, but it was created in JavaScript using Unity. I've had a lot of students watch it, the videos that were produced demonstrating how to create that game, and then turn around and try to do it in C#, come back to me and say, hey, I'm stuck with this or I'm stuck with that. I decided to go ahead and reproduce that game here inside of Unity, but showcase how to do it with C#.
Well, what is that game?
That game is it's called Proof of Concept. That game was put together by Mr. Casey Jones, and he released the videos over on the Unity forums. He did an excellent job. Very nice presentation. The videos come in at about an hour and a half total. If you'd like to take a look at those videos, I highly recommend that you do, especially if you're interested in creating using JavaScript. Head on over to unityjumpstart.com. That's Mr. Jones's website, and you're going to find a folder in there called Proof of Concept 1, and in Proof of Concept 1, that's where you're going to find the 4 video files.
Cool.
So I highly recommend you take a look at them if you are interested in doing what we're doing here in JavaScript. Now, we are going to push things a bit further because he demonstrates how to rapidly prototype a game that consists of a cube and a sphere that simply slides down the screen. You shoot it, and then it jumps back up to the top of the screen, comes back down, and you continue that process until rather you win based off of some rule that's been set up, such as how many times you've hit it, or him hitting you, you dying, and that happening 3 times in a row, and your lives are gone. We're going to take things and push it a little bit further so that the final game looks like this. We're going to start out with a really cool screen. It's going to give you some instructions up in the corner. It's called the space shooter. Press any key to continue. Then you're going to press a key.
After you press the any key.
The any key, that's right. Now you have some asteroids that are kind of cruising down different sizes and different rotation speeds. And as you begin hitting these guys, they will start speeding up and to the point where they become difficult. You'll notice that we're also tracking how many times you miss. We can also die, and when we die,
you get an adorable pink puff of smoke.
We also employ one of the old 1980s arcade-style game respawning of a player where you slide back on the screen and then you blink because you are invincible for a moment, as you'll see here.
Now, we have some sound effects, too, don't we?
Yep, we do have sound effects. So, as a matter of fact, if I don't have sound being injected in, so I know this is a very cheap way to go about doing it, but if I grab some headphones and
you just lost.
And I restart the game because I just died.
Because you lost. You're going to hold your headphones up to the microphone?
I am.
That's awesome.
But there you go. So, at
least they're Bose headphones, so you know you're getting good quality.
This is true. So, and we also have screen warping as well. So, it looks like a 2D game, but obviously, 2.5D because we are taking advantage of a little bit of a 3D feel here.
Yeah.
We have a scrolling background in place. I've hit a score of 1,000, so I've won the game. Hooray.
Very easy to win that game.
And it's also very easy, as you guys have already seen, to lose. So here we go. 1, I'll come back on. I'm invincible, but not for long. Oh, didn't hold out long enough. We'll die, and let's come back in and die one more time. And here we go. And let's die, and there's our lose screen, so we're not that good. Now, putting this together is going to be a lot of fun. There's a lot of things that we're going to cover. I'm going to keep the design as close to Casey's as I can. Obviously, when we get to the end of his version, we're then going to kind of branch off and polish things up with these nice screens and replace our models and enhance a little bit of the code here and there, but the structure is going to follow along nicely. One of the reasons I decided to do this, outside of the fact that I had so many students asking me, hey, I'm trying to redo those videos that Casey did, but I'm trying to do the project in C# and I've run into these problems. The other thing is the fact that he did do such a great job with JavaScript. For those of you out there that are coming into these Unity videos and it's the first time you've worked with Unity, take a look at his, because then you can kind of get a feel for which language you'd prefer to work with.
Sure.
So you may want C#, you may want JavaScript. Personally, I'm a huge fan of C#. There's a lot of flexibility, a lot of power there. With .NET and all that you can put into action. I mean, you can take advantage of all that stuff over in JavaScript too, but there's just a lot of things in C# that I love. So with that, let's go ahead and hit stop there and give a quick warning. The warning is our style. For those of you that have never seen a 3DBuzz training video, I just want to warn you up front that our style is very relaxed, very casual.
They might have even caught on.
Probably so. I would hope so.
At this point, anybody who would be like interested in this warning has already hit stop. But go ahead anyway.
But I just wanted to point that out because there are people out there that prefer their videos to be very, cut and dry, go from point A to point Z, don't waste any time, which we don't waste a lot of time, maybe a total of 5 minutes in all by the end of this monstrous video set. We are talking about things that are important. You will just catch Zach from time to time making fun of me because I have a hard time hitting the sphere that's coming down the screen.
It's just because it's late. It's not because you're a bad game player.
But it is because it's late. The other thing is, since these videos are being put together in our free time, that means between the hours of around 2 and 6 in the morning, we don't have time to sit down and plan everything out carefully. That would just take a lot of extra time. We just wanted to jump in here, put these videos together, and get them released to the general public for free so that you guys can get in there and start playing with the Unity. But with it being so late, from time to time, we do make small mistakes. It happens, and we do our best to catch those and to point them out as we proceed through this series. Just rest assured that what you saw just a second ago is the final product that we complete through this entire video series. We haven't changed anything off screen. So with that, a couple other things I wanted to do real quick. One, I wanted to spend just a second and talk about the editor, the IDE that I'm using for coding. I'm using Visual Studio, of course, Visual Studio 2008. I am using Professional. If you have it installed on your machine and you would like for that to be your default editor so that when you double click on script files, that is what comes up, as you see here, all you need to do is come up into Edit, drop down to Preferences, and then from the General tab here, just make sure that your external script editor is set to Microsoft Visual Studio 2008. So
now, will that work with Express Edition as well?
Yes, this will work with Express Edition.
Okay.
Let's see, what else I want to talk about. Looking down. Oh, yeah, save. I am not going to remind you to save all the time, not after each video. But just know I am hitting Control-S all the time. I don't like sitting here staring at a screen after a crash and realizing that, I haven't saved in the last 2 hours and I've just lost a lot of work.
Yeah.
So please make sure that you save. With that, there's nothing else that I really want to throw in right here. We can just get started. Again, this is just a quick crash course in Unity. That's the next video coming up. And then from there, we're going to put this game together. So I hope that you guys find these videos helpful. If so, let us know if you're interested in seeing any more of these in the future. I do have another set that will be coming out. These will be specifically targeted towards my Unity students to start out with, and then probably member sponsors over on 3DBuzz that will take this game, break it back apart, recreate it in a different structure, and we'll talk about that a little bit as we progress through these videos. So with that, Zach, thank you very much for joining me with this. And
thanks for having me.
Guys, let's get started. Okay, so the first thing I'd like for us to do before we get going with any sort of cool project is do a very quick crash course over Unity.
Okay.
So, Zach, here we are with Unity up. Now, you've installed the 2.6 version.
I have.
That's now been released that anyone can go out and grab for free. And you've
just
set
this
it up.
morning.
Okay. Now, I've got the professional version that I'm using here. So there are some subtle changes here and there. But let me ask you, when you launched yours, how did it come up?
Well, I only saw one picture of the islands on the left-hand side.
Okay, so you did indeed get the island.
I did get the island.
Okay, so let's talk about the island real quick. So the island is a demo. It's a tech demo of what can be done with Unity. And of course, it's a first-person shooter type game, not a full game, but enough in which you can run around inside this environment and you can see things that come to life. And
it's an interactive environment.
It is, without a doubt. So that opens up automatically so that you can, scroll through the different assets and you can kind of pick apart what they've put together to give you an idea about how games in Unity are put together. And that's very cool. So I wanted to make sure that that did indeed come up.
Yep.
Okay, so anything else different than what you're seeing right here on
Like I
this
said,
one?
I only saw one picture. So like right now, you've got two images that show the island from two different angles.
Okay.
I only got one of them.
Okay, so we're going to talk about these panels here in just a second. I just wanted to get a real quick feel, just for those of you out there that are watching the video, just to let everyone know, when we record videos over here at 3DBuzz, everything is, unscripted. So we're kind of shooting from the hip here, which means I may forget to ask Zach questions from time to time, such as, so what did Unity look like these days when you open it up? Because I've been using mine for quite some time now.
Yeah, and it looked like a totally different app.
Well, it's good to hear that it doesn't look completely different. But that does bring us to the key thing that I would like to point out as we start our little crash course. And that is Unity, in my opinion, is one of the most simplistic editors I have ever seen. It really divides up into three key parts. Those parts are, first, of course, across the top, we've got a menu bar. And before I go any further, let me take 1 second and say this. For those of you out there watching the video, a lot of you may be familiar with 3DBuzz style videos. And with applications, we generally spend a good deal of time going over pretty much every feature available on a user interface. That is not how we're going to approach this series. This is going to be one of those, we'll learn it as we need it, just so that we can really push forward into the cool stuff.
Okay.
So we've got a menu bar across the top. Up underneath that, we have a toolbar with only a handful of options available under.
There's not much to click on the toolbar.
And then up underneath that, we have a series of panels. So when I say we've got three key areas, that's it. We just have the menu bar, toolbar, and panels. Now with panels, there are several different kinds of panels that we will be working with, and we're going to be focusing on 6 of them. There are some others that we will talk about later in time, but for now, these 6 panels are going to be very important to us.
Okay, so what are these 6 panels?
Well, if we come up here and we click on Window, we can quickly see right here a bunch of panel names. We've got Scene, we've got Game, we've got Inspector, we've got Hierarchy, Project, Animation, and Profiler. And then Asset Server is something different, which we'll get to spend a little bit of time talking about later. And finally, at the bottom, we've got the console. So these panels, you can see docked all around the user interface here, provide a way for us to work with different types of content within Unity. And what I mean by that is, let's take our scene panel, for example. The content in which we are working with here is the full composition of our 3D environment that we have put together. So in this case, if I was to come over here and hold Alt down and just left click and kind of drag around, we can see that we've got lights, we've got terrain, we've got trees and water. So again, we're just using this particular panel to look into the world in which we are creating. So obviously we're going to be working inside of our scene panel often. We're not limited to working with a perspective view only, as we see right now. We can come up here to the scene gizmo in the upper right hand corner, and we can quickly switch over to other views. If I was to take this and rotate it around so that we have positive X pointing off to the left and Z pointing forward, if I wanted to quickly switch over, let's say, to a right view, or to a left view, or over to a front view, or even a top view, you'll notice how I'm using my axes here to navigate to that particular view quickly.
And in that one bit where we actually saw the island when it rotated around, you can kind of feel things flatten out as they would with an orthographic view.
Absolutely. Those are indeed orthogonal views. So again, scene view, we're going to be working with it quite a bit. And as we begin working with it, there will be times that we'll need to start working with some of the different options that are available to us within the view. And that's when we'll come in here and we'll start talking about these specific options.
Sure.
So moving down from there, we've got what is known as the game panel. The game panel is going to give you a representation of your final product. So right now, looking down here, what we're seeing is where we're going to kick things off for the game. When I hit play, we're seeing our final rendered representation of the game as we have it now.
Okay.
So let's go ahead and hit play. Let's take a look at this. So look at this. Boom. Everything comes to life. I can now start looking around as if I was in a typical first-person shooter. I can also use my WASD keys, and I can strafe left and right. I can walk forward. So fast, too. I'm actually having to drag the mouse very slowly here. Look around. Look at that. We've got animations taking place. So we have these birds flying. We've got ambient sounds. We've got the water. It has motion on it.
Even it looks like the foliage is moving a little bit.
Absolutely. Everything is just simply, you can see the tree swaying there. Everything's just come to life. But that's the key here. What we're looking at is the game in motion.
This is what the player would see.
That's right. So even if we were to go as far as to create a series of menus and we had scores, everything, we'd get to see all of that right here. This is very convenient because I can just hit Control-P to start and stop our playback mode for the game. That's so much more convenient than coming in every time we want to test something and having to rebuild the game every single time. Much more convenient.
Now, I'm a creature of analogy, and I do come into this from working with a lot of 3D apps like 3ds Max and Maya, and it looks like the real key difference between these two panels is where your scene view, your scene panel, that's going to be a lot like your perspective view in most 3D apps. And
it's going to be like your typical viewports.
Right.
Where you're looking at your final rendered image down here in the game.
Right. Your game panel is going to be like whatever your in-scene camera would see.
That's right.
So you're the director in the top view, you're the player in the bottom view.
And we are indeed looking through a camera. You have to have a camera in which you're going to capture imagery that your player is going to see when playing your game. So that's very important. And we'll talk more about cameras a little bit later.
Okay.
All right, so there's two of the panels. So let's go ahead and move over here to the right-hand side. We've got three panels over here. These guys are all related to assets and game objects that are in the game and properties that we will be working with on the content itself. In the next video, we're going to spend just a few minutes and we're going to talk about game objects. Everything that you see over here inside of our scene is a game object. Game object at its core is just a simple base foundation that we can add components to. And we can make cameras out of them, lights out of them. We can have terrain. The list goes on and on. But if we have something that is over here inside our scene, it is a game object, and we get all of those guys listed here in the hierarchy. So what I'm saying is right now, everything that exists over here in the scene exists here in the hierarchy. Okay. Now, below, we have project. Project's different. Project shows us all of the assets that are available for us to use in our game or in a scene. Okay, it does not mean that every asset that we have brought in is indeed in the game. Okay, there are things that exist over here in our project panel that are sitting there as prefabs, which is something we'll discuss a little bit later, but they're sitting there as these packaged prefabs that will be instantiated when the game runs, and that particular object needs to come into existence.
Okay.
For example, if we had a spaceship that's flying along and that spaceship has a weapon and the user hits the spacebar to fire off that weapon, projectiles, they've got to come from somewhere. And
lasers.
Exactly. So projectiles may sit as a prefab down in the project area where it doesn't actually exist in the game, but then when the user presses the fire button, that prefab is instantiated and a game object comes into existence in the world, and then we can control that game object.
So hierarchy is going to show you the objects that exist in the game as of this exact moment.
That's right.
Does that mean it's going to change while we play the game?
Absolutely. As I was just saying, the spaceship example, as we're firing, we're instantiating all of the prefabs, the bullets or projectiles. If we hit play right now and launch the game again, look over here. Take a look at, we can see things that are coming into existence and going out of existence. And so there is just a quick example. Now, we're going to see this in a much cleaner state a little bit later on when we put together our own simple game. But you're absolutely right.
So the hierarchy panel's a list of everything that's in the game right now, where the project panel is kind of like a library of everything that could potentially be in the game at some point.
Exactly. And to drive that home a little bit better, let's go ahead and bring a folder over here. All right. When you create a project in Unity, all you're really creating is a root folder. And then when the project is created, you get a couple folders that are created within the root folder. And here's what I'm saying. Let's say that we were creating this game and we called it Island Demo. So we would have said, create a new project, and it would have asked us where do we want to put the project and what name do we want to give it. So let's say that we'd put it under Unity Projects, and we called the project Island Demo. To make that, all we would have needed to do was create a folder called Island Demo and select it and say that's our project. And then Unity is going to come in and we're going to end up with an assets folder and a library folder. And there are some other things that we'll see under certain conditions, such as temp or Visual Studio solution files if you're working with Visual Solutions, or excuse me, Visual Studio.
Right.
But we'll talk about that a little bit later. There's so many things to, I hate saying that we'll talk about it later, but there are so many things to touch on. And if we were to talk about every single thing, this would turn into a monster of a video.
It's easy to stray off the main path.
Absolutely. So the thing I want to point out by bringing up this folder here is the assets folder. So if we take a look down here in our project panel, everything that we have down here is what exists inside of our assets folder. So let's go ahead and jump into assets, and I can prove it real quick. So we have airplane ruins, birds, bridges, and you can see the list go on and on. And if we were to scroll down a little bit further, we also have some assets in here, prefab, scene file, a PSD file. And if we were to scroll down over here, we could also find these guys that are sitting out at the root themselves. So if we were to come and start closing things up, there's that islands file that's not actually in a folder. So the folders that we have back here inside our actual folder structure are represented as folders in here. And we'll be creating folders in here later. Just keep in mind, as we're doing that, we're actually creating folders behind the scenes for real in the directory structure.
So in the end, the projects panel is really just allowing you to browse and dig through an actual folder structure in your OS.
Exactly. But there's a lot of power that comes with this panel right here. When I drag and drop audio files or textures into the projects panel, there's importing that takes place. You know, there may be some texture compression that takes place.
Right.
So there's some other things that are happening that's going to benefit us by bringing these assets in. So it's not like just we're dragging a particular file over to a folder inside our assets.
Right. And one of the reasons this is so interesting when you point it out is, again, I come into this from a different background. You know, I come into this from 3D animation. I've also worked with other game engines where assets are packaged up into kind of a particular type of file. So, and when you try to go into your OS, you'll only see this very specific type of file. You won't actually see a folder structure that exactly reflects what you see inside the editor itself.
Right.
Things get compressed down into a proprietary format.
Exactly.
And here you don't have that. Here you have something that's literally reaching into the exact same folder structure you would get if you navigated to it inside of Windows or Mac OS.
Absolutely. Well, I mean, for example, with our airplane runes right here, if we were to jump into the FBX models, look at that. We're actually looking at the FBX models right there. If we come back over here and we were to open up our airplane runes, there's FBX, open it up, and there's our models, in which we could take and drag them straight into the scene or up here into the hierarchy and make that object now exist in the game in this particular scene. Okay, so with these two guys out of the way, and we'll be working with these a lot. We're going to talk later on. I mean, you see up here how we've got these collapsible objects, but everything's supposed to be a game object. But the question is, you know, what are these guys that can be collapsed? Well, all we're looking at are game objects that have been parented. We've just created hierarchy. So that's all you're looking at here is a root level game object, and then we have other game objects that have been parented to this guy.
Gotcha.
So a bit different than the folder structure that we see down here in Project. Now you'll notice that as I have been clicking on things in both the hierarchy panel and down here in the project panel, over here on the right-hand side, the inspector has been coming to life. what the inspector does is it shows us the properties of a selected game object or of an asset. So if I was to come over here and select a PSD file, you'll notice I've got all sorts of information that comes in regards to are maps being generated, what kind of filtering are we going to use.
Looks like you even get a sample of it, yeah.
Yep, so there's a lot of things that's taken place. Or if I was to dig down, just one more example, let's see, scripts. If I was to look at scripts, it's going to fill this guy out with as much as it can show us from a script until we get to a point where it's going to say etc., in which you'll need to go into an editor, which we'll be looking at here very shortly. Sounds, so if we were to jump in here and take a look at some of the sounds, look at that.
Oh, nice. You get a waveform.
Yep, and the ability to play it. And it's very powerful, but it's very straightforward and simple. And I really, really like that. So
context sensitive, that'd be a big word to throw
absolutely.
out for that guy.
So the inspector is simply going to show you the properties of the object that you have selected. So I come in here, well, object, asset, or let's go ahead and throw one more thing in there, because up here we're looking at game objects. And so we see game object and we see any components that have been attached.
Sure.
Down here we're looking at properties from the particular asset. We can also come up here, let's say to edit, come down to project settings, and let me pick on player. Now we're looking at player settings for the game. When we go to actually build our final game here, these guys are going to be taken into account. Things like the default screen width and height, etc.
So these are properties for the editor itself?
Yeah, properties for the player for the game.
Okay.
So the inspector is going to show you properties for pretty much anything that you select, be it an asset, be it a game object, etc.
Okay.
Okay. And then, of course, as soon as we select back on something here, it's going to light up over on the right-hand side and jump back to those particular properties.
Very cool.
So, again, keeping things nice and simple. When working inside of Unity, you're going to find yourself working in these panels. The panels break down into very simple and concise categories, with working inside our scene, looking at a representation of our game in action and testing it out without leaving the editor, seeing all of the game objects and the hierarchical relationships between those game objects, seeing all assets available to us, as well as taking a look at all of the properties that are available for us to manipulate on a given object that has been selected. There's one more panel that at the moment I've got it over here on my left side monitor. Let me make sure he makes a very quick appearance, and that is our console. And the console is a very, very helpful panel. Once we begin creating scripts, this guy right here is going to be available to us where we can debug information out. We can log information out to here so that we can keep an eye on what's taking place under the hood. Also, as we run into problems that will generate warnings or errors, we will also see those in the console. We'll also get a flash of it down here at the bottom. So the last thing that gets printed out or the last warning will simply sit down here until it gets cleared. But over here in the console, you can generally select on the error or whatever it may be and get additional details down here at the bottom. And we'll get to see this quite a bit in the project that's coming up, because we'll use this for debugging some of the things that we're going to be putting together. So with that, that's pretty much everything that I wanted to talk about at this stage of the game. Again, quick crash course. Just make sure to understand that we're dealing with panels, toolbar, and a menu bar, and we're working with game objects. It's that simple. So any other questions?
No, I think I'm with you so far, man.
Okay, as we dig deeper and deeper into our own game, everything here is going to just really start to solidify. So with that, that's going to wrap up this video. Thanks a lot, guys. Okay, before we kick off our simple game project, I wanted to spend just a minute and talk about game objects. Now, as far as I'm concerned, game objects are the very heart of any game created with Unity.
So what is a game object?
So a game object is, well, that's the funny thing. A game object's everything. Well, just about everything as far as objects in a game go. A game object is a base object that comes with a transform ability, so it can be positioned in the world, and then it has components attached to it.
Okay.
So perhaps you can help me come up with an analogy here. So you being the student, this should be a lot of fun.
Okay.
So I'll describe to you a little bit more about Unity, and then you find something in the real world that you can relate this to. And I'll give you a very cheap version out the door. We order a pizza. The base of a pizza comes with our crust, and we've got some sauce and maybe even some cheese on it.
Okay.
And every time we get a pizza, we'll always have that.
Sure.
Okay. Now, you can turn around and you can start adding stuff to the pizza to get a very specific kind of pizza. I would like perhaps a pepperoni pizza.
Okay.
I would like a supreme. I would like a taco pizza, something radically different.
Yeah.
But these pizzas are all indeed different types of pizzas. With a game object, we come in and we attach components to the game objects. And by attaching components, we then come in and we give that object in the game its specific meaning, if you will. So a camera is nothing more than a game object with a camera component attached to it. Let's take a look at this real quick.
Okay.
If I come up here to game object in the menu, I can create an empty game object. So out the door, if I do just that and create an empty game object, you can see right here, game object. Let's look over in the inspector with this guy selected. All we have is the ability to set a name, activate or deactivate him. We can assign a layer or set a tag. And we have a transform component that's always going to be there with the game object. And this gives us the ability to position this guy within the world. But that's it. There's no geometry associated with him. There's no light associated with him, no sound, no nothing. Those are things that we will then define by simply coming up to component, and then we can begin attaching components to this guy. So I can come over here to mesh, and I could attach a mesh filter, a mesh renderer, text mesh, etc.
Okay, so what I'm getting out of this, conceptually, a game object is kind of like a generic machine.
Yeah, there you go.
We don't really know what it does. It's just a generic machine. And depending on the stuff we bolt onto it, it could perform specific things. Like we could turn it into a dishwasher if we bolted the right things onto it. Or we could turn it into a battle tank instead. Okay. And they're all the same thing. They just have different things attached to them.
Exactly.
Okay.
So, the difference between our light and our camera is simply the components that have been attached to the game object.
Okay.
Because as I come through, take a look at this, in the hierarchy, because remember the hierarchy is populated with nothing but game objects. As I come through here and I click on game objects, you'll notice that the top, for the most part, is going to stay the same. Now, there is some prefab stuff that's going to show up here. And prefabs they're special prepackaged game objects, if you will. That's something we'll explore a little bit later. Very powerful stuff. But the key thing is you're seeing the same thing as I go through all of these game objects. You're seeing a name, you're seeing a place for a tag and a layer to be assigned, and you're seeing a transform component. And then with different objects, you're seeing additional components attached. Like in this particular case, this level objects game object right here is acting as a parent for all of these guys that are up underneath him, but he has no components assigned to him. But if we were to jump down here to somebody else, this guy right here, _bunker combined, he has a component attached. The component that he has attached is a script. So this script has been attached. So that's really nice. If you wanted to, let's say, create some sort of a script that's going to cause something within your environment to take place, you can drop an empty game object in, as we've done right here, and then you can write a script using whichever language it is that you prefer to use with Unity, and then you can take that script and drag it from down here, because remember, the script, of course, is going to be an asset, meaning it's going to show up down in your project section. You can simply grab, drag, and drop it. As a matter of fact, we're not going to use this guy, so I'll pick the FPS counter. We grab, drag, drop, and boom. We have now attached a component to this game object, giving this game object more focus, if you will,
more functionality,
a more specific reason to exist.
Now, do all of these game objects have the transform information?
Yes.
So, and again, I'll keep throwing these out there because I do come to this from this kind of 3D animation perspective. These are kind of analogous to locators in Maya or helper objects inside of 3ds Max. They just kind of have a position and they're ready for things to be attached to them?
Yeah, pretty much. We have no real gizmo here other than, we're looking at the translate gizmo right now that we can, move it around with just to adjust these positional numbers. But there is no sprite associated with it. There's no geometry, etc.
So like a locator that didn't even have the little crossed lines.
Exactly.
It's just like the general concept that you have some sort of null object in place.
Exactly.
Okay.
And then when we come in behind that and we begin bolting things onto it, we begin attaching components. And by hooking up these different components, we give that particular object its meaning that we want it to have.
Okay.
So coming up here, you saw where we had created an empty game object. Instead of creating an empty one, we also have a bunch of game objects that have been predefined for us just so that we don't have to go through the same steps over and over and over. If we were, let's say, creating a bunch of cubes or we needed to create several cameras, we already have these things predefined, as I accidentally hit the mouse off the screen. So if we want to grab a particle system or a camera, let's just drop a particle system in real quick. So I've thrown a particle system in down here. Let's look at the top. What do you know? Standard game object, standard transform information, and now we have very specific components that have been attached. So these components all work together in giving us this particle system effect that you can actually see right there in your screen, alive and popping.
I got you. So to actually kind of retract what I said earlier, it's not like this is like a locator. It really, I mean, if you were taking the Maya aspect, and I know I can't really assume that everybody watching is a Maya person, but I am. So if you are too, then
I knew where you were going with it, so I didn't have a problem with it.
This is actually more like a transform node.
Yeah. It's even if you want to take another step away, look at this as kind of like a base class in the programming world, where we're then going to extend this class into more specific functionality.
Well, see, I was actually trying not to say that right out of the gate because it felt like you were trying to stay away from using words like class right now. So I was like, how can I say this without talking about base classes?
Fair enough, but that's the key thing. Just as long as you understand that by coming in and attaching components, you then define the functionality of that game object. So again, here we are with a particle system. Let's go ahead and jump back up real quick to game object, come down and, let's do a camera real quick. So I'll throw a camera. So here we are, look, brand new camera sitting in the scene. Starting at the top in the inspector, same thing. There's our transform component, and we're looking at the name, tag, layer information. But then up underneath that, take a look at this. Once again, we have a component that has been attached, another component, and another component. So here we are with multiple components that have been attached to this camera.
Okay.
Now, could we have built these things from ground up? Absolutely. You can simply start with your own, if I come back over here, empty game object, and then once you've created an empty game object, as we've done here, you can then come in to component and you can begin adding into it the things that you would like in order to give it the functionality that you're looking for. So even here with rendering, camera, blink, now we've got a camera component. And this guy's just come to life, and look at that. All of a sudden, he has where we're going to be looking at with our camera. We've got the gizmo available for us inside our scene. Very powerful stuff. And as easy it is to add components, we can, of course, come in here and quickly reset or remove components altogether. So if I remove this out, we no longer have a need for seeing our camera gizmo information over here, so it's now gone.
Now, are each of these components completely modular? For instance, could we have like a camera that was also a particle emitter?
Yes, you can. Yeah, you can pile a whole bunch of things on, having them all do different things.
Okay,
absolutely. But the most powerful thing, as far as I'm concerned, is the ability. And I can just show it to you up here. If we come up here to, I was going to jump back over to the project, but there's so many ways that you can do the same thing. But when you write scripts, your scripts are just components as well. So here we are with a ton of different script components that can be added to our game object. So again, they're just components. We can simply add them on. Or of course, from over here, we can come down to any of these scripts and drag the script over here and just drop it in the inspector, or we can simply drag it straight onto the object itself, and then boom, we now have another component that has been attached.
Okay.
But that's the big thing that I would like for everyone to take away from this video, and that is just understanding that every object that we're working with in our scene is a game object. And at the base, the game object is nothing more than a place to set a name and a tag and a layer. Now, there are some other things that we can get to behind the scenes, and we've got a transform node as well. But it's more or less just like, a clump of clay. And now we need to come in and start manipulating that. And the way we manipulate things here inside of Unity is by adding on components and then adjusting the parameters of those components. So any other questions?
No, sir.
All right, well, with that is going to wrap up this quick video over the game object. Now that we've taken a couple of minutes to look at the Unity user interface in our quick crash course on Unity, as well as the game object, we've talked about the game object and how we can attach components to it to give it its specific meaning within a game, it's time for us to really begin learning Unity. And the only way we can do that is to get our hands dirty, to get into a project and create something.
Learn by doing.
That's right. Now, as I said back at the very beginning of this video series, the simple game that we will be creating is really a parallel creation of the one that was done by Mr. Casey Jones. He had put together a series of videos that did an excellent job of showcasing how to put a simple game together for beginners with Unity. Now, he used the default scripting language, so he was using JavaScript. I've had many of my Unity students watch those videos and have a good time following along, but then they end up jumping over to C# and they try to reproduce the project and they find themselves struggling. Some get very resourceful and go out on Google and find the information they need, while others run into a brick wall. So I thought it would be really cool to have the same project reproduced, almost the same project. It's darn close, but instead of using JavaScript, do it with C#. So this is going to be very helpful for those of you out there that are new to Unity and you plan on doing all of your coding in C#. This is also very helpful to me because I don't need to create this set of videos twice, once with JavaScript and once with C#.
Right.
So if you are interested in seeing how this is done with JavaScript, head on over to www.unityjumpstart.com and take a look at Casey Jones' videos that he had put together, and you'll see the exact same project, but you'll see it done with JavaScript.
Okay.
So with that, the very first thing we need to do is create a new project. So very simple stuff. We'll just come up here to File. We'll come down to New Project. Now, as I had said a couple videos back, in creating a new project, it's really just creating a folder in which we tell Unity this is going to be where our project will live. So instead of using the default that's being suggested here, location, I'm going to come over here and click Browse. And then inside of Browse, of course, we're still down inside our island demo, but we are within the Unity Projects location. So let's jump up to Unity Projects. And for me, I'm just going to come down here to VTM Content, right-click, and create a new folder. So let's call this Simple Game, like such. And then with Simple Game selected, I'm going to simply hit Select Folder. But before I do that, let me bring up my opened folder over here to show we've got Simple Game. If we jump in, nothing inside him, okay? So let's go ahead and push him offside and hit Select Folder. And now it's going to ask us, import the following packages. Now, since I have the professional edition of Unity, I can bring in the Pro standard assets. I don't want those, and I also don't want the standard assets either. I don't want anything coming in. We're going to create all of the stuff ourselves. So everything's been unchecked. Let's go ahead and hit Create. And it's going to ask if I want to save anything that I have done with the island demo, and I don't want to save it. I've added some stuff in and all.
Sure.
And then with that, everything disappears. You see my lovely desktop for a second, and boom, we are now back in our simple game. So at this moment, if we were to come over and take a look at, let's bring this back over on screen, folders again. So here's Simple Game, where just a second ago I showed you that it was empty inside. If we jump in now, look at that. We now have Assets, we now have Library, and we now have Temp. If we jump into Assets, Assets is empty. and it should be empty. Take a look down here at our project panel. It's empty. There's nothing in it. Now there is a folder that I would like to create starting out, and we're going to do that over here inside the project panel. And that is going to be a folder in which we will save our scenes.
Okay.
Scenes are very important. Scenes are where your level lives. It could be where menus live. It's where your game objects are going to live. When you play a game, a scene is loaded, and it is that scene in which you are interacting with menu options or perhaps an entire level, as if you were playing a first-person shooter like Unreal or some of the other game types that are out there. A level, look at a level as a scene.
Sure.
Okay? But a scene can be more. I just want to point that out. You could have a scene that's nothing but a menu that comes up.
So would it be better maybe to call a scene like an environment?
Well, they're called scenes.
Right. I mean, if we're reaching for analogies, though, if we're reaching for other things,
I don't have a problem with scenes.
Just call it a scene.
Just because, again, a scene could simply have a graphic on it that's going to be your splash screen.
I gotcha.
And then after a counter counts down, it's then going to load another scene, which may be a menu or an actual level for the gameplay to begin. So first thing I'm going to do, let's go ahead and create a new folder. So I'm just going to simply right-click inside my project panel, come up to Create, and first thing, Folder. Let's add that folder in, and then I'm just going to simply single-click over here, and let's call that Scenes, like such. Now, I want to come up here to File and jump down to Save Scene As, and I'm going to come up under Scenes. So you'll now say we've got the folder, it exists up under Assets. We'll simply jump in, and then from here, let's call this something like Level 1. Okay, go ahead and save it out. You'll notice up at the top, we have level1.unity. That's the scene that we're now working with. Over here in Project, if we open this guy up, we now see our level 1 scene.
Nice.
So if we were to close Unity out, project's been saved. When we come back in, you'll need to make sure to open level 1 back up instead of working in the blank scene that you get by default.
Okay.
So now that we're inside this guy, let's see, what else did I have for us to get knocked out real quick? Let's go ahead and take care of the camera. You'll notice that we have a main camera. It's the one thing that exists in the hierarchy, the only thing. And you'll always get this every time you create a new scene. You'll always have a camera. So there's a couple of things I want to do real quick. I'm going to come over here and change the background color. So all I need to do is simply click to bring up my color picker, and let's just take it to black. That'll work for me. Next thing I want to do, we're going to be showcasing a 2D style game. So let's go ahead and turn this into an orthographic view coming from this camera. Remember, what the camera sees is what the player is going to be seeing.
Right.
So I'm just simply going to come over here and check orthographic. Now with orthographic check, you can see how far out we can see with our far clipping plane by how far it's drawn this rectangular box. Let's now go ahead and change our orthographic size. And we're going to have a discussion dealing with orthographic size a bit later on so that you can determine exactly pixel-wise where your left and right edges of the screen are that you can then use inside the scene. For now, let's just go ahead and set it to a setting. And we'll come back to it a little bit later so we can spend a little bit more time on it. But I'm going to use 5. So there we are, nice and small. And also, if I want to focus up on this guy, all I need to do is with him selected, simply hit F, and that's going to frame it up for those of you that are used to working with 3D applications. And with that, one final thing I want to do is down over here, as far as our screen aspect is concerned, let's simply drop this down, and I'm going to change this over to web, and we're going to just stick with 600 by 450 right now, just so that we're all working with this size right here. And we can talk about different resolutions and how to handle that a little bit later. So with that in place, that's pretty much everything I wanted to do. Very quick, simple video. In the next video, we'll create a player and a light, and then we'll start building from there.
So we just kind of set the stage.
So all we've done is just set up a simple project, set our camera up, and called it. That's it. Okay, so with that, that is going to wrap up this video. Okay, now that we have our project set up, let's go ahead and move forward with the creation of our player and a light that will enable us to see the player. So first things first, the player. What are we going to use? Well, we could run off and create some fancy geometry and bring that in, or we could start simple. We can create a cube, use the cube as our player, set up all of the code for him, and then later bring the model in that our artist has put together and simply switch out the cube for the real geometry.
Okay.
And so let's take that approach. That allows us to just get things going and rough a game in quickly.
Sure, kind of prototype it.
That's right. So what I'm going to do is create a cube for our player. So I'm going to come up here to Game Object, come down to Create Other, and then let's just come down to Cube. Now we have our cube. First things first, let's go ahead and give him a name. So I'm just going to come over here and call him Player. Next thing I'm going to do is I'm just going to set the position to 0, 0, 0 for now. So come in here and set 0 for Y and 0 for Z. Okay, so we can see him over here sitting there. The next thing I want to do is I'm going to scale him up a little bit. So let's take him up to about 1.5. So we'll go ahead and jump into 1.5, 1.5. And funny enough, I'm going to go and do Z as well, even though since we are doing an orthographic 2D style game.
Yeah, you couldn't really see it.
Yeah, exactly. But I'm going to go ahead and just keep this a nice cube for at the moment. Now, bringing this game object in of type cube, you'll notice that, again, we have the game object. But then moving on down, we already have 3 components attached. We have a mesh filter. The mesh filter holds our mesh. It holds our geometry. So all I need to do when I bring new geometry in later is simply, once the geometry has been brought into the project, drop this down, and that geometry would then show up in our menu. From there, we have a box collider. Box colliders are very helpful when you're wanting to do collision type stuff, which we will be wanting to do soon. And then finally, we have our mesh renderer. And the mesh renderer is going to be the guy that's responsible for actually getting the surfaces onto our mesh that we are then able to see in the end. And we can also determine things like cast shadows, receive shadows, and then finally materials that will be applied as well. And we can see right now element 0, default diffuse material. So let's go ahead and create our own material and apply that material to our player.
Okay.
So to do that, let's bring our attention back down here to project, because the material is just an asset that we will use with a game object as opposed to a game object that exists.
Okay.
So we need to create that down here in the project area.
A component, could you say?
It's not a component.
Okay.
It is just an asset, like how a texture
Sure.
would be an asset that you could use on a component. So here we are with a component, the mesh renderer, actually looking for a material.
Okay, I gotcha.
So I'm going to come down to project, right click, come up to create, folder, and this folder is going to be called, do you have a guess?
Ooh, materials?
Very good.
Ooh, so creative.
Oh, yeah. So now we have materials. Right-click again with material selected. Come down to create, and now I'm going to create a material. So here we are with our standard default diffuse material. First thing I want to do, simply click and give this guy a name. I'm going to call him M_player. M underscore is just something that's kind of carried over from Maya for me from so many years, and it's a quick way of designating my materials inside the material folder. I like having, this is something just to point out real quick, I like having the M underscore here. If I was to create other folders up underneath the materials folder to help kind of keep things further organized,
Sure.
but I still had materials that were sitting just at the root of the materials folder, everything is listed down here alphabetically, and so you could end up with a material, a folder,
right.
By doing M underscore in front of all of your materials. They'll all be grouped together.
Yeah.
Then you'll have your other subfolders.
And on top of that, it's just important to have naming conventions in general.
Yeah. So now that we've got this guy in place, let's give him a color. I'm just going to come in here, and again, I'm going to keep this as close to Casey's as I can. So I'm just going to go with some sort of, that's a little bit of a bright yellow, but we'll go with a yellow color.
Hey, my motorcycle's that color.
So we can see right now that on this material, we have a main color. We do have a place we can drag a texture if we had a texture. And we can also choose between a bunch of different shader types that are available for driving this material. But we'll just stick with the standard diffuse, the default diffuse. So now that we have created a material, let's get that material applied. All I need to do is simply left click, drag, and drop him on the player. By doing that, you'll notice that our player is now turned yellow.
Very nice.
Furthermore, if we click on player and we take a look over here, look at this. On that mesh renderer that we were looking at a second ago, up under materials, size 1, element 0 now contains m_player instead of that default diffuse material.
Okay.
So we've got this guy applied, and we can see the material being applied as a component down here with the shader and everything, in which we could manipulate further if we would like. Next thing I want to do, let's go ahead and add in a light. So we're going to come up to Game Object once again, and we're going to come down to Create Other. And then from inside here, let's pick a directional light. So we'll drop him in. He's already pointed in the right direction, so this is just giving us parallel rays of light.
That brightened everything up.
And everything's nice and bright now, and that works well for me. That's everything that I wanted to do in this video. Just a very quick video of getting a player in the scene, getting a light illuminating that player, and making sure the player had his own material that we could manipulate. Any questions?
No.
Okay, well with that, that is going to wrap up this video. All right, welcome back. So now that we have our player, cube, just kind of sitting there, it's time to bring this guy to life.
Okay.
In this video, what we're going to do is take a look at scripting. We're going to create our own custom component that we will be adding to our player here that will enable us to read input from a user that's playing the game and make this guy move back and forth. But more importantly, in this video, you're going to see for the first time how we would go about creating a script that we could then turn around and attach to our object.
So we're going to be doing some programming.
So we're going to be doing some programming. And on that note, let me spend just a second and talk about programming. We may have some viewers out there, Zach, that aren't programmers.
Oh, no.
And you might kind of fall in that category as far as any language that requires a compiler.
Yeah, I have to admit, I do a lot of stuff in MaxScript and MELScript, but if you have to hit a compile button, my brain kind of shuts down.
Well, it's actually going to be pretty easy. I'm going to do the best I can to make everything clear here. But I just want to point out that I'm not going to stop and start talking about things like inheritance and what instantiated classes are, et cetera, et cetera. But I would like to point out that over on 3DBuzz.com, we have created an XNA series. There's actually quite a few of them out now. We got XNA Volume 1, 2, and 3. And with XNA Volume 1, there's a large portion, at least 10, possibly 11 hours of it, that is freely available. So you can head over to 3DBuzz and create yourself a user account, which is absolutely free, and then jump in and start watching those Volume 1 videos. If you're new to C#, we're going to talk about getting C# up and running. Now, they're a little dated. I believe at the time when those were created, we were using Visual Studio 2005 Express. But it doesn't matter. Everything's still going to apply. The Hello World project that we make available for everyone goes way beyond a standard Hello World project.
Well, it's actually a full game.
It really is. We walk you through the creation of a text adventure game in which Zach wrote the underlying story and all the decisions you have to make. But we cover a lot of stuff. And throughout those videos, we continuously remind our viewers not to panic if they're new to programming. We just want for them to get in, follow along, get their hands dirty, and get exposed to some of the terminology.
Now, do you consider those videos to be a prerequisite for what we're about to do here in Unity?
They are not. I just, if you're new to programming, I highly recommend that you take a little bit of time and you can go to Microsoft, you can simply Google C#, find some introductory tutorials, do a little bit of reading. If you are new to the concept of object-oriented programming, it's very important that you at least have a basic understanding of working with objects and what properties are, data members, behavior, etc. Because all of this is, it's all underlying themes when working with C# and you're putting your scripts together, because we're going to be working with all of this stuff.
Absolutely. And while we're doing this stuff here on the Unity videos, I mean, you can type what we type. You can run the whole thing in monkey see, monkey do. But if you really want an understanding of what's going on under the hood, there is going to be a little bit of additional research required on your part, because these aren't programming videos.
That's right. But the good news is everything we're going to be doing throughout this simple game is pretty easy.
Cool.
Actually, very easy. So I'd like to point out that by default, when you're working in Unity, the scripting language is JavaScript. I am using Visual Studio. In fact, I'm using Visual Studio Professional 2008. Now, If you happen to have the Visual Studio 2008 Express, that's fine. It'll work with it just as well. There's a couple little things that won't work, such as in your console dialog or a panel that you guys saw earlier. If you get an error, you can't double click it and it take you over to that line inside of Visual Studio. This isn't the guys behind Unity putting this up as a, sorry, you've got to have the full-blown thing to do it, meaning professional. That's not the case at all. When you're working with Visual Studio Express, Microsoft has basically blocked off some of the hooks into it.
Sure.
With the intent of, if you want to get more professional, get the professional version.
Makes sense.
So, but everything that I'm going to be doing, you can follow along with absolutely fine.
Okay.
So, with all of that said and behind us, let's go ahead and get started. Again, we're going to be creating a script. So this script's not going to be a game object that we're going to come up here and add to the hierarchy. It's going to end up being a custom component that will be added to our player game object. So we're going to come down here into our project panel, and this is where we're going to create our script. But we need a folder. So I'm going to right click, come up to create folder, and let's call this guy scripts. Keep everything nice and organized.
Oh, yeah.
So now what I'm going to do is right-click, come up to create again. You can see JavaScript, C# script, Boo script. So we've got these 3 different types of scripting languages that we could work with. Now, when Casey Jones put this example game together, he used the default JavaScript. And again, the reason I'm paralleling what he did is I'm simply reproducing it using C#. So let's go ahead and select C# script. So we've got a new script in. There's a couple things I'd like to point out. First of all, if you've played with Unity before and you've not worked with C# scripts, but you did play with the JavaScripts, you'll notice that there is definitely a difference in the way things look. We can actually see the class and who we inherit from, where that's not something you're going to see when you're working with the JavaScript that gets created when you right-click and add a new script.
So is it just a syntax difference?
Well, I mean, it's a language difference.
Yeah,
They're different languages.
Right.
So here, first thing I want to do is go ahead and name my script. So let's go ahead and click on it, and I'm going to call it player. I'm just going to have it simply match my my object, my game object. Now, you got people out there that like to do things like player script.
Sure.
Or S_player. And there's nothing wrong with it as long as you come up with a naming convention that you stick to. And if you're working with a small team of people, everybody is agreeing on. That's the key thing, is consistency. In my case, when I come up with my my scripts, I generally use the name of the object that it's going to be attached to, unless it has some other very specific type of behavior that it's going to be responsible for.
Okay.
So we've got it as player, but take a look at this. The class is called new behavior script. So the name of the class did originally match the file name that was created, because this is actually a CS file that has been created in the scripts folder up under the assets folder in our project. If I try to take this guy right now, drag and drop him up on player, it's not going to let me, because it's expecting my class name here to match my file name. So let me click and try just to show you guys. So drag it up, drop it on player. We get the dialog saying can't add script. And this is because can't add the script behavior player because the name does not match the name of the class. So we need to fix that. So this is where I'm going to open up Visual Studio, which is where I'll do all of my scripting work, of course. Now, I'd like to point this out. When working with Visual Studio, as a matter of fact, if you guys give me just 1 second, actually, let me just do this and then I'll pull it up. I'm going to right-click on player. This is the important thing to understand here. I'm going to hit Sync Visual Studio Project. And the reason I'm doing this is I honestly cannot recall if in standard Unity, if it will automatically sync when you double click to open up a file. Only because I've just been steadily working with professional.
Yeah.
Exactly. So hey, I'll be honest, I just don't remember. Plus, I haven't worked with 2.6 standard at all, to be honest. And it is with 2.6 that they added the ability in to work directly with Visual Studio. What's going to happen when you click on the Sync Visual Studio project, which you can right-click and select from a script, or you can also come up to Assets and get to it from up here.
Okay.
What's going to happen is a solution file is going to be created, and that is a Visual Studio solution file, in your project folder at the root, so at the same level as your assets folder and your library folder. So if we were to jump down here and open this guy up, so here we are in Unity Projects, VTM Content. Inside our simple game, there's assets, library, etc. Here is the solution file that was just now generated.
Just like as if we were programming this inside of Visual Studio.
That's right, and we had created a project over there.
Right.
And this solution file, of course, is going to have all of the files that we're going to be working with inside of Unity. Everything keeps organized. So the idea is that we want to keep our solution file synced with the files that we add back over here inside of Unity. Now, what's really nice is from inside of Visual Studio, if we add files there, Unity is really slick. Unity is going to pick those up automatically.
Gotcha.
So that is generally where I'm going to add files. We're going to come back to that a little bit later because I want to show you guys how you can create a template. So instead of having to right-click and create your scripts over here, you can just add a new Unity or mono behavior script inside of Visual Studio and just stay working over there all day long.
And it'll just pick right up.
And it'll just pick right up, which is fantastic.
Now, what you were saying earlier is that you can potentially double-click on that script here inside of your project panel, and it will sync, but you also right-clicked on it?
I did. And the reason is, once again, I simply can't remember if with standard, if double-clicking it is going to give you the dialogue and sync things up. It may just be pro only.
Okay. Either way, it's just safer to right-click and choose it directly.
Well, to be honest, in standard production, I will right-click and sync it all the time anyways if I've added something over here since I've been in Visual Studio, because I have a couple of times in 2.6 have had it to where I've double-clicked and it's not synced up properly.
Gotcha.
So I don't know if that's a bug. I'm not sure what happened. So I've just got into such a habit of I just always sync, double-click, and then so there we go. It opens up, and now I am looking at my file.
Very nice.
Okay? And you can see it's got my directory structure showing up here with asset scripts, and then there's my player.cs file. Now, first things first, let's go ahead and change this name from new behavior script over to player. Now, if we were to save it, the moment I click back over here into Unity, this thing's going to be analyzed and compiled, if you will. So let's go ahead and click back over here. If we had any problems with the script, an error would have shown up over in our console, and we would have also seen the error down here.
Okay.
But everything's cool. There's no problems. But we can try something now. Let's grab player, drag it back up here to our player game object, let go.
And it just works.
It just worked. It gave me no errors. And now when I select player and I start looking at all of the different components that have been attached, down here, you will see that I now have a new component that has been added, and this is my script component player. Okay?
Okay.
So now that we have it in place, let's jump back in here. Let's point out another thing that is very important, and that is we also have help.
Fear not the help file.
The help file is so important. As a matter of fact, before we start doing some coding, I'd like to show you how important it is. Let's jump back over here to player and take a quick look at what we have for our script so far. So we've got using the Unity engine. So now, as we begin coding, everything that exists inside the Unity engine is just accessible to us. So all of a sudden, code just understands. If I wanted to say destroy something and type out the word destroy, it's going to know, hey, I know what destroy is because destroy is inside of the Unity engine. And since we're using it, it's right there at our fingertips. We're also using system.collections. We don't really need to use that at the moment, but if we wanted to use like array list or something, we have that at our disposal. But here's the big thing. We have a public class called player that inherits from mono behavior. So mono behavior is our base class. That's who we're inheriting everything that is protected and public from this guy. He has several very important things that we're going to be inheriting, such as a bunch of overridable functions. And here's what I'm talking about. We've got a start function and an update function that have already been set up in a template here for us to utilize. And some comments. Use this for initialization. So we'd put some code in here on initialization for our player script. And then update is called once per frame. So if there's something we want it to do every frame, we could add the code in here. Outstanding. But where do these come from? I hate things that just appear magical. I like to understand where things come from. Well, since we're inheriting from mono behavior, and mono behavior we're now getting back to unity itself. Here's a way of looking at it. You can look at it as unity has hooks into mono behavior, and then there are functions that exist in mono behavior that are virtual that we can then override to put our own functionality in. And as the Unity engine is hitting that functionality, that just kind of trickles down to us, the actual component attached to the game object, and our code executes.
Okay.
So I want to see start, update, and what other functions are available to me. So what I'm going to do is I'm going to actually jump down here and open up my browser just to point out to you guys that we also have help available to us online. Just showing you, there's help all over the place. Use it. So here inside the help, which is actually the same thing that you'd have inside of Visual Studio as well.
Yeah.
What I want to do is come down here to runtime classes, because our player is a script that's going to be a runtime type class. And he's inheriting from a class that is obviously a runtime class. So from inside here, let's find mono behavior. That's who we're extending, right? Because we're not going to find player in here. Player is our own custom thing.
Yeah, we made that up.
So as we come down to the world of object, and we start digging on in, we find mono behavior. Or you can use Control F and just type it in.
I was going to say, I would just have to search for it. I hate lists.
So let's go ahead and click on this. And here's what I want to point out. So mono behavior, it's the base class every script that derives from. And I would like to add my own comments to that. Yes, it's the base class that every script that will be attached to a game object will derive from. Okay? But that does not mean that you are limited to every single class having mono behavior somewhere back up in its family tree as the base. Meaning you can still create your own custom classes in C# that are not going to be attached to a game object.
Okay.
That have very specific functionality, and your game objects may interface with those classes for one reason or the other. And I actually have planned, and it's just a matter of time, redoing this simple game with a different structure, a structure that follows a few design patterns. And with that, you're going to see some very interesting things. And again, that's just time, depending on time. So anyways, inside here, what I'm going to do, let's look down to overridable functions. I guess I got to select from right to left. There we go. So functions that I can override. So these guys, once again, are all kind of hooked into Unity. So Unity is going to make sure these guys get called at the appropriate time. But there we go, update. So update has now been checked off the list. He's no longer magical. Update's called every frame, just like it said back in the comments. If the mono behavior is enabled, okay? We're going to get into enabling and disabling a little bit later on.
So keep it simple for now. It's just something that gets updated.
It is. When we apply this, it is enabled until we go in there and disable it. So with this component enabled, update's getting called every frame. Now we have some other updates that we could put in there, but they're not there by default. Now start. That was the other magical function that just appeared and somehow knows to get called there at the beginning. Here we are. Start is called just before any of the update methods are called for the very first time.
Okay.
You have another one in here that I like to use often that's called awake. And awake is going to get called when the script instance is being loaded. So look at it like this. Awake gets called first, then start gets called right before that first update. And then you get
updates.
Your update every frame.
Gotcha.
We also have other things in there that we can take advantage of. So if you wanted to track a mouse coming over or exiting out, you can use on mouse enter, on mouse over, on mouse exit, down, etc. Very handy. Once again, for having Unity, which written in its native language, much faster than scripting language, having it make calls to this stuff as opposed to you tracking the mouse location and update every single frame. A lot slower. So as we scroll down, you'll see we do have quite a few functions that we have the ability to override.
But by default, we got our update function and we got a start function. Currently, they don't have any code in them.
That's right. We received those from mono behavior. So this did this to me earlier. Let's give it just a second and see whatever it's saving, doing, or I'm not sure. Let's let it finish real quick. And Yeah, for whatever reason. I have faith. Zach's over here shaking his head no. But I'm not 100% sure what the machine's doing at the moment. So, still do not have functionality back. And there we go. Yep, not 100% sure, but we have functionality back. Let's continue going.
All right, cool.
Okay, so now what I'd like to do is let's get some code in. Let's just take a look at how we would go about manipulating our player.
Okay.
So I'm going to, and I know those of you out there that are professional programmers or have been programming for some time are used to having your braces start right after the declaration or of the function itself.
Sure.
This just goes back to anything that I present in video format or when standing up lecturing in front of students. I always try to organize things like this. I just found that teaching, it helps. It helps keep things more organized.
Oh, it's funny. That's how you taught me to use Mel years ago, and it's still how I code to this day.
Oh, is it really? Yeah, it's weird because when I'm teaching but I'm coming off of a programming gig.
Yeah.
I have a hard time remembering to straighten these guys up. But so, anyways, I'm just doing that just to keep everything nice, organized, very linear when you're reading down the script.
Sure.
Okay, so in start. Let's start out by having our player, when we launch the game, I want to see the game begin and the player actually appear somewhere else. Okay. So right now, our player, as we know, is located at 0, 0, 0 in the world. So let's play with him for a second. So if we were to take a look, let's come over here. Actually, with him selected, let's just go ahead and frame up on him or focus up on him. So we can slide them left and right, and we can see down in our game panel that, we can see him move. So over here and maybe up here, that'd be a good place to have him start off at. So I'm just going to use a pen and jot some numbers down real quick. So let's say about -6 in X, and I'm looking right here, and about, about 5, we'll just say 5 in Y, okay? Now, let's zero him back out. So we know that we want him to start when the game starts. That's where we want him to actually begin.
Sure.
So how do we go about telling the script to do this? Well, first of all, what do we want to manipulate? We want to manipulate the transform component of this game object. So we've got to talk to the transform. Mm-hmm. Now, once we begin talking to the transform, we now need to step down because there's different elements of transform that we can talk to. We can talk to the position, we can talk to the rotation, and we can talk to the scale. I want to talk to the position. And then even more specifically, I want to talk to the X and I want to talk to the Y components. So let's go ahead, jump back over in here, and see how we would go about doing this. So first thing, I want to talk to transform. Look, transform, there it is. And yes, it is just that easy. Now I'm going to hit dot and let it finish typing out transform for me. And then here are all of the different things that I can now talk to up underneath transform. And as we said, the next thing is going to be the position. Okay. So there's position. Now, if we were to hit dot again, you'll notice we now have access to X, Y, and Z.
Gotcha.
And if you're working over inside of JavaScript, you can just say .x equals and give it a number. Mm-hmm. But transform.position is referencing a vector 3. Okay, a vector 3 contains a float, and a float. Those three floats are X, Y,
and Z.
That's right. So in this case, what we're wanting to do is we're wanting to create a new vector 3 object that we're going to reference. So instead of saying just .x, because I can't get away with that, I'm going to say we're going to make a new, and look at this. IntelliSense pops up and says, hey, you want a vector 3, don't you? Because it knows that that's what it's expecting.
Yeah.
So please keep in mind, Visual Studio is actually here to help you, and it's going to do a pretty good job of that.
Nice.
So, okay, vector 3, nice. Let's go ahead and open up, and now it's letting me know we've got 3 overloads for it. So we can come in here, we can just give it an X and a Y, or we can give it an X, Y, and a Z. So let me start out by positioning it where I just indicate it back over in the scene when we physically drug out. And if you guys recall, we said we were going to position it at -6 in X, 5 in Y, and you'll notice you can see which component I'm referencing. As I'm typing, it's making that particular component bold, comma, and now we've got Z. And for Z, I could just leave Z at 0. Or, Zach, tell me what you think I'm doing when I do this. If I come back in here and say transform.position.Z.
Setting it to whatever it is already?
You got it. That's very, very important. So in this case, let's just say that the Z location of our object was at a very specific place, and we didn't want to change that. So obviously, we wouldn't just type 0 here. And in our code, perhaps we didn't know where that location was based off of events that have occurred in the game. So by simply doing this, that is going to leave the Z property untouched.
And before anybody out there is like, well, this is an orthographic game, it's two-dimensional, why does Z even matter? You could use this for layering. Having one object that's further back from the camera than another will give you the ability to put one object literally on top of another from the player's perspective.
That's right. So this right here, this is how we simply go about assigning a new position to our object.
Okay.
What we're doing is we're assigning this new position in start. So when I hit play, when our game executes in the game panel, we should see our cube start at this position.
So no matter where it is, when we're actually sitting inside the editor, as soon as we hit play, it should jump to the upper left corner in this case.
Yep. So I just hit Control S to save, because we got to make sure we save before we jump back over here. So I've jumped back over. The compiler's done its thing. As a matter of fact, we even see a warning down here talking about line endings, difference between working with Mac OS X and Windows with a different line ending. Don't worry about that. That's something we can clean up later. In fact, Visual Studio will even ask you about cleaning up that as we progress forward. And that only occurred because we created the script originally in here, which used a template that had the line ending that is slightly different than what's expected over when working inside of Visual Studio with Windows.
Okay.
Don't even worry about it, all right? So now that we have our scripts applied, we have some code in the start, and if we click on player now, you can see everything's updated. We can actually see that code in here.
Yep.
If I hit play, watch what we get. Boom.
Nice.
As soon as the game began, that is where he's located. And if I was to come up here, select my player, he is at -6 by 5. Now, while I'm right here, let me point something else out too. And that is that you can manipulate these numbers in the inspector while your game is running. This is awesome. As you manipulate these numbers, you can see the effects that it will have on your game object. Nothing is being remembered, meaning the moment you hit stop on your game, everything resets back to what it was before you hit play.
Okay.
So that's very handy to be able to come in here and go, oh, let me try a different position, or let me try a different position over here. Oh, maybe I like that a little bit better.
Sure.
As soon as I hit stop, whatever this guy was at before you hit play is what he resets back to.
Oh, because at this point, start hasn't been called yet.
That's right. At this point, we're no longer playing a game. We're back in the editor, so we're back to what we were at before we hit play.
Okay.
Okay, so now that we have a quick example, let's jump back over here into Visual Studio, of how we can take our object and position it, it's time for us to move on to how do we go about manipulating it in regards to a user controlling, keyboard input, and that keyboard input in turn causes our guy to move. And that is what we're going to take a look at in the next video, only because I looked down and we've gone for almost half an hour. So this video has gotten pretty long. So let's try our best to keep things short. Wrap up here, because this was a good introduction to getting our first script created. And in the next video, we'll get that motion into place. So let's go wrap up this video, guys. See you in the next one. So in this video, we will continue with the creation of our player script. The goal of this video is to have a very simple system that is set up so that we take user input into account, meaning that when a user goes left or right with the keyboard, meaning the A or the D key, then our player on screen here, our little yellow cube, is going to move left and right.
Sure, we're adding some gameplay elements. Right now, it's not even a game.
That's right. So this is where things are going to become interesting, because we will be able to interact with our little yellow cube as a player ourselves. So right now, the only thing we do have in place is instructions that tell our cube to locate itself all the way up here in the corner when we hit play.
And here's a question
for you. Yeah,
here's a question. If you're creating a script like this on your own, do you really need to use scripting to tell your object where it needs to be when the game starts?
No, Unity is full of wonderful tools. Use those tools. I can come in here. I know I want this guy to start down here at the bottom. I'll just grab him, move him down, and that looks good to me.
Okay.
There we go. All I need to do is make sure that I come over here and take this line and remove it because I no longer want to tell my guy to jump to that location when start is called. So when I hit play. As a matter of fact, watch this. I don't want anything to happen as far as start goes, so I don't even need to override that function. So I can keep my script nice and clean by deleting that out. And then with that, I can hit save, not undo. I can hit Control S, not Control Z.
S and Z look a lot alike.
Yeah, they do, especially when you're not looking at the keyboard. Then I can jump back over here into Unity. Notice he's sitting down here on the floor where I physically positioned him. I can hit play. He doesn't go anywhere.
Gotcha.
He's exactly where I want him to start out at.
But the cool thing is, at this point, you've now seen the start function. So you now know that you can plug any kind of functionality you want into that, and it's going to take place at the very beginning of your game.
That's right. So now we need to get this guy to where he can move. So how do we go about doing that? Let's jump back over here. Well, in having him move, I need to give some sort of speed. I need to set a speed because is he going to move real slow left and right? Is he going to move super fast left and right?
Sure.
And the way I'm going to do this is I am going to define a public data member. So it's a variable, but it's a special kind of variable in such that it is a field or it is something that belongs to the instance of this class as a whole.
Okay.
And it is what allows someone who has instantiated this class to give the instance state. Okay, so a specific state by saying that this instance of player, this script, has a speed of 5. And then if we had another player that has the same script attached, we could say this guy has a speed of 7. So their states would be different.
Okay.
So again, this is going to be a public. You'll notice that I am defining this inside of class, but outside of my function. So up here at the top. So public, now next thing I need to specify is going to be the data type. So let's just do a float. So this allows us to enter numbers that also contain decimals. And let's give it a name. I'm going to call it player speed. And let's go ahead and just terminate that. Now, by making this guy public, something very interesting happens. Let's go ahead and save and jump back over here into Unity. And boom, he just popped up. So now if we locate our player script, player speed shows up. I can come over here and I can type in a number myself. So let's go ahead and put 5 in over there.
Oh, now that's cool.
This is very helpful because now while the game is running, I can come over here and adjust my speed and find a number that I like.
See, I was figuring you'd have to go in there and actually, now that you've established your variable, now you've got to instantiate it. And
well, the variable is going to he is instantiated in the sense that we've already taken the script and attached it to a player. So in this case, this is our instance copy, if you will.
Right.
So we've given it state by assigning 5 to it. Now we need to use it in some way because right now there's just a number 5 sitting out there.
It's just cool that you didn't have to plug that number in through code. You can do it within the interface.
Absolutely.
That's very wicked.
Well, it becomes, like I said a second ago, very helpful when you don't know for sure what the number is, and instead of having to jump back and forth between Unity, Visual Studio, Unity, Visual Studio, tweaking numbers out, you can just do it in the inspector.
Okay, hurry up. I want to see this.
You just want to see how this is going to play out, don't you?
Go.
Okay, so now what we need to do is we need to come up with an amount that we want to move, and we need to apply that to our game object. I'm going to jump down inside of update. Now, update is going to be run every frame, and every frame is a great place to check to see if the player is holding down, one key or the other. And notice how I paused and I said, when the player is holding down, well, what is considered down here? I mean, are we holding the A key? Are we holding the left arrow key? Or do I have a joystick in my hand and I'm holding the joystick over to the left? Check this out. This is going to become very important in a second. Jump back over here into Unity. Let's come away from our player for a second. Come up to Edit. Let's jump down into our project settings, and then from here, let's come over here to the Input Manager. So we select Input. Our inspector suddenly comes to life with new stuff. Let's open up our axis, jump down in here, horizontal, vertical, fire 1, 2, 3, jump, mouse X and Y, all the way down, and then you're going to see some of the stuff, the more common things, start repeating again.
Right.
What we can do in here is we can come in and we can start specifying what exactly will constitute the movement of something in a horizontal key or mouse button, and which one specifically. So as we come down and we open up Fire, positive button, left control. Up here, positive button, right. negative button, left.
Which would be arrow keys?
So if we're wanting to get, yes, a left or a right, that, well, in this case, we also have alternate. So yeah, so we can use arrows, or we can use the A and the D key for going, again, left and right. Negative meaning that when we get a value back, we're going to be going from 0 to 1 or 0 to -1. If I want to go left, now my character is positioned, I call him character, my player is positioned at 0 in X. Okay?
Sure.
So going left would be going negative.
Negative, right.
So my negative button, left, is going to be A, okay, my alternate negative, and my positive is going to be D, going to the right.
Threw me off. I was like, well, it kind of depends on which axis you're facing, doesn't it?
And then if we jump down here to the other horizontal, you'll notice we have joystick axis set up in here. Okay, so very cool in that we can come in here, and we can also, there's other things that can be specified that we're not going to discuss right now, but we have all of this flexibility that we can wrap up into a single word, horizontal. Later, you'll see that when you build your game, that this information in the input manager right here can be made available to a player so that a player can come in here and set what will be left and right motion, what, what's going to be jump, etc.
Sure.
But from our point of view, from a coding point of view, it is simply going to allow us to refer to these axes as just horizontal.
Gotcha.
Then a player could later go in and say horizontal is going to be the J and the L key for whatever reason.
So for the purposes of coding, it's all left very generic.
Yep.
And we can make it specific within the editor.
Absolutely.
Okay.
So that's what we want to take advantage of here. So to do that, let's jump back over here. Now, again, I'm going to, in the spirit of Casey Jones' great videos that he put together, I'm going to follow the exact same formatting for everything, again, so that people can see the differences between C# and JavaScript. Again, a lot of this you're going to find very, very similar, if not spot on. What I need to do is I'm going to create an amount to move. How much do we need to move in this frame? So let's go and do a float variable, and let's call this amount to move. So there's the local variable that I am creating inside of update. And now with amount to move, I need to determine how much do I want to move this guy here. So I need to move by his speed. Let's just play with stuff.
Sure.
So if I say move by player speed, I haven't done anything that takes into account any type of
direction.
Yeah. So I need to get that from somewhere. So what if I took player speed and I multiplied that by something? Like what if I did input? Yep, there's input available to us inside a little drop down. And then inside of that, I come down and now I want to turn around and get some information from an axis. Remember we saw when we went to the input manager, we had axis that we opened up, and then we saw all of the different ones available. So let's go ahead and say get axis, but look over here to the right. It says that, well, let's see if we can get that to pop back up. It's looking for a string axis name, and we saw it was called horizontal. So let's go ahead and say get axis, and then open this guy up. And there he is. He's looking for the string name. So string, let's go ahead and throw him in double quotes. And I'm going to call it horizontal. Let's close off the quotes. Let's close this off. And that information gets multiplied by our player speed, which we've set to 5 over in the inspector. So again, what we're getting here is going to be a value that runs between -1 and 1. So if we're going to the left, we're going to get -1. Going to the right, we get 1.
Now, is that a float value where it can go like halfway in between?
Oh, yeah.
So if you have like an analog stick?
Absolutely. If you have that joystick and you just barely bump it, you got it.
Okay.
So we have this. I would like to point something out, though, and that is right now we're using get axis. There's another one that we could use called get axis raw. The difference is get axis is going to filter out or smooth out the result that comes back. So if you were using an analog stick, just so that we get, so nothing's nice and jerky, everything's nice and smooth. And it's going to give you the feeling of having your player almost slide on ice, if you will, a little bit. But we're going to change this in a minute. I just want to talk about the two and then show you the other one, because to me that feels more like the standard arcade games that I play.
Okay.
So we'll do get axis. So we get this information, we multiply it by the player speed, and now it's stored in our variable amount to move. Now we need to use it. So where are we going to use it? I'm going to use it I'm going to use it to affect my player's position, but I'm going to use it differently than the way you guys saw a few minutes ago. A few minutes ago, you saw me manipulating the position of the player by using its transform.position property. Okay?
Right.
So we just jumped right into saying, this is where you're going to be. Now, what we're going to do is we are going to use a function that is available on transform called translate. This is a relative thing.
Yeah.
So it's going to cause us to translate from where we are based off the amount we feed in. Let me type it out. It'll make a lot more sense when you see it.
It already makes sense. I see where you're going because translating something suggests you're moving it, setting its position. Says I want it to be right here in this spot,
in absolute world space.
Yeah, and you can't really do that here because you're taking a value between -1 and 1, and you're multiplying it by a number like 5.
Right.
So it wouldn't move. It would just jump to this new location, and it would just sit there as long as you were holding the right arrow key. But by translating it and changing it over every single frame, relatively sliding it, now you're going to get motion.
You got it.
So I already see where you're going.
So if I come in here, once again, start typing out transform because I want to talk to the transform component, and then dot, now instead of position, I want to come into translate.
Gotcha.
Now, very important. Make sure, for those of you that are new to working with code, that you pay attention to what kind of an element is that we're dealing with. Is it a property that we're going to set? Is it a function that we need to pass information to? Because a few minutes ago, you saw how we could type transform.position equals, and in this case, it is a function where you'll say transform.translate, and then we'll do an opening parentheses because we now need to feed it information.
Right, this is not a property we're setting.
Exactly. So what we're going to do is we're simply going to tell it, now we're wanting to move what is going to be left and right. So I'm going to use a vector3.right, and we'll talk about that in just a second. I'm going to multiply that by amount to move. There we go.
Okay.
So amount to move contains if we need to move left or right. Then I'm turning around and I'm telling this guy to translate, but check this out. I'm telling him to translate. I'm using a vector3.right. So this is already set up for us. If we wanted to, we could visualize this as a new vector3, and since we know that left and right is x, and this is all based off of the direction that we're pointing by default when Unity starts up with the camera. Okay, so of course, if we start flipping things around, yes, you're going to end up with these meaning different things.
Right.
Okay, but if I said move 1, 0, 0, I'm telling this guy to translate in x, but relatively, I'm not having any effect on y or z.
Sure.
Okay, and if I put a -1 right here, I'm going to be going in the other direction. Well, amount is going to just contain our -1 to +1, and if we multiply -1 by 1, we're going to get a -1. So
Right.
we'll go the one way, and if we get a +1 multiplied by +1, we'll go the other way. So very clean way of representing our vector3. Okay, so with this setup, everything's looking good, but we're going to have a problem. Let's go back to the comment up here. Update is called once per frame. I'm going to be running at about 5,000 to 6,000 frames a second. Let's analyze what's going to happen here.
Yeah, you're going to take off like the speed of light.
Thank you. We're going to be moving. So let's go ahead and save this out. Let's jump back over here into our game, and let's see. We might want to position ourselves
really, really far away.
All right, that's pretty good to start out with. Let's go ahead and hit play. So now, if I was to hit the A or the D key, there's our guy. Now, I'm just like tapping, just barely tapping. But if I was to hold it, and let's get focused back to our game panel.
Goodbye.
Zoom. Oh, there he goes, way away, and zoom. He goes back the other way.
It's like probably faster than the screen can capture.
So that's a good point. So do we really want that to be the speed in which he's going to move? No.
Yes, we want people to be that leet when they play the game.
Now, of course, that means that somebody may think, oh, I need to select this guy and come back over here to my player speed, and yeah, let's change it to something like 0.1, and then let's manipulate it. So, ooh, look at that. Nice and smooth. No, we don't want to do that. What we want to do leave this guy at 5, and we want to define a speed in which this guy's going to move that will be consistent across all machines that are capable of playing your game. Because let's say that you happen to have a machine that is a generation behind mine, but it's still within specs for running the game.
Sure. You're going to be moving slower because you have a slower update.
Absolutely. So I might have 5,000 frames per second that I'm running at, and you might be running at 1,000 frames per second, but surely there's a way for us to come up with a consistent speed that we maintain. And there is, and it's actually very simple.
So it's like a way to bypass the speed of the processor? Is that what you're getting at?
No, it is a way in which we will be able to say, this is the amount that I want us to move over 1 second.
Okay.
So now notice how we've just decoupled ourselves from frame rate, and we're now discussing real time.
Gotcha.
And here's how we do it. I'm going to jump back over into Visual Studio, and I'm going to take and multiply my, so we take, so we've got our, well, let's just jump back up here to our amount to move. We've got our positive 1 or negative 1, multiplying that by our player speed. I'm going to multiply that by one more thing. So times, I'm going to use time dot delta time. Now what this does is this is going to basically be a number that when multiplied by this, we will then have a much smaller amount to move. But the fractional value that's used to multiply by this is a value that enables us to move this amount over 1 second.
So now you're basing it off of physical time, which you can't even have physical time. You're basing it off of time as opposed to CPU cycles.
That's right.
Number of seconds as opposed to...
you have a slower machine than I or a faster machine than I can still... I can still rest easy at night knowing that my player is still going to move that same distance over 1 second on both of our machines. So by simply putting this in, saving this out, jumping back over to Unity, you'll notice our player speed is still 5.
Yeah.
If I hit play, look at that.
So in a way, you kind of have bypassed the concept of CPU cycles, at least in terms of them affecting the motion of your player.
Right, because think about it. As let's say my frames per second start going faster or start going slower, that time dot delta time, it's adjusting.
Right.
So that I have a consistent amount that I'm guaranteed to move over 1 second.
Very nice.
So the other thing I want to point out before we wrap all of this up is that as I go left and right, you'll notice
a bit of smoothing.
You'll get that. That's that smoothing I was talking about. That doesn't really have that old arcade feel. I mean, not back in the 80s when I went to the arcade.
It was linear. That's not linear.
It would snap. It is wham.
Yeah.
So let's jump back in here, and let's just take a quick advantage of the get axis raw, so we don't have any of that smoothing in place, just so that we have seen both of the functions in action. So we'll go ahead and save. We'll jump back over in here and hit play. And so now when I hit left and right, look at that. So
gotcha. I see what it's getting at. It's kind of, without using raw, it's kind of a way to simulate an analog stick, because there's going to be that moment of time when you go from full right back up to the 0 position.
And depending on your speed in which you're doing it.
It's kind of providing that when you're tapping keys.
Here's the nice thing. Maybe I think that the speed I'm going right now is a little too slow, so without having to jump back over to code, I can come in here and I can make updates and see what I think feels good. Just as long as, don't forget, the number you put in here does not stay in there when you hit stop.
Right.
Man, I've had that burn me in the past where I've made adjustments to several things. I'm like, ooh, that's perfect. And hit stopped and then moved on. And then come back and hit play. I was like, why is it wrong? Oh, man, I did that while I was actually...
Change it while you're not running.
That's right. But it's an excellent way to test numbers. So if I now come back over here, ooh, yeah, nice and snappy. So I can get a good feel for that. So, all right. Let's see, how long have we been going? We've been going 20 minutes. And I know it's late at night. You want to play with a little bit of a challenge?
Sure.
All right. Put you on the spot here. What if I wanted him to rap? So he goes off and all of a sudden he pops back in on the other side.
Okay.
Or we go this way and suddenly he pops back in on the other side.
Talking some sort of an if statement?
Okay. I love it. So we're going to start out with an if statement. Zach's like, all right, this is absolutely no fair because this is not planned at all. What are you doing? All right. So,
this is not in the notes.
So the if, my notes contain the 2 lines we just typed. It's awesome. So if statement. Actually, you know what? We could come in here. Good habit for you guys out there that are new to coding to get into is throw comments in. So single line comment, 2 slashes, and I can just say amount to move. And then I could come over here and jump in and say move the player. Now I could say
Wrapping.
check. Okay, we can just say wrap. That's what Zach said. Zach's in charge now. All right, Zach.
Now, I'm not much with syntax on
no
programming.
worries. It's all good. We're all just here to have fun.
But it seems like if the game is actually centered up right on the center axis, so the middle of the screen is 0. If you slide all the way off the screen, as soon as that happens, you could say if your position is greater than this value, couldn't you just multiply it by a negative value to snap him over to the other side?
Okay. Well, let's play with this. First thing I would do would be to come over here and physically
get that location,
get that number.
Yeah.
Now we can do this mathematically because it's an orthographic camera, and there's a very simple equation that we can use to extract pixel-wise what will be our left and right bounds of the screen. Something we can play with a little bit later because I think it goes kind of outside the scope of super simple videos.
Sure.
But let's push them over. So about right. So that's got negative 7.4. I'm looking at the transform component in the inspector.
Yeah.
So let's just say negative 7.5. Let's go on the other side and make sure that's a positive.
7.5.
It is. So we're going to be using 7.5. That's our base. So let's go ahead and put him back at a nice little 0 value. So now that we have some numbers, you want me to say if. Well, if what?
If our X position...
Okay, so we would say transform dot position dot X. So now we're looking at that particular element.
Now, what we want to know is if it's greater than... Well, I mean, okay, technically speaking, just in math terms, I want to know if it's 7.5 units away from 0. To the left or the right.
Okay.
I mean, you could do that with two ifs or like an FLs to check in both directions.
Yeah, let's keep it simple. Let's do that.
Okay. Then you could say if it's gretter than 7.5, is that the number we chose?
Just since I was dragging left, let's just go with if it's less than or equal to negative 7.5. And I'm going to put an F in there to denote that this is a float. Okay, just so that doesn't see it as a double.
Now we want to assign a new position to it, which will be taking the original position and multiplying it by negative 1.
Okay, so transform.position is...
times equals, can you do that?
Okay, well, we want to do a new vector 3.
All right.
And in this case, I want to keep things very simple.
Yeah.
So I'm actually going to, since we're using a... I'm using less than or equal to.
Sure.
So I'm actually going to put it right inside. I could take the equals out and do the multiplication, but I want to keep everything just black and white for those that are watching that may be completely new. So what if I said move him to 7.4? So that would be just inside.
Right.
On the right hand
so you could just see a
side.
sliver of it.
So, which would look good because you should see that sliver because he's just sliding back on.
Right.
So if we did that, now what would I want to come over here and put for my Y and my Z value?
Whatever they're already there. So
whatever they're already that you talking.
You know,
like me.
yeah. You're rubbing off on me. So
so
transform.position.Y and .Z.
Absolutely, good job. So we'll throw those guys in there, and then we can say else if. Now again, get transform.position.X is...
And you just go in the other way, so this would be greater than or equal to
7.5
right.
F. So if that's the case, and then once again, all right,
just copy that
too
line
much
of
typing.
Code. Yeah.
Copy this line of code and paste that line of code. And let's just jump over here and say now he's going to be a negative 7.4 just to pull us right on the inside. And again, we could definitely do the multiplication.
Sure.
But it's a lot of extra stuff to type in.
Sure.
Keeping it simple.
Now, I'm not suggesting we do this. We'll keep it very simple. I just want to kind of theorize with you.
Sure.
Is there a way you can pull the absolute value of the X position out so you can just say if the absolute value of the X position is greater than 7.5? So you don't have to have two different ifs. Because really, in the end...
Well, you could just have one if and put an or in here.
Okay, all right.
And such as that.
Yeah.
And then put the other check.
Yeah.
And then and take the equals out of both of them and then do the multiply it by negative 1.
Sure.
And then you could simplify it down. So now that we have this in place, you looking at it, you happy?
So far, yeah.
Okay, so we'll go ahead and save it. And let's see if we have some wrapping ability. So we'll simply hit play. So we're moving back and forth. Let's hit stop real quick and bump up our speed. I like the faster speed. All right, now let's see. Looking good. All right, you ready? Huh?
Ready.
Ready.
What do you got? What do you got?
Huh?
Oh, there we go. Looks like we have wrapping.
So it looks like we just have natural wrapping.
Nice.
Good job, Zach.
Cool.
Outstanding. So, and the key thing here, look how easy it was.
It's very easy.
Very simple. So now we have the ability to interact with our player in the scene. Any questions?
No, I think I'm good to go here.
Okay. Well, with that is going to wrap up this video. I believe coming up soon, actually, I have no notes about what video is coming up soon. Sometime very soon, I think it's even in the next video, we are going to start on the projectile so that our player has the ability to fire.
You'll see when we get to the next video.
So that wraps up this video. Thanks, guys. Okay, so we're going to pull ourselves away from the player. Mm-hmm. We were right in the last video. We were going to be taking a look at the projectile. So starting out, in this video, all we're going to do is get our game object set up. We're going to get the script started, and the script is going to have the code in it just to make it move up the screen and to make sure that it is destroyed once it gets off the screen.
Okay.
Because there's no reason for that object to continue living.
But it won't be firing from the position of the player.
No, it will not be firing from the position of the player yet. Okay, so that is our goal. So let's go ahead and get started. First thing that I'd like to do is to create my game object. In this case, what we're going to do is create a capsule to use. So we'll come back up here to game object, come down to create other, and then from there, just jump down to capsule. Now, from the capsule, first thing I want to do over here in the inspector is set a name. So, projectile.
You should leave it just like that. We have a block that shoots Tylenols at the enemy.
That's what it looks like. So we've got projectile in there. Position 000 is great. Scale, well, like you said, it's a giant Tylenol. Let's go ahead and bring this guy down in size to something like 0.2. So I'm just going to just jump across real quick. Now we have a laser.
Okay.
0.2. Now we have a teeny little guy, and I'll go ahead and keep things consistent with Z as well.
Oh, it's a little Tylenol.
So now we have a little bitty guy. The next thing I'd like to do is to create a material to apply to this game object. So again,
as long as it's not half red and half white.
Over here in the materials folder, I'll just right click on it, create, and then come down once again to material. And then let's give a name. So we'll simply click, do M underscore and projectile, like such. And let's go ahead and set our main color. For now, let's just do green.
Okay.
So, oh, I don't like that green. There we go. That's nice and bright. So we've got green, and all we need is to make sure that this guy gets applied. So, as we've seen before, we could simply click, drag, and drop him up here on projectile, or we can just activate projectile and then come over here and grab our M projectile and just come over here and replace our guy. There he is, green. So the default diffuse, bye-bye. New guy is now in play.
And now our player is obviously a bad guy because the bad guys shoot the green lasers.
Do they now?
They do. You saw Star Wars.
They're not purple? Oh, yeah, good point. I'm thinking lightsabers. Mm-hmm. So moving right along. You saw nothing. Okay, so we've got a material set. Now it is time to apply a rigid body. Collisions are going to be a very important thing in this game, and they are in most games, most action games anyways. So when this projectile collides with an enemy, we would like for the enemy to, well, explode. That's kind of good.
Yeah.
But we need for the collision to occur, and somehow we need to have a section of code get triggered when we have that collision between a projectile and an enemy. Mm-hmm. Okay, so in order to take advantage of is trigger, which happens to be on a collider, there's a few things that we're going to need. We're going to need rigid body on at least one of the objects that are involved. We're going to need colliders on each of the objects that are involved. And we're going to need one of these guys to be set to is trigger, maybe both if you want to get called in both objects about the collision.
Sure.
And we're going to focus on this a lot more when we get into the collisions later. But right now, what I'm wanting to do is just kind of point out why I am about to add a rigid body. It's just a requirement, having at least one when we're wanting two objects to collide, in the sense that we're going to be using the is trigger. Mm-hmm. Now, let me stop right there because you're still giving me a confused look. And that's great.
You're good. But go ahead.
We can take advantage of the physics the physics engine here with Unity. Mm-hmm. We can have two things collide and bounce off of one another, etc. We can also take advantage of this system to call a function for us, one that we can override, that lets us know we just collided with somebody.
A collision event, if you will.
Kind of like a collision event. And we can also tell the physics system not to manipulate our geometry because of the collision. Let us do it in code.
Okay.
To do this, what I need to do is add a component to my projectile. So the component I'm going to add to this game object is going to be a rigid body, because I need to have at least one rigid body involved in a collision. So what I'm going to do is come up to component, come down to physics, and then from over here I'll simply select rigid body. With my projectile selected, you'll see that a rigid body has now been added to my game object.
Gotcha. So that's just giving us access to collisions.
So yes, this is really going to facilitate the trigger working properly.
I gotcha.
And what I mean by trigger is we are taking advantage of the isTrigger property over here on the collider. So when we create an enemy, he's going to have a collider on him. He's not going to have a rigid body. We've created this guy. He had a collider by default. And even our player has a collider on him by default. But what they didn't have was a rigid body. For two things to be able to collide and for us to get that callback, at least one has to have a rigid body.
So in this case, the projectile is kind of the catalyst.
So that's right. So he's got the rigid body on him. Okay. So the next thing that I want to do is come over here to the rigid body and say use gravity. No.
Yeah, because you say rigid body, and just because I come from the 3D background, I immediately think of stuff falling and bouncing on the floor.
Gotcha. And we can very easily pull that off with Unity.
Gotcha.
And that's not what we're looking for right now. So we're not going to use gravity. The next thing that we're going to do is we're going to check is kinematic. This is very important. The reason we're checking is kinematic is because we want to make sure that our script is able to influence this guy.
Yeah.
Okay. We don't want for the we don't want for the physics engine to calculate any sort of interaction between two colliding objects.
We want to tell it where to go, not let it be simulated.
Exactly. Okay, so we won't control, so we're simply just going to check that to make sure that there is no external force calculations or anything that's going to be calculated by the physics engine. So now that's not going to happen. And that's pretty much all I wanted to set up there. And now the next thing we need to do is move on to the script. And again, if any of you out there watching feel a little confused about the collision stuff, don't worry. All we've done is added a rigid body. Soon we're going to come back in when we actually have an enemy to collide with, and I'm going to make everything clear. I'm going to point everything out once again and talk about what is required to make this happen. Now, let's get a script on here. So for the script, what I'm going to do is simply, I could add a new script here, or I can come over here. Now, this is cheating. This is awful. I've already created a template that I can use.
Cheater.
So, okay, I won't cheat then. But I'm going to show you guys how to create a template later so you can do exactly what I'm doing right here.
Cheaters never prosper.
So let's come over to scripts. Thanks, Zach. You're keeping me in line. So on scripts, I'm going to right-click, and we're going to create a new, once again, C# script.
Did you lose your material, or am I going colorblind?
Oh, we sure did. We need to set that color again.
Okay.
Let's go ahead and set this guy to a projectile, the name. Okay. So we've got projectile in there. Let's come back up here real quick to our projectile and come down to our material and set that color back to nice and
Imperial laser green.
Yeah, there we go. Almost. Not feeling Star Wars enough yet. Oh, I am now. Okay. So we've got the color set. So we've got this guy. Let's come over here real quick and take a look at Visual Studio. It's noticed that there has been a modification outside of the environment. And do we want to reload? And I'm just going to tell it to go ahead and reload. One, you're going to see that the projectile.cs file now shows up here in our solution. Number two, here we are talking about the inconsistent line endings. Remember I said earlier that that's a warning that we saw because of the way that the file is created when you do it inside of Unity versus the way it's done when you create a new script inside of Visual Studio, Windows-based file creation. You'll notice right here that this is talking about the player CS file. So I'm just going to tell it, yeah, let's go ahead and fix stuff. Everything's happy. Now, we've got our projectile over here. I also have an asterisk up here on our player, so let's go ahead and save that guy out. Come over to our projectile, so I'll double-click it. Now, what do we want to do here? First thing, do you remember?
We need to set a position.
Position. Even before that.
Even before that. Oh, we need to change our name.
You got it. We need to make sure that our class name matches the actual file name.
And to go back through all the things we did.
All right. It's amazing we're still going, and here it is, very late in the morning. Okay, so projectile, inheriting from mono behavior. We have a start and update being provided by the template. We can go ahead and jump back over here real quick. Let's make sure we save that, though, because, again, you can see it's not been saved. So we'll save it. We'll jump back over. No warnings. Notice how everything's been cleaned up, which is real nice in regards to that end of line vector. So let's go ahead and take projectile, drag and drop it up here on projectile. So when you click on projectile, you can see that we now have the projectile script added as a component. Now let's jump back down. Next thing I'm going to be interested in doing is setting up a projectile speed data member, because I'm not sure what kind of speed I want at the moment. So again, I'm going to make this public. If I make it private, it's not going to show up over in the inspector.
Okay, that makes sense.
Just make him public, and then let's give this guy a data type of float and call him projectile speed. And we'll go ahead and save this guy out. So once again, as soon as I select back over here, compiles, and you can see projectile speed gets added in.
Actually watched it pop in.
I have no idea what kind of speed I want. Let's maybe start out with 10, but that's a nice thing. We can adjust this. So let's go ahead, coming back over here. So now that we just saved out our projectile file, this is one will need to be cleaned up later by Visual Studio, because you can see the inconsistent ending. But I'm pointing it out.
Yeah.
Don't worry about it. All right. Just in case anyone's watching going, but you got a warning. All right. So now that we have speed, let's get this guy moving, but the direction he wants to move is up. So we're going to be moving up in the Y axis.
Positive Y.
So we're moving up in positive Y, as you can see over here. So all we need to do is, well, the exact same thing that we did over in the player script, and that is come in here, figure up an amount to move, and then simply translate the guy up instead of left and right.
Okay.
So simple enough. Again, we're just going to do a local variable inside of update, which is going to get called every single frame, and we'll call it the same thing, amount to move. And we'll say that amount to move is equal to projectile speed times, and we better put this in because we know we're going to need it, time dot delta time.
Yeah, notice this time we're not taking in any inputs from the player.
Nah, we don't need to.
Because this is going to be propelled on its own. It's not like you're actually using the joystick to move your laser around.
That'd be cool.
That'd be a cool weapon, though.
Yes, it would. So now we've got that in. All we need to do is call on transform on the function translate. And what do we want to translate? Now, of course, we could again apply a new vector3, or we could just use one that has already been set up for us, which is in this case vector3 dot up. And we can take dot up and multiply that by amount to move,
which in this case will always be positive.
Which is going to always be positive. You are absolutely right. So with that, let's hit save. Now this right here, since we've already got our script applied to our projectile, the moment we hit play, this is going to kick into action.
It's just going to fly away.
So it's just going to fly away. So let's come back over here and check it out. Hit play.
Goodbye.
Hey, we got a projectile that's moving.
Yeah.
But the problem we have, as I position our scene to watch, is we have a projectile that moves and moves
and never goes away.
And he never goes away.
Now that means it's still going to be calculated by the engine, even though we don't see it.
He's still being calculated. Not good.
Yeah.
So what if we were to first focus up on him? Let's back away a little bit. What if we were to destroy him the moment he went off screen?
Another if statement?
So, yeah, sounds good to me. So let's just, again, we're taking the black and white approach, keeping everything simple. So instead of using any type of special formula for calculating the top of the screen, let's just simply drag this guy up and see what we consider the top of the screen. So back out a little bit.
Something like a couple of pixels beyond the visible range.
You got it. So looking over here, so there we go, kind of sliding off about right there. So we can say 6.4 looks good to me.
Sure.
So if he's at 6.4 or greater,
destroy him.
Yeah, we want to destroy him. So just move this guy on back down, just so I have some room for him to move up. Jump back over here. And as you said, we're going to do an if statement. So we're going to say if. Now, again, we are the script. We are attached to the game object. we want to refer to a component on that game object, transform. Now, I haven't said this before, but this is something that you're going to see me using a lot. Notice how I've been just starting out by typing transform like such? I could have started out by doing this, game object. So now what we're doing is we're saying this being the script, the projectile script, that is actually attached to the game object. Okay, so us, game object, that's the guy we're attached to. Then I could work my way back down. Let's go to transform and then go on from there. And this code would work beautifully.
Right.
But since there is no other transform component available anywhere, I can simply just say transform.
I gotcha.
Very helpful. I just wanted to point that out because we will have to refer to game object from time to time. But game object will immediately tell us, hey, this is the guy we're attached to.
Right.
We didn't do it. It's him. So here we are, transform. So now, what do we want to do? If transforms position dot, well, which way are we checking? Y. And we said if he's greater than, not question mark, greater than or equal to, I'll just say greater than. What did we say? Remember the number?
6.4.
6.4, absolutely. So 6.4, throw an F in there to indicate we're talking about a float. So if it's greater than 6.4, then what do we want to do? We want to destroy it. And destroy is functionality that's built into the Unity engine that since we have Unity engine as something that we're using here, we can just type it out. So let's try it. Destroy.
And it'll automatically know that it's this thing we're destroying as opposed to destroying something like the player.
Well, destroy wants to know the game object.
Okay.
So watch this. So destroy, and I'm going to say, well, there's a ton of ways to say it. I'm just going to say game object.
Okay. So can you say this?
Very good. Let's put that in there just because you said it. This dot game object. So it's me saying, hey, the script, us, our game object that we're attached to. So that's how you can read that.
Whatever this thing is that just went over 6.4.
So yeah, this being the projectile script dot the game object that we are attached to. So now if we were to go above 6.4, we're going to destroy ourselves. So let's save that. Let's come back over here. Let's position ourselves where hopefully we can see, and hit play. And
boom,
look at that.
Disappears.
He's gone, completely gone. And that's it. It's as simple as that. Now let's jump back over here, and again, just for educational purposes, let's go ahead and just bring this down to game object only, and save, play, and up, and boom. He's
Still
gone.
works just fine.
Still works just fine. And the other thing I wanted to demonstrate was, let's go ahead and say game object. Here, just to back up what I was saying about this allows me to gain access to the game object we are attached to. Save, play, boom.
Now, it doesn't matter in any way which ones of those you use? Or is there any efficiency concerns as to how you write that out?
Well, that's a very good question. Yes, there are, especially if you're coding for the iPhone. Right now, every time that we're looking at transform here, we're having to do a lookup to get this guy. There's a little bit of processing involved there. One of the things I do, especially when you're writing something for the iPhone and your processing power is so precious, every cycle means so much to you, is I will do the following. I can come up here and say I'm going to keep a private transform, and we're going to call this, I'll just call it my transform.
Sure. I already see where you're going.
Then in start, I would say my transform equals transform. Now, if I do this, now remember, start's going to get fired one time, right before the very first update's called. So we know that this will be good. We're guaranteed that. Now I can come down here and watch this. If instead of transform.translate, let's just kind of push this over to make my point. If I say my transform dot, it has everything available, including translate. And if I was to then come in here and just update that like such, nice and happy. Again, same thing right here. Instead of doing the lookup to the actual component, instead I say my transform dot position. Then this right here is actually, we're holding a reference already. So the moment this thing gets fired, moment start is hit, we do one lookup.
One store, store a value just once, right?
Yep. We find where that object is out in memory, and we hold a reference pointing straight to him. Now, every single time, 5,000 times a second or whatever it may be that we're hitting update, we're not having to look out into memory and look him up every time.
Right.
We know where he's at. So this right here, so what you said, you didn't realize what you were stumbling on. You actually said a really important thing if you're doing iPhone development.
Gotcha.
How important is this when you're doing development for, say, the PC or for the web? Nowhere near as important as working with the iPhone. But this is still an optimization that I would suggest doing.
So it's one of those things where, like, if you're doing it for a PC or for the web, you don't necessarily have to do it, but it's still a good idea.
It's still a good idea. It's still an optimization.
Yeah, and it's not like it's any less valid.
It's just you've just made the computer do less work.
Right, to do the same job.
Every single frame. Yeah, because you're now holding a reference pointing right to the guy.
Gotcha.
It's like if I wanted to go to a friend's house and I didn't know where he lived, so I have to go through the trouble of looking him up in a phone book and then MapQuest to get the directions out and then go there.
You still use MapQuest.
Or whatever. It's the first thing that came to mind. Google Maps.
There you go.
Yeah, I know what you're getting at. But every single time, let's say that I went to his house 1,000 times a day.
Yeah.
I went through looking him up every time.
Right.
Oh, wow, what a waste of resources. So anyways, with this in place, let's go ahead and save, come back over here and check and make sure our functionality is the same. Hit play, he goes up, and he vanished.
If you go to a friend's house that many times in a day, the cops are getting involved. You know that.
Yeah, probably so. Actually, that's a fact. So anyways, there you go. That is a quick demonstration of caching out our transform, our component. Now, is there anything else that I want for us to do in this video? I don't think so. I think we've accomplished what we set out to do.
And a little more.
And definitely more. The goal was simply to create a projectile, create a material, apply it to the projectile, give it some sort of color. From there, and again, we're just keeping everything standard, default. From there, we wanted to make sure that a rigid body had been applied as a component to our projectile game object, because this is going to become very important in triggering that collision. And then from there, we wanted to go ahead and create the script, apply the script, and have the script do nothing more than make him move up the screen. But the key thing was make sure that he was destroyed if he moved off the screen.
Right.
Okay. So with that is going to wrap this video up. And in the next video, we're going to talk about prefabs for a minute. Thanks a lot, guys. Okay, now that we have I guess you could say the base foundation for our projectile in place, let's go ahead and get this guy firing from the ship.
Okay.
This is where things get interesting. This is where we're going to use our first prefab. See, we have an interesting problem. We would like for this projectile to come into existence in the game when the user presses the fire button, be it a joystick fire button or the space bar, etc. And we're just going to stick it to space bar. That'll work for this little simple example.
Okay.
But we would like for this guy to come into existence. Now, the nice thing is, the moment he comes into existence, he already has a script attached to him that's going to tell him to start traveling up the screen at a certain speed, and when he gets off the screen, to destroy himself. So how cool is that? All we got to do is say, hey, you, create. And then we can just forget about it. And he goes about doing his thing. That's really nice.
It's like simplifying the entire process down to fire laser.
You got it. And then you don't have to worry about it.
Gotcha.
But now how are we going to create this guy on the fly? Because right now, he exists as a game object in my hierarchy.
And only one of them exists.
And only one of them. But I need many of them to exist as I'm slamming away on the old space bar. So what I'm going to do is I'm going to turn this guy into a prefab. And you can instantiate prefabs on the fly. So prefabrication, prefab. Mm-hmm. What exactly is it? Well, it is, all right, I'm a programmer, so I like to describe it from a programming point of view. You can almost look at a prefab as a class, a complex class that's describing everything about this game object, meaning you can have scripts attached to it, you can have sounds attached to it, you can have everything attached to it. And once you get all of that set up, you can then package this up in a prefab, and that prefab can be instantiated on the fly, meaning that all of a sudden, bloop, he appears in the scene, and everything that's been set up on him is there.
So from a non-programming standpoint, it's really like a collection of assets that can be instantiated on the fly.
Yeah, it's a whole bunch of components that can all be put together on a game object, and you can take that game object and you can then package it up in a special format that's sitting there waiting to be called upon. See, I can't take my game objects and drag them down here to project.
Right.
That's a problem. So what I do is I put them in a prefab, and that can exist down here in the project, and then I can instantiate prefabs. So that's what we're going to do.
Okay.
So the very first thing that we'll need to do is to create a folder that we can keep our prefabs in. So I'm going to jump down here to my project panel and right-click, create, and folder. And then let's go ahead and single-click this guy and prefab. So with that, now to create the actual prefab, the way it's done is you first create your game object, put all your stuff on it. You don't even have to have them finished if you want to, because you can work directly with the prefab after you've created it, which is really nice. In this case, we've got pretty much everything on them. We're going to visit them again a little bit later, but we've got everything set up. So I'm going to come down here to prefabs, and I'm going to create an empty prefab, if you will. So I'm going to create a prefab, and I'm going to call this guy something like Projectile Prefab. Notice the color of him. He's a whitish color, right? This is indicating that he's basically empty at the moment. What I'm going to do is grab my projectile, drag the projectile down here on him, and when I do that, now you'll notice he's lit up, kind of a sky blue. You'll also notice up here that the color of my object back up in the hierarchy has changed to a blue color, indicating that this is an instance of a prefab.
Okay.
Meaning that if I take this guy and delete him, come down here to my projectile prefab and simply drag and drop him in, there he is again, as if nothing ever happened.
But what's the difference?
But if I hit play, he even works like normal and kills himself. If I wanted to, I could take this guy and I could say, let's move him over and down. Let's drag another projectile prefab in, and maybe over and up, and one more just for fun. And we'll leave him right there. Hit play, and ding, 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 ding. And there they all to go.
Watch him actually disappear out of the hierarchy view as well.
Absolutely. And boom, boom, boom. And you can see that they did not all delete at the exact same time because they all reached the bounds that we set up at different times.
Yeah.
So now we have the ability to create a bunch of them, but in code we need to be able to do it somehow.
Okay.
So we need to make our code aware of this prefab. So let's go ahead and delete these guys out. And what I'm going to do is come back over here to Visual Studio, and let's go ahead and reload and bring our projectile back up. And yeah, we'll let it clean things up. All right, so in here, first things first, I need to hold a reference to that prefab. I need to be aware of that prefab. So I'm going to come here up underneath my field for projectile speed, and I'm going to create another field that's going to be public. Now, the data type that I'm going to store here is going to be a game object. I'm going to store a game object, and I'm going to call this projectile prefab, like such. Let's go ahead and save. Now, this data type, so this first guy up here, the data type he's looking for is a numeric value that can have decimals in it.
Just a
float.
number.
This guy is looking for a game object. So by saving this, coming back over to Unity, and it compiles, when I turn around and select, actually in this particular case, the funny thing is, let me back up a second. You'll notice that I put this on the projectile. Projectile doesn't exist yet. He needs to go on the player.
Yeah.
Okay, this is just because it's 2:30 in the morning. Let's move that over.
That's a simple cut and paste.
So I'm going to cut, save, and let's open up the player.
I got really interested for
Paste.
a second. I was like, wait a minute. I saw where this was going a second ago.
Paste. We need somebody that's in the scene, that's in the hierarchy that already exists.
Absolutely.
So let me hit Control S, jump back over.
All right.
So I've just simply took it out of projectile, moved it over to player. So let's come back over.
Well, it makes sense. You want the player to be able to fire projectiles.
Absolutely. It needs to be on somebody that exists in the hierarchy that can then turn around and instantiate it.
Yeah.
So if I made somebody that's sitting down here aware of it, he's not in the game, so he's not going to have code executing.
Yeah.
So check this out. I've selected player. Look over here at the player script. So he has a player speed that's been set and a projectile prefab, none, but it is a type game object.
Too cool.
I can take my projectile prefab,
Just drag it in.
drag and drop.
Oh, that's too cool.
Now I'm aware of it. Okay. So now, actually, it's more than being aware of it, but let's just leave the language like that. I'm aware of it. So with that in place, now I can turn around, jump back over here, and instantiate this guy. But we only want to instantiate him in a particular case. And what is that case?
When we shoot our gun.
When we shoot our gun, absolutely.
It's funny, without even trying to earlier, you were setting up one of the coolest games ever. You were going to have lasers that could fire lasers.
Okay, we obviously want to put this inside of update.
Yeah.
So right now we're getting an amount to move. We're moving ourselves. We're checking to see if we need to do a wrap.
You've got to take in an input from the player. In this case, we're going to be listening out for something like spacebar, and when that happens, we're going to fire off some code that will instantiate our projectile.
Sounds good to me. So another if statement, and we'll say if. We'll talk to input again. We'll say, hey, input, let me know if there's a key down, because this time we're going to do it a little bit different. Instead of going after get access or get access raw, we can do get buttons, so we can get mouse buttons. We can also get keys, so we can check to see if there's my mouse buttons. We can check to see if a specific key has been pressed. Now, when dealing with keys, it's important to understand, and the mouse button as well, we have our get key down, get key up. So let's talk about these for a second. Get key down is just simply going to say yes or no to a particular key being down every time the frame runs. So let's say that spacebar is what we're looking for. If I did get key down, let's just do it, and then told it that we're going to be looking for spacebar, and then let's just go ahead and block this out, and we're going to do stuff here. Fire projectile. If I hold the space bar down, even if I hold it down for just a second.
Every single tick.
Every single frame. Update gets called. This will be yes. We'll instantiate another one. We've just made an awesome machine gun.
Serious auto fire.
So
it'd probably end up looking like just like a solid beam.
Yeah. Well, yeah, pretty much. You'll still be able to make out the projectiles, but yes. Watch this. Let's come over here and change this to get key down. Get key down gets triggered when the frame comes through. When the player first presses that key down, that frame says, yes, the key is down. Now, if I continue holding the space bar down and a fraction of a second later we come back into update again, get key down? No. The key is down, but the key was not pressed down that frame.
Yeah.
So that's what we're saying. So this only gets fired once. To get this to fire again, I have to let go of the space bar and then push it down again.
So it's kind of like a key state.
So
that gets reset when you let off the key again.
No, it gets fired the moment I press spacebar down. It's fired that one frame.
Yeah.
But then as I continue to hold the spacebar down, it's no longer set. It's set to true for one frame only.
Right.
Okay. So one frame only. We picked up the spacebar was down. All right. Check this out. All I need to do, instantiate. And we've got a couple overloads. Let's start with the simple one, which is just what's the object we want to instantiate. I want to instantiate my projectile prefab. So projectile prefab is a public data member of this player class. Over in the inspector, we have assigned a prefab to it, the key being the prefab being a game object. So we've assigned that to it. So now when I say instantiate,
make one.
We're holding the data. We need to make one.
It's time to make a laser.
This is going to make one. So with all of this in place, let's go ahead and hit save, jump back over and hit play. Now, hit spacebar. Whoa.
Cool.
Look like a laser. So I can go left and right. Looks like we have a problem.
Yeah, sort of.
He's coming into existence, and we can see deleting himself out. Outstanding. But the position's wrong. So let's go ahead and hit stop. Jump back over into code real quick. And now what I'd like to do is correct this positioning problem. We saw that instantiate gave us a couple of overloads. So let's jump back in here.
So I imagine one of those overloads is instantiate at some location.
Yep. You'll notice that up and down, the second overload allows me to specify my object, specify a position, and specify a rotation. Okay. I could also just use this very straightforward and do just the object, but then you'll notice this guy also returns an object back. So I could store a reference to the guy I just created, and then on the next line of code, position him. And since this will all happen before we get a visual update, then it'll all look right. But we can just do it on one line and no need to hold a local reference in this one iteration of the frame to that guy. So I'm going to instantiate, projectile, prefab, comma. Now, where at? Well, let's take us. We're at transform dot position. So that's where we're at. So let's put them there. Now for rotation, I could do transform dot local rotation. I'm thinking scale. Rotation, like such. But there is no rotation on our player.
Right.
Our player is not rotating. So one of the things we can do is we see that we have a quaternion as our rotation type. If we know that there is going to be absolutely no rotation whatsoever, we need to match the world or the parent which we're parented to in parent space, we could simply come in here and do a quaternion dot identity, like such. And that's basically saying there's no rotation on this guy. So that's all we're doing right there. So if we do this and hit save, jump back over and hit play, hit fire. First one looked good. He looks good.
Nice.
So now we start firing like crazy.
They're also not starting off just above the location of the block.
Now, well, actually, we do have an interesting problem
Are
there.
they?
Yeah.
Okay.
Well, they're starting off where they are here. Let's set this to 3. Let's pretend that was what we had left it at. So now if I hit play, watch what's happening. You'll notice he's not any higher, he's lower. He's at the position of this guy. So what we need to do is to move him up. Okay, so because right now we're saying use the position of our player.
It's going to end up feeling like a delay because it's coming from inside the block.
Yeah, very good. So what I'm getting at here is no matter what we set Y to, if we set it to 10, it doesn't matter. We're being created from the center of this, so we're not positioned where we would like to be positioned. We need to offset ourselves up some. So how would we go about doing that?
Do it in code. You want to add a few.
So
I don't know, whatever the thickness of our box is.
Okay, well, let's come over here. Well, the thickness of the box
half the thickness of the box.
Thickness of the box would be determined with in this particular case, let's look at our player. Just take a look at that and tell me, how would you determine the thickness?
Is it a scale?
Very good. 1.5. So we're looking at the scale. And you were just saying something about half.
Use half. Well, I mean, if the origin of our box is at the dead center, we don't actually need to offset by the total width. We need to offset by half that width.
Sounds good to me.
Which would be, what, 0.75?
Oh, let's not worry about specific numbers. How about we just write the code in such a way that no matter
take the scale and divide it by 2. Okay, so it's not hard-coded. That makes sense.
So I like that a whole lot better.
Yeah.
So all we need to do is come in here, and I'm going to get a new position of where I'd like to put this guy. So in order to do that, we need to go ahead and create now we could put all of this in one line of code, but it would get really big and messy. So let's keep this simple. So I'm going to do a vector3 local variable and just call it position and say this is equal to a new vector3. And now for x, we can just use our transform.position.x. And then for our y, now we need to take into account our y position of where we are as far as the box is concerned. So position.y.
And then add on
and then we need to
scale.
add to it our transform dot. Now in this case, we're not looking at position. We're looking at our local scale. And we need to take that in the y-axis, just in case for whatever reason he was scaled up and only y and maybe not x. We need to look at one of these guys anyways, but we are moving in y. And take that and divide it by 2.
Now, do you have to put that in parentheses or anything, or does order of operations take care of the problem for
In this case, order of operations are going to take care of it, multiplication, division, then we'll do our addition and subtraction. But I'll tell you, I
was only asking because I always put that kind of thing in parentheses.
It just, for readability's sake, your brain just well, for a lot of people, the brain processes it, just says, oh, I'll do that first, without even thinking about, order of operation or anything. So we'll set that up, and then let's save. And now, let's use it. Hang on, jump back over here. Because we've just taken and created this new vector 3.
Do we have Z yet?
We don't have to worry about Z,
okay,
because we have one of the overloads, for vector
is just
3
2.
And then that's all we're worried about.
Okay.
So in this particular case, we now have a local variable of type vector 3 containing a new piece of information. We need to use it, and we're using it in the Y location. So, or I'm not Y location, in the position part of the instantiate. So I just come in here and say position.
Okay.
So we're going to create this prefab at this location, which has already been offset, with 0 rotation. Save, jump back over, play, and now...
No delay.
Now no delay at all. Absolutely. You can see it. You can feel it. If you guys were playing this awesome game where we have screen wrapping thanks to Zach, you'd be like, wow, man, there is absolutely no delay. Look at all these guys getting deleted out. Now let's talk about that for just a second. For those of you that may be using the Unity engine for creating iPhone apps, something to think about. And that is the garbage collection of these objects that are being destroyed. And this is something we could take a look at in a later video series. It's actually very easy to do. It would be better to create a pool of projectiles that have already been instantiated the moment the game starts. You're not looking at any significant amount of memory. And then as they've been created, come up with a number that you simply could not exceed with how fast you can fire things.
Yeah.
And then as you're firing, you then position it and utilize it. It could be a matter of, making it visible, enabling it, moving it into whatever.
Yeah.
But the bottom line is this guy now needs to be marked, so you could have an internal private member that allows you to set that he's, in action or active at the moment. And then he goes off the screen. As soon as he goes off the screen, instead of destroying him, set him to inactive. And then you could also maintain a pointer, so you could have. And I'm just right now just talking off the cuff.
Yeah.
So you could have a list, an array that references all of these guys, and then you could have a pointer saying that, all right now we're on index number 0. As soon as you use him, that could advance to the next one. So when you go to instantiate the next one, it would simply say instantiate this object that's at index number 1. And then that guy would be marked to active. And then the pointer would auto-advance. And then when the pointer got to the end, it would come back around.
So what you're setting up in that case is a system where instead of creating and destroying projectiles, you have a set number of projectiles at all times.
Yeah, you're creating a pool.
And you're just going through that list. I always picture that circumstance as like a queue of people all waiting in line to go run to the end of the room and back. So like the guy at the head of the line, he runs to the end of the room, and then he runs and he gets back at the back of the line. And he waits for everybody else to run around. And then when everybody's running, it's now his turn, he's going to run again too.
Yep. And visually, it would look exactly the same. But behind the scenes, you don't have to worry about if you sit there and you start destroying hundreds or even thousands of objects as time goes on. You could run into some interesting problems with with Mono's garbage collection for objects that are being destroyed, because it's kind of a lazy collection thing where it's like, oh, okay, let's go ahead and collect. You can't predict exactly when.
Yeah.
Now, there's things you can do to
force it along,
to really help it along,
yeah.
Forcefully. But that kind of gets outside the scope of the video right now. Just keeping things simple. Just saying that destroying, this works well, but if you are looking at creating a game for the iPhone with Unity, then you would want to consider having something like a projectile pool, and that projectile pool would contain all of your projectiles instantiated at the very beginning or when the level loaded, whenever it may be, and then you just write a very simple system to utilize them, as Zach said, starting with the first guy, work your way all the way to the end, and then back to the beginning, and just keep working it like that. Anyways, so we've got this guy alive. We've got an offset that he's using. Anything else? I don't think there's anything else.
You're shooting a laser. I think that's what you came here to do.
I guess while we're in here, actually, no, we will need to stop to grab some audio files real quick, because now what we'd like to do is add some sound into this so that when we fire, we get a sound played of the pew, you know, the laser pew pew sound or something. So with that, that's going to wrap up this video. So next video is going to be real quick. We'll be back in just a minute. So in this video, we're going to wrap up our projectile prefab by getting some audio brought in and applying that audio to the prefab in such a way that when the prefab, the projectile in this case, is instantiated, it's going to make the sound. What sound is that, Zach?
Like a pew-pew.
Like a pew-pew sound.
Lasers.
That's right. Now, the creation of audio effects are outside the scope of this video series.
I was just bummed you didn't ask me to just like sample some myself.
Well, there's all sorts of ways that you can go about creating your own special effects. And, of course, there's a lot of places online in which you can download some free ones that have been created. If you take a look at Mr. Casey Jones's videos that he created showing how to put the same game together using JavaScript, he spends a few minutes talking about a really cool app that's been created by somebody on the internet that allows you to make those old 1980s style arcade sounds.
Oh, cool.
So if you'd like to take a look at his video, I'm not going to steal that away from him for the simple fact that he does an excellent job, and there's no reason to really repeat it here.
Sure.
But anyways, again, there's so many ways that you can go about getting your own audio. Now, getting the audio in is extremely simple. Let's keep everything organized. The first thing I want to do in my project is come down here and create a folder. Didn't see that coming, did you, Zach?
No, I didn't.
And then
let's call it audio.
Let's call it sounds.
Okay,
just because you stole audio away from me. All right.
Stole your thunder.
Now what I need to do is bring my WAV files in. So it's very simple. I'm going to grab a WAV file that I have off screen here and just drag and drop. Look, that easy. We've now imported it.
Yay.
And then I'm going to grab my laser sound and I'm going to bring it in as well. So just two standard WAV files. They've now been brought in. And as we've seen before, if we click on these audio clips over in the inspector, we get a preview window in which we can play and etc.
Okay.
So we've got this guy in. Very good. The next thing that we want to do is set up our prefab so that it will play this sound when the prefab is instantiated. So how do we go about doing that? Well, first of all, while the prefab is a special data template for this game object with a bunch of components that have been attached, in the end, we can still look at it as simply a game object. And with that being the case, I can continue working with it right here in my project panel as if it's just a regular game object. So with our projectile prefab selected, all I need to do is come up here to component, come down to audio, and what I'm going to do is I'm going to attach an audio source to it. And the audio source is going to allow us to assign a sound to the audio clip that the source will play.
Okay.
So let's go ahead and add this in. So we've now added in an audio source. You can see the component right here. Now, with this, let's bring our attention down here to the audio clip. None assigned at the moment, but we happen to have brought some in. So all I need to do is grab laser 1, drag and drop it over here. It's now set up, ready to go. And you'll notice our next property is play on awake. What this means is that when this prefab is instantiated, this sound will just automatically play.
Okay.
So very convenient.
We'll get a little laser sound.
So we'll get a little laser sound.
Anything else?
So, no. Did you believe that's pretty much it?
Wow.
See, off video, I told Zach that we were finally looking at a short video.
I didn't believe it.
Sure enough, here we are with a short video. Now I'm going to reach over and grab my headphones because I do not have audio being injected back into the sound system right now. But this will perhaps let us hear something. So if I hit play without changing anything else, we can hear it. So we now have audio being played every time we fire our projectile. And that audio
does sound like a very particular
pew pew sound.
Yeah.
Yeah, it does sound very familiar. Like an old 80s style arcade game. Let's just say that.
Yeah.
So what game comes to mind?
Galaga.
Galaga?
Yeah.
It sounds just like that. But the sound was created with one of these sound effects applications.
I got you.
There's so many of those online. But looking well. And also, just want to point this out, with our audio source being created as a component, of course, on the game object, if we take a look back here, you can, well, let's not jump up there. Let's bring our focus back down here. You can see when I fire out a projectile, you can see the audio source with a speaker on it.
Nice.
Okay? So, and in the future, we'll spend a little bit more time talking about some of the things we can do with audio sources. I mean, you can see right now with the properties, some of the standard things we can do. But we start talking about audio sources, you'll get to a point where you need to start talking about listeners. And then there's some interesting things that you can do. But we'll get to those things in some more advanced videos later. So that is going to wrap up this video. Coming up in the next video, we need to go ahead and start working with an enemy, because we need an enemy to destroy.
Sure.
And of course, when we start working with that enemy, we will need to create a script for it so that the enemy is, well, controlled. Now, to do that, I'm going to take a moment and show you guys how we can create a custom template in Visual Studio. So in the next video, we are going to take a quick break away so that we can do that.
Okay.
And then we'll pick things back up again with our game and continue on with the enemy. So that is going to wrap up this video. Thanks a lot. So in this video, we're going to take a quick break away from Unity, jump over into Visual Studio, and we're going to talk about setting up a template. The reason is we're coming up on the enemy, and with the enemy, of course, we're going to be creating a new script. I don't want for you guys that are following along using Visual Studio to have to continuously come into our project panel here, right-click, and create the script, because what's the problem, Zach?
We've had to do all this back and forth where we have to change the name of the class to match the name of the script.
So the name comes in as new mono behavior or new behavior or something like that, but you got to change it to the name of the class you want. But then you can't drag and drop because the class name needs to be changed. So then you got to jump over into Visual Studio. We can simply set up a template that we can use over in Visual Studio to add our scripts, and we no longer need to add them here.
Okay.
And as I had mentioned in an earlier video, as soon as we jump back over to Unity, Unity is going to see anything new that we've created externally that resides in any of these folders, and it will suddenly appear. So that's very convenient.
Gotcha.
So let's jump over here and take a second to look at what I do have set up right now, because, of course, since I use Unity for real, that means I do have templates that I use. So if I come up here to script, let's say that we were going to create the enemy. If I was to right-click, come over here to add, and say add a new item, and now it's going to come up and ask, all right, what do you want to create? Now look at this. It's already got one of my templates being shown down here in name.
But where'd that come from?
So let's scroll all the way down to my templates.
Okay.
So inside of my templates, I've got an editor script and I have a mono behavior script. So I'll just simply select mono behavior because that's what I'm looking to extend. And then I can select set a name. So please call it just enemy. Hit add, check it out. Enemy, extending mono behavior. We're using Unity Engine, and we have one of our functions set up. Now, this is how I like to work. It's as simple as I can get it. I have a good friend of mine, for those of you that frequent 3DBuzz all the time, you may know him, Mr. Chrono78, Lee, good guy. Now, he loves his regions, and I really like regions. Regions are things that you can set up that allow you to collapse entire sections of code. You'll notice that right out the gate right here, I can collapse some things, like I can collapse the class down, I can collapse my functions down. But, some people like to set up regions around their fields, their properties, and then all of their functions so they can just close those down.
Get them out of the way.
So, so what I'm going to do is I'm going to kind of take the extra step and talk about setting things up that way, though you guys have seen how I generally work with my templates, so you can decide however you want to set it up. Basically, whatever code you end up putting in the file that you're going to use to create your template will then be available anytime you create a new item based off that template.
So like some default framework.
Exactly. So first things first, let's take a look at what happens with enemy when I come back over here to Unity. Click, and look at that. It's like Unity was there all along.
Cool.
So now if I was to jump back over here and we decide we don't want an enemy no more, so we go ahead and delete it, it's going to ask us, are you sure? Because this is going to be permanently deleted. Let's go ahead and tell it OK. Jump back over. And now if we jump back over, it's like it was never there.
Nice.
Okay, so we can see that by working here inside of Visual Studio, adding and deleting things, Unity's going to keep up with you, which is excellent. Now, where do these templates reside? Let me drag one of my folders over here. You'll notice that we are inside my documents, Visual Studio 2008, up under templates, item templates, because we have two kinds of templates that we can create. We have item templates and we have project templates.
What's the difference between the two?
Well, a project template is setting up an entire project. Let's say that you create some sort of application. Let's say you need to create a bunch of them for whatever reason, and they start all pretty much at the same base, and then they have slight modifications. So you could go in and you can set an entire project up and then just go from there.
Gotcha.
And an item template would be, like in this particular case, where I'm wanting to do an item. I want to do a
single
class
part
file.
of a program.
Yeah. So from inside here, we can have things that are templates that are residing out here, meaning not in any of the folders, and then they're just going to show up everywhere. Or we can have things more specific and have those templates show up inside of one of the particular languages that we're using. So in this case, you'll notice there are the two templates that I have. So we have editor script and we have our mono behavior. Now, let's take these guys and just get them out of the way and watch what happens. So if I grab these guys, I'm just going to drag them to the other monitor. There we go. So they are now out of the folder. Let me just get this guy out of the way for a second. Come back over here. Let's try adding once again. So select scripts, right click, add, new item. It's no longer saying editor script 1 or mono behavior 1 because my template is now empty.
Gotcha.
Okay. So very simple to set one up. That's what we're going to do. We won't worry about dragging those other ones back in. I'll do that off video when we're done. So I'm going to create the file that I will be using to create my template. To do that, I'm just going to grab Projectile and do a Control-C, Control-V. And now with this guy, let's just come over here, and I'm going to give him a name. Let's call it Go. The name is completely irrelevant. Let's go ahead and double-click him to bring him in. Now, I'm going to change this guy to Go. Again, this is completely irrelevant. I could call it Jason if I wanted to, because when the template is saved out, there's some stuff that's going to get changed around, such as the code that ends up going here in the template, so that the template is smart enough to know that whatever name we give to the file is going to be the name used for the class.
And we've already seen this when you created your template earlier and named it enemy. As soon as we opened this up, it already said enemy at this point.
Absolutely. So irrelevant. Now the next thing, we need to make a decision. What things would we like to be in the file when it gets created from our template? So right now, we're building that up. So we get to decide what using statements do we want. Well, I know we want Unity Engine, and by default, back over in Unity, anytime that you create a C# script, they're always using system.collections. So we'll go ahead and leave that there. So this stays very similar to what they have. Now, of course, we don't need any of these data fields here, so I'm going to come in here and get those guys out. And we don't need any functionality inside of our functions. That'd be kind of strange. I mean, we could.
But this functionality is very specific to this object.
That's right. And for me, I'm just going to take these comments out. I know what start and update do. That kind of drive me crazy.
Now, you'd mentioned regions earlier.
Yes, absolutely. So we're going to set some up. I do want to point out that I am going to go ahead and leave start here because we do see start over inside the template that's used in Unity. So we're going to follow along with that. But again, for me, when I want code to appear in start, then I just go ahead and declare and use it right then.
Okay.
So in other words, I'm not always using start.
Right.
So let's set up some regions. So if I come in here and say pound region, and then give it a name like functions or methods.
I was going to say, are you going to use functions or methods?
And then come down here and do end region, like such. Look at that, automatically lined up with one another, and we can now collapse it. Here's what's nice about this. When I collapse it down, it just says functions. I generally don't throw a bunch of regions around things like fields, properties, and functions because, as a rule, I try to keep all of my classes small. The moment you have to start scrolling through a class, you really, in my opinion, you really need to sit down and think about everything that's in that class and make a decision on it. Is there a way that we can break it up? Because you really want to try to keep your classes small. And that's something that we will be talking about when we come back through in a more advanced video series and recreate this game yet again, but we're going to do it without the structure that we've been using right now. We're going to be using design patterns, etc.
Okay.
It's going to allow us to demonstrate a lot of really nice functionality in C# with just a very simple game. Okay, so we have that region set up in place, and let's go ahead. And I'm going to follow my good friend's Lee's setup. Let's go ahead and give the fields and the properties in case anyone else out there would like to do the same. So I'm trying to make Lee feel special here.
I see that.
So if we do region and go ahead and do fields. And again, we need to make sure that we have an end region. And then I'm going to come down and do the exact same thing for properties. So, and then let's make sure that we end them off. space that out a little bit. Now, if we want, close them. And you can see that's how things would look nice and neat. And it does help, and your code starts to get big. So there we go. We've got our infrastructure set up for our template. The first thing that I'm going to do is make sure that I save. So just go ahead and do a quick Control S. Now to create the template, there's a wizard we can use. It's very easy. All I need to do in Visual Studio is come up to File, come down to Export Template, and then from in here, first thing, let's make sure our solution gets saved. It's going to ask us, do we want to create a project template or do we want to create an item template? I'm going to go ahead and create an item template. And of course, it's going to be from the Project Simple game. So let's go ahead and jump over. And it says, all right, well, from Simple Game, this is what you have available. What item are you looking to export? Well, we're going to use our Go CS file. So let's go ahead and select that and jump over to Next. It's going to ask us about any references that we would like to include. We don't need any. Go over to Next. We're just creating a very simple file here. Next is going to be template name. What would we like to call this? I'm going to go ahead and call this, as you guys saw back there earlier when I was using one of my templates set up, I'm going to call this mono behavior. Such. Template description, we could just call it something like a game object script. Game object script. Script component, script object, doesn't matter.
Yeah, whatever you want to call it.
Output location. So where is this template going to be outputted outputted to?
Yeah.
So from exported templates, I can grab this and I can then go give it to somebody else. We're just going to leave everything here all defaults. Okay. So automatically import the template into Visual Studio and display an Explorer window. We don't need to do that because I've already got one open to the right. But I mean, for those of you that have not opened up an Explorer window, leave that checked. It'll automatically open it up for you, so you'll see your template. So with all of this in place, and we're going to, of course, use just default icon, let's just hit Finish. And with that being the case, let's drag my folder back over. So nothing in here. Let's step from Visual C# up to Item Templates.
And there it is.
And there it is.
Okay.
And if we were to step back further, a couple, all the way back up to Visual Studio, there's My Exported Templates. You'll also find it up under there as well. So let's go ahead and jump up, jump back down, and back into Item Templates. So we now have it. So let's go ahead and drag this guy out of the way. Now I'm going to take go.cs, let's delete them out. We no longer need them. So now let's try creating that enemy once again. So if I jump back over here into Unity, you'll notice no go, no enemy. Very good. Let's jump back into Visual Studio. So I'm going to come over here to Scripts, right-click, add a new item. Look at that, mono behavior, and there's my description, game object script. And if I scroll down, my templates, there it is. So you can come and create all sorts of templates. If you find yourself creating a particular file with a particular set of statements over and over and over that you apply to a lot of game objects, you may want to just go and turn it into a template and save some time.
So from now on, you'll be creating all of your game object scripts here inside of Visual Studio.
Pretty much.
You won't be making them inside of Unity because now you've alleviated having to jump back and forth.
Creating them over in Unity, one of two things are going to happen. One, after you create it and you know you've got to get everything fixed up, you need to make sure your solution is resynced, or if you come back over to Visual Studio, it's going to notice that there is a synchronization issue itself, and it's going to ask you, do you want to reload everything, and then it'll fix it. So doing it this way, much less hassle, and it's a lot cleaner as far as I'm concerned.
Okay.
So let's go ahead and give this guy a name like enemy, like such, and let's go ahead and add him. Let's see what we got. Well, look at that. Public class enemy extends mono behavior, and we've got fields that we can come in, we've got properties, and we've got functions. Very straightforward, very easy to use. As a matter of fact, seeing how in the next video we're going to be creating our enemy, we could go ahead and leave the script here and go from there.
Yeah, you'll be all ready when you jump to the next video.
Yeah. So any questions?
No.
You can see how this could definitely be a time saver.
Yeah, save you a lot of time as you move forward and have to create more game scripts using Unity.
That's right. Okay, so with that is going to wrap up this video. Thanks a lot. So in this video, we're going to be setting up our enemy. Now, if you happen to have skipped the last video where we demonstrated how to set up a template inside of Visual Studio, I just want to point out real quick that we wrapped the video up with the creation of the enemy script. So we already have it, just in case somebody skipped over the video.
Well, it's based on the template we put together.
That's right. And you'll see down here in scripts, of course, we have enemy. Now, let's go ahead and create our game object. So we're just going to, again, following Mr. Jones's example, we're just going to use a simple sphere. And again, we could say that this is stand-in geometry that later on we could easily swap out for our own model. So we're going to come up here to game object and come down to create other. From there, we can jump down to sphere. Number one thing we need to do, make sure that we rename them. So rename him enemy. Next thing, I'm going to go ahead and just center him in the world. And then for our scale, let's make him just a little bit larger. So we'll go with something like 1.3. Okay, that looks good. Next thing I'd like to do is set up a material that we can apply to him. So I'm going to come down here to materials. I'm going to right click, come down to create material. Let's go ahead and give this guy a name. Following our convention, it'll be m_enemy, like such. And for a color, I don't know. What do you think, Zach? We'll go with red.
Red generally means bad.
That generally means bad, absolutely. So we'll go with red. So now we have a color. Now let's go ahead and grab this and apply our enemy material to our enemy. Okay, so as you can see, everything's been applied, looking good. The next thing I'm going to be interested in is going to be his position, getting it all set up and then getting him in motion. Now he is going to be moving in the y-axis downward, and we would like for him to move from, random locations as he's moving down. So we're going to keep the AI simple. Actually, there is no AI. We're just going to pick a random location across the top, right out of the screen, and then we're simply going to let him move down. If he collides into the player, the player is going to die. If a projectile collides into him, then he's going to die. If he manages to make it off the screen, we're simply going to jump him back to the top.
If that happens, are you still going to spawn another enemy?
Well, that's just it. We're doing this in the cheapest way imaginable.
So you're not actually.
We're not really destroying him.
I gotcha.
In this case, when we say destroy, what that really means is quickly move him back to the top of the screen off the top, pick a new random location, a new random speed, and let him go down again.
Gotcha. So there really aren't multiple enemies. There's just going to be this one.
There's just one. Though you could set up a prefab. You could create an empty game object called an enemy spawner and then attach a script to that. And then in that script, you could instantiate these game objects, and you could have that guy responsible for what level are we on, or reading the level that we're on and determining how many enemies that we want to spawn over a certain amount of time. So it could say that, all right, we've made it up to level 20 and we want to spawn an enemy every 2 seconds, which means our screen would then be very populated with enemies all over the place. There's so many things you can do with Unity. It's very neat. But we're just going to work with just this one guy, no destruction.
Okay.
So with him, to do all of this stuff, of course, we're going to need to be working inside of our script. So let's jump over into Visual Studio, into our script for enemy. And I'm going to start out by creating a couple of public fields for the enemy that we can use to set up a speed. I don't want this guy just to have a steady speed every single time he's coming down. I think it would be a bit more interesting if we gave him a random speed every time.
So some enemies move faster than others.
Exactly. So if we wanted to, we could come up here into fields and start out by saying I want a public float, and we'll say that this is going to be a min speed, and then another public float, and this will be our max speed. We can hit save. If we jump back over here, it automatically compiles, and we have access to that information. So with enemy, we need, of course, to make sure that our script object has been applied to our game object. So we'll come down here and grab enemy, drag him up, drop, and then there we are with our minimum speed and a maximum speed. So if we go with, 4 to 6, and we can come in here and adjust that as we need. Let's jump back over. Now, what are we going to do with this speed? Well, we need to generate a current speed, if you will. So we'll grab a number within this range that we have defined, and then we need to hold that so the enemy can be using that speed as he travels down the screen. Then when he gets reset, he can generate a new random number and store that.
Right.
And the way that I'm going to do that is I'm going to set up another field. This guy, we can just keep him hidden. We can have a private float, and we can call this current speed, like such. Now, let's see. We'll just, all right, I'm trying to decide exactly how I want to go about this. Let's just stick with the speed stuff for now. So now that we have a minimum speed, a maximum speed, and a place to store a current speed, we need to generate a current speed. A great place to kick things off would be inside of our start function. We know that start gets fired one time, and that one time is right before the first update is hit inside this script object. So what I'm going to do is just come down here into start, and I'm going to say our current speed is going to be equal to. Now, we have a random object that we can use with Unity, which is very nice. So if I come in here and say, let's use a random, with random I can say a random range, and then the random range is going to take in a minimum and a maximum, and we have a min speed and a max speed.
Right, let's use our public variables.
You got it. So we can set those numbers over in our inspector, and then those number values are being respected inside our start function to randomly generate between those numbers a current speed. So now we have set up that speed. The next thing we need to do is apply that speed to our enemy. And we're going to do that inside of what function, Zach?
Our update.
In our update, absolutely. So we'll come down here to update. And I'm going to follow the same convention that we have used so far for both the player and projectile, and that is to create a local variable, so float amount to move. And amount to move is going to be equal to, we're going to do our current speed, time, since we need to make sure that we have this a consistent amount that's moved per second, so we just times it by, or multiply it by time.delta time. Okay, so now that we have that set up, we'll just turn around and use it by saying take the transform, dot translate, and then instead of going up, as the projectile did, we're now going down.
So you got negative y.
So in this particular case, all I need to do is a vector 3 dot down, and then I'm going to multiply that by our amount to move, like such. So if we save that, and jump back over into Unity and run this. Oh, and lovely, hang on. Let's set that back up again. Now when we run this, he is going to move down the screen. So let's hit play.
There you go.
And he's moving down the screen. And let's do this for just a few minutes. Let's take current speed. Let's make it public to make it show up over in the inspector, so we can see it, and we can basically prove to ourselves that we are indeed coming up with a random number between the range that we've given.
Right.
So public, though this is a case where this is a number that does not need to be accessed externally, and we would keep this private. So let's save this off and run again. So there we are. Current speed is at 0. When I hit play, 4.6. Let's stop it, play again. 4.8. Come on, give us something higher. 5.4, and we got something higher. Excellent.
Nice.
Very simple. Now, for our enemy, we want him to start we want him to start off screen, so he's going to need to be up here somewhere. So we could say perhaps maybe around 7. And then when he goes off screen, so if I was to take and move him over a little bit, when he goes off screen, I need for him to reset back up. There's a few things that we need to do. So for starters, just leave them right here. Let's set the code up just so that in start is going to position him off the screen in Y, and using what we've already seen with random range, let's go ahead and come up with a random location horizontally between here and over here. So that's going to be between what, about -6 and +6. Looking up there at, look at that. So position minus 5.9. Yeah, so -6, +6. So let's jump back over here. And again, using what we have seen so far, I'm going to come up under our current speed, and I'm going to create another field. This one will also be private. Now, let's always, at the moment, pretend that current speed is indeed private.
Sure.
So this guy is going to be a float, and I'm just going to set up an X, a Y, and a Z. Now what I'd like to do is jump down into Start, and in Start, we know what we would like Y to be. Y needs to be 7, as we demonstrated back over there. And I know I could just simply use a vector 3 with just an X and a Y. Let's just go ahead and spell everything out.
Okay.
Like I said earlier, keep it black and white. So we'll set Z as 0.0, so he's at 0. So X is the interesting one. We saw that X could be anywhere between a -6 and a +6, and we've already seen how we can go about using random. So let's just simply come in here and say X is going to be equal to random dot random range, and then we can say -6 and a +6, like such.
And you're specifying those as floats.
And we're specifying these as floats. I'm typing F's all over the place. Didn't have to do it here, but it's good practice anyways.
Yeah.
All right, so this will get him positioned properly, even though we know right now the starting location has him down here at the bottom. Am I right?
Well, it should be, because you've got it set up to where as soon as start takes place, he's going to be moved off screen, and then it's going to pick a random horizontal location. Or, well, most of the way. We haven't actually set up the transform for that yet.
Ah.
We've established 3 variables.
We've got 3 variables.
Yeah. So we've got the framework down. We just need to set up that initial transform.
So we need to somehow use this information. I almost got you to fall for it.
Almost.
All right, so how are we going to use the information?
We're going to do transform.position.
Okay, so we know that transform.position would definitely allow us to, position the guy. So let's just jump up underneath this and say, let's move him. Transform.position is going to be equal to a
new vector 3.
Very good. And then X,
Y, and Z. The 3 variables you set up.
Yep, we've set them up. We just
Now,
never used them.
Just for proof of concept, granted, if everything works right, we should be able to see that ball pop up in a new horizontal location. Do you want to make that private variable public just so you can see the number while we're testing?
In this case, we will see it just by the fact that he's going to move around. So that one we don't have to.
Okay.
Let's say that he does indeed move. So hit play, and look at that. He's right there. Okay, same location.
There's a new
different location. Another location.
Nice.
And every time he's starting off the screen, scrolling on to the screen.
Actually, at this point, you could probably take that variable that you made public and go ahead and make it private again. Because we've already established that it's working.
So let's do that. So we'll come back up here. When we get into the advanced topics in a later video set that's redoing this game, you'll have to listen to me talk about nothing is public. Everything is always private. So very important. We don't want to destroy the idea of object orientation and data encapsulation. So moving on. So now we've got these guys set up. We're using them. The next thing that we need to do, as we said a few minutes ago, was monitor his Y position in space, and the moment he goes off the screen, make sure he resets back to the top. So in order to do that, let's first just jump back here. Since at the moment we're not doing anything fancy to determine what our screen bounds are, and let's just do this by hand. So again, we're traveling in Y, and as he's moving down, 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 and goes right off the screen, I'm looking over here, and I'm seeing a -5.3, so I think we can get away with, we can get away with -5. So when he is less than or equal to -5, then we want to make sure that we jump him back up. So in update, after we've moved him, then we want to do an if statement. So I'm going to say if our transform.position.y is less than or equal to
-5.
a -5. Well, if that is indeed the case, let's go ahead and block this in. What do I want to do? Well, I want to generate a new current speed. I need to generate a new X. I do not need to generate a new Y and a new Z. Remember, these guys are fields, so their state has been set. So I don't need to set them up again, but the current speed and X, those two guys do change. So I can just grab these two guys, copy, come all the way down here and paste. There we go. Now, once again, we need to make sure that we use this. So we just grab this guy right here and position him. And let's save, and let's look at the code. So every single frame we're coming through, we're grabbing an amount to move based off of a current speed, which stays consistent until, so this value does not change until we hit a state in which we are being reset back to the top. Okay, so we come in here and we get that. We move our guy down. After the guy's been moved down for the frame, we then check his Y position. If it's less than or equal to -5, we're going to generate a new current speed between whatever has been set as min and max over in our inspector. Then we're going to turn around and we're going to grab a new random range between -6 and +6, and then we assign the position. Now, just in case anyone out there is a little bit confused and says, wait, but how do you make him jump back up to the top? I mean, because his Y's got to go back up. We never did anything with Y. Y is just holding a value for us. It's 7, and we are reusing that 7 right here. So that's going to cause him to jump back up.
It's still being stored. We haven't changed it.
Absolutely. So with this bit of logic set up, let's hit save, jump back over, and let's go ahead and execute. So he's going down, and he's reset.
Nice.
And now he's just jumping all around. And the nice thing is, while we're playing, we can say, let's try maybe speeds of 6 to 20. So, whoa, nice, a little bit slower. Whoa, a little bit slower.
Really fast. Will be really fast.
So now we can really see the whole random thing kicking in. And if we wanted to, we could store a level. We could say, you know, every X number of ships.
Speed things up a little bit.
We could, or how about this? Even if we didn't do a level, here's a very simple thing that we could implement. Every single ship that gets destroyed, as soon as it gets destroyed through code, make your min speed and max speed both go up by like 0.2.
Yeah.
So as you're hitting more and more, he's getting faster and faster and faster.
Right.
So the game becomes more difficult. Maybe we'll do that later. Very simple stuff. Now, keep in mind, I have made these adjustments while the game was playing, which means the moment I stop the game, it will revert back to what it was before we hit play. That's all we needed to do for this particular video. Now, I'll be honest with you. I have something going on right here that I'm not a big fan of.
Well, it seems like the establishment of your speed and your position could all be put inside of a single function.
Absolutely. We've got some repetitive code in here, and the code needs to stay the same. So a little bit of code up here and this code right here, and then we have the same code down here. So this could be centralized. In the next video, we'll take just a few minutes and we'll talk about that. So with that is going to wrap this video up. Thanks a lot. Okay, so at the end of the last video, we had everything set up with our enemy, such that the enemy would cruise down the screen, and when he got to the bottom, he would then come up with a new random location at the top, jump back up, and a new random speed, and come down once again. And it would just keep repeating that cycle over and over. But the problem that we had with our code is that we have some repetitive lines in there, and that's not good. And it's not good because let's say that I came in here and for whatever reason, I needed to change one of these values right here. The -6 suddenly needed to become -12 or whatever.
Right.
And I forgot to change it down here.
Right. You'd have to cycle all the way through your code and find every place you used that.
That's
and
right.
Change them all.
It's very easy right now because, one, we're the designer of this class, and number two, it all fits pretty much in this one small area inside of Visual Studio. What happens if we have a very large class or even a class that's broke up against multiple files? It would be very easy to forget that you actually have code that's been repeated, and it's ideal not to do that.
Right.
So in this video, we're just going to take a minute, come in there, and kind of centralize some of this code. And so to do that, I'm going to come up with my own custom function. I'm going to create a function that, first of all, is going to have a void return type. He's not responsible for returning anything whatsoever. I'm going to give it a descriptive name. In this case, what are we doing? We are coming up with and setting a speed, and we're coming up and we're setting a position. So let's go ahead and call it set position and speed.
That's very descriptive.
Thank you.
Good work.
And then we'll go ahead and block this guy in. I would like to point out that if you are using your regions, you know, it's very good to make sure that you respect them and keep your code inside the region so that when you collapse them, everything gets collapsed. I didn't in this particular case, want to put this function outside of our end region, because then he would not get collapsed with our functions region.
And if you mess it up, you could end up losing something too. Like
Absolutely.
get everything collapsed. And where did I put that function?
You got it. So what I'm going to do, watch how simple this is. I'm going to start with start. I'm going to grab all of this code right here, Control X, come all the way down here, and paste it inside of my set position and speed. Now I'm going to come back up here to start, and all I need to do, set position and speed. Just call that function.
Yeah.
So this, when start gets hit right before our first update, this function gets called, which means we jump down here, we execute the lines of code in the function. When we hit the end of the function, we return back. There's nothing else to do, so that's it. We're done with start. Now in update, look at all this code. This code now exists down here. It doesn't matter that we are reassigning Y and Z. So, I mean, we could move those back up to start right before set position and speed. I'm just going to leave them there. It keeps everything simple.
Sure.
So let's come in here and let's remove all of this out and do the exact same thing.
Set position
and speed.
And what you're doing here, and I know you're not trying to turn these into, hey, let's teach programming kind of videos, but it's in the real world, it does kind of have an analogy. If you've got a kitchen full of dirty dishes, you can tell somebody, hey, take that cup over to the sink, put soap in it and scrub it. Now take this plate over to the sink, put soap on it and scrub it. Now take these dishes over to, you can tell.
So you have just described a series of tasks that we could then bundle up and give a simple name to it, such as?
Wash the dishes.
Oh, wash the dishes. So that is calling upon a function. So if I said, Zach, go wash the dishes. No, I'm serious. Go wash the dishes.
Exactly. You tried that once with Make Coffee.
Then it almost worked. And anyways, you would know you've been called upon, and you would know the series of tasks that have been wrapped into the description. Go wash the dishes.
Right. You don't have to tell every single command over and over again. You just bundle it up into something simple.
Exactly.
Which is all we've done here.
So let's make sure this works, of course. So make sure that you hit Control S to save. We'll jump back over here and hit play. And hey, he's still moving. Up, still got random locations being generated and random speeds, as this one's faster than the last. And it's about the same speed.
Well, the range is so thin,
the range is
it's
tight.
be hard to.
But you were able to see it really well between the first two.
Yeah.
But anyways, now we have cleaned our code up. We've streamlined it, if you will, in such a way that we do not have repetitive lines of code. The code's being typed out one time, and we are simply calling on that functionality when we need it. So with that, anything else you would like to add?
No, I think we're good.
Okay, I think you're really picking up with this stuff quickly. That's good, because I have some evil plans for you soon.
I know, I'm scared.
So with that, that's going to wrap up this video. Thanks a lot. Okay, so now that we have life in our enemy, let's remove that life. Let's go ahead and set up some collision stuff such that our projectile can collide with our enemy, and we can destroy, well, both of them in that particular case. Now, keep in mind, when I say destroy the enemy, what that really means. So with that, let's spend just a second and talk about collisions. When dealing with collisions, there's a couple of ways that we can go about handling them. One would be just regular rigid body type collisions, and with those we could, find out when two pieces of geometry hit and who it was that we just hit with and what was the point on the geometry in which the contact occurred.
Sounds pretty complex.
Exactly. Or we can take a very simplified approach and we can set up a trigger, and when one of our objects collides or enters into the other one, it's like entering into the trigger location, and then we can simply have that fire off a function that we can then put our code in.
So it's like a penetration check.
Yeah, exactly. So that's what we're going to do, because it's very lightweight and easy to set up. Now, for this type of a collision, what we need to have in place are the following. One, both objects. So I'm just looking at this from the point of view of just two objects that are going to collide. Both objects must have colliders. So let's go ahead and come back over here into Unity and take a look at our prefab down here. Our prefab has a capsule collider on him. Excellent. The other guy must have a collider. Well, who's the other guy? He's our enemy. So let's select our enemy. He has a sphere collider. So we have met that condition. Both of these guys do indeed have colliders. The next thing is one of the objects must have a rigid body.
Okay.
At least one of them. So in this case, let's take a look. Our enemy, nothing. Let's come down here to our projectile prefab, and with him, rigid body. And if you recall, when we set up the rigid body, we had unchecked use gravity because it just didn't make sense. And we had checked use kinematic, or is kinematic, excuse me, so that we can handle the positioning of this ourselves as opposed to letting the rigid body react by a physics simulation in regards to how it's going to spin away. Or
we're moving it manually as opposed to it being simulated.
That's right. So we're going to keep things very lightweight here as far as physics engine's concerned. Okay, so now that we have that in check, meaning at least one of these guys has a rigid body, the last thing is one of the colliders must have is trigger checked. So with our enemy here, let's go ahead and just take the enemy. And because I'm going to demonstrate checking is enemy or is trigger on the enemy, and then we're going to add this functionality over on our projectile.
Okay.
So, but it doesn't really matter.
Yeah, you could do it either way, it seems.
So is trigger, check. So we have now met all of the conditions to make a trigger event occur. Mm-hmm. And so with that, what I'd like to do real quick is come over, grab our help file. And here we are on game objects, so let's kind of cruise down to mono behavior. I just want to get those out there that are new to working with Unity comfortable with jumping into the help file.
Absolutely.
And getting a quick refresher on what functions are available that they can use. So we know we want to use this trigger thing, and as I come down, here's on trigger enter. On trigger enter is called when the collider other enters the trigger. Wow. Does that read weird, or am I just...
Yeah, it's a little funny, but I see what it's saying.
I see what it says. It just reads kind of odd. But anyways, and of course it could be because, once again, it's like 2 in the morning. So, but we have the functionality of on trigger enter that we can go in and override and add our own functionality in there. We have on trigger exit. We have on trigger stay. Then we have the true collision stuff that we were talking about a second ago, where we're looking for collider and rigid bodies where they've begun touching one another.
And that would be useful if we wanted like our projectile to maybe hit the enemy and it would bounce off in some actual trajectory based on where it hit. Yeah, we're wanting to use physics to calculate all of that stuff for us. In this case, we want to keep things extremely simple. So we're going to be overriding on trigger enter. So with that, next thing we need to do before putting that code in place is come up with some way for us to locate our enemy in code from the projectile's point of view. So we know who we hit?
Exactly. Now, this is a very simple setup right now. I mean, we have only one enemy. We're not really spawning enemies, and we know his name. So I can use gameObject.find and say enemy, and it's going to find my enemy.
Sure.
That's not a problem. But in this case, what I'm going to do is, again, following along with Casey's setup, I'm going to use tags. Tags are very powerful, very helpful. An example, let's say that you have a bunch of different objects that are all considered collectibles. Mm-hmm. You could tag all of these guys as collectibles, but they literally could be different things. You could have stamps. You could have butterflies. You could have hey, it's 2 in the morning, and it's the first thing that comes to mind.
Yeah.
But I could set up a tag called collectibles and put all of these guys, or set all of these guys' tags to collectibles, and then I could have a script simply say, hey, is that object a collectible? By looking at its tag. And even though they're very different objects, meaning your baseball card from My Little Butterfly.
I was going to say, you thought of stamps and baseball cards first.
No, butterflies. You thought of baseball cards. Get it straight, Zach.
Okay.
So, but anyways, but we know they're all collectibles, okay? Mm-hmm. So we know that because the tag would be set.
Right.
So I could check the name, but what if we had different types of enemies? What if we had, quick, give me some enemy names. The X111, okay. The F15, and the K31R36211.
Wow.
It would not be a lot of fun in our code to say that if the object we just hit was this guy or this guy or this, that's a lot, right? Instead, all of those enemies could have their tag set to enemy, and then I could just simply say, hey, if the object we just hit, if his tag is enemy, don't care what kind of enemy he is, we just hit him. Let's do some stuff.
Gotcha.
So to set a tag, you'll notice on the game object right here, we've got tag, and right now this guy is untagged. Let's go ahead and drop this down. Now, Unity does give us some defaults that are set up that we can take advantage of, such as if we had a player or a game controller, camera, etc. I'm going to come down here to add a tag. Adding a tag is very easy. I'm just going to come up here to tags, open that up, come down to element 0, and then over here I'm going to type enemy. Enter. You'll notice that as soon as I started typing, element 1 popped up. So if I would like to add another tag later, very easy to do. So now that we have set the tag up, we've not actually assigned this tag to our enemy's tag property. So let's grab our enemy again. So tag is still untagged. If we drop down in our list, we will find enemy.
Okay.
So now he's been set. And this is very helpful because now inside our code, we can simply check the guy that we've collided with and say, hey, his tag, is it enemy? And if the answer is yes, then haha, we have hit who we need to hit in order to destroy what we need to destroy.
So if we had multiple objects here that were serving as enemies, we just need to make sure that they all had that enemy tag on them.
Okay. Multiple different kinds of objects.
Gotcha.
So very easy. So you can see how this could be a very powerful system.
Simplifies selection.
Absolutely. So let's go ahead and jump into our projectile code. And then from inside our projectile code, what we're going to do is we're going to add the on-trigger event. Once again, bringing this up, I did demonstrate that this exists on the mono behavior in which we have extended, making all of that available to us. And so we're simply going to be overriding on trigger event. And that's going to get called automatically from Unity when we have this collision. So let's go ahead and minimize this guy. And I'm just going to jump down up under update, and it's going to be a void on trigger enter. Now on trigger enter is going to take in a collider. Because that's what it's going to let us know, is because it's all about colliders with the trigger, as we saw back over in the help. As a matter of fact, if I jump back over here real quick, come back down. So again, it's all about the collider. So if we take a look at this guy and jump in here, you'll notice that the function, now again, this is in JavaScript. Everything that we see inside our help at Unity is going to be in JavaScript. But it's very easy to take this stuff and turn it into C# code. So just keep that in mind. That's the format we're looking at. So our function, we're going to be calling the on-trigger event. We're not calling it, but that's what we're setting up. And we have a variable name of type collider. So we just kind of need to reverse the way we say that in C#. So we're going to give our data type first and then our variable name. So let's jump back here. And in order to do that, and again, following along with what Casey had set up, I'm just going to call this other object. So we start out with our type,
which is a collider. A space, and then the variable name that we want to give it. So it could be any variable name. But Casey called it other object. So we shall do the same. So we'll set this up like such. Now, inside here, let's start simple and get our beginners out there comfortable with doing some debugging. I'm going to do debug.log, and I'm going to log out to the console about something like we hit, and now I'm going to append to the end of that other object dot. Now, it's a collider. Now remember how the components work. As far as scripting goes, we talked about this a little bit a few videos back. When we refer to everything we can get to on that component, if there are things up on the object and on other components that would never exist on us, we can get to those things from right here, meaning that other object is not really the game object. It's the component on the game object. Sure.
But in most cases, I can simply treat it as the game object, meaning I can simply turn around and say .name. Okay?
Right.
So it's not, since collider, the component, doesn't have a name property, what's name? Well, name is going to be the name of the game object then. So we'll go ahead and set that up. So all I'm doing is basically echoing out to the console, we hit, and then we're going to append to the end of that
the name of whatever we hit.
The name of whatever we hit. So that's all we've got right now. Just that just proves things work. So let's go ahead and save this, jump back over. Now, first thing I'm going to do, hit play, and start missing. Boy, that was amazing.
I was going to say, that was a nice job.
We hit enemy.
Yep.
Okay. Let me go ahead and bring this guy over here. So we hit enemy, we hit enemy. I actually missed him on both sides a second. It was amazing. So again, so we hit him again. Again, so that's 4 times and 1 more to make 5. 5. Now let me bring my console back over. So there we are with all of the hits. So we hit enemy, and the information is simply being echoed out for us.
Right, now he's keeping the console over on a separate monitor. But
That's correct.
While he's actually doing this, you can see these entries appear in the log. So if you've got enough screen space or if you're using multiple monitors.
I can come down here, and we can clear this, and then cruise on over. Where's he at? Boom.
Oh, okay.
And there you go.
I wasn't sure if focus was going to change.
So there was a whole bunch of collisions.
Yeah.
Oops. Hush.
Fail.
There we go. So anyways, let's go ahead and move that out.
We need to make this multiplayer.
Hush. Okay, so let's hit stop. Now, pretty simple, but obviously, when playing an actual game, we're not looking for information to pop up at the bottom of the screen saying, you hit an enemy.
Right.
We want to see some stuff happen, such as we want to get rid of the enemy.
If you hit the enemy.
Okay, exactly. So let's go ahead and jump back over into our code. And let's change this around. We don't need to keep the debug anymore. I just wanted to show everybody that you can make use of that.
Okay.
What we're going to do now is we're simply going to ask our other object if its tag is an enemy. Mm-hmm. So I can simply say if other object dot tag. Now this is an equality test, so we need to use two equals here. A single equal is going to be an assignment operator.
I always remember it by thinking you're saying the word equal to.
Yeah, okay, it works. Very nice.
So there's 2 equals there.
Okay. So our other object's tag, if it is equal, I like that. If it's equal to enemy, man, we haven't recorded videos together in forever.
It's been a little while.
Yeah, I miss it. All right, so if it's equal to enemy, that means that we did indeed collide with the guy that we're interested in colliding with. Now, let's just block this in. We could do something like, one might be thinking, destroy him. Well, fortunately, destroy is available that we can use. Mm-hmm. So we can say destroy, and it's looking for an object to destroy. And so the object that we want to destroy is going to be our what?
Other object.
Okay, this is where you got to be careful. If I say destroy other object, right, that does indeed look right. Watch this. And it is going to work.
Okay.
Not the way we think.
So it looks right and it's going to work, but it's not really
I'm going to hit play, hit him. Something just happened. Over here changed.
I know you actually hit him. That was the impressive bit. See?
Now nothing's happening.
Oh.
Now let's stop and play it again, and I want you to focus on this. I want you to look at the game object stack, all of the all of the components that are on it, and see what changes. Hit play, fire. Something changed, didn't it?
Yeah. We got a projectile. Hang on.
All right, let's hit stop.
Do it again.
I want you to read off the components we have.
Oh, the components. Gotcha.
Start right here. Transform.
We got our transform. We got our sphere, our mesh.
Our mesh filter.
Yeah, we got our sphere collider. We got our mesh render, and we have our enemy.
Okay. Let's hit play
Which
again.
is the script, of course. Oh, wow.
Pause. Now, nice thing about pause.
Yeah.
So now, let's read it again.
So, yeah, we've got our mesh. We've got our mesh render. We've got our script, but we're missing some stuff.
Who are we missing? Let's hit stop. Who are we missing?
It looks like the sphere collider's gone.
Collider. Let's jump back over here. And what is other object?
It's a collider.
Very good. Other object is the collider. Mm-hmm. And this is what I was talking about earlier. When you refer to something like a tag, tag's on the game object, to the game object level.
Sure.
But it's not on the collider, and so the system's set up, it's very robust. It's going to say, oh, well, the tag, okay, that's the game object's tag.
Yeah.
I could have very easily, as I demonstrated a little bit earlier, I could have come in here and I could have said game object just to be very verbose. Mm-hmm. Okay, and this right here, same exact thing. This just keeps things nice and simple.
Right.
But there are situations you need to be careful in. In this case, I really do want to destroy the game object. Mm-hmm. Because by saying destroy other object, I'm just saying destroy the one component.
Right.
And it's cool because now you see that you do have the ability to go in and destroy just parts of what makes up a game object.
Which is very interesting.
So now, to do that, I would simply come in here and say dot game object.
Gotcha.
Now I'm referring to the actual object. So let's save that out, come back and see what it looks like now. It's a bam, destroyed.
Yeah, and you hit him on the first go, too. That was the really impressive part.
Back off.
Well, I was going to say we could throw some, like a comment into that code and just say this entire block of code is irrelevant when Buzz is playing.
Would you like to just line up a series of 30 players across, and when I hit fire, they all fire. I won't miss a darn thing.
Sweet.
So what I'm getting at here is that you need to make sure when you are working with components and you're working with a game object, be aware of what you're really working with. Now, do we really want to do this? No. Because at this point, the game just got very boring.
Kind of dull, a little dry.
The enemy had the enemy script object attached, okay? So that script component had been attached to the game object enemy, but now we've killed the enemy. So you could say that instance of the enemy script is gone, which means it's no longer running.
So nothing ever resets.
So nothing resets, so there's no enemy coming back down the screen again, and now here I am, lonely with nothing to do in the game.
Well, kind of the drawback of our system by which we don't really have multiple enemies. We're kind of pulling the wool over the player's eyes by taking one enemy and using them over and over and over again. And what we've just done is we've killed that one enemy. So now there's nothing left to do.
Absolutely. So what we need to do is we need to reset them. So I'm going to jump back into code. And let's get this line out because that's no good. Though it did a good job of demonstrating a very important concept when dealing with components and the game object. So let's go ahead at this point and change the code to something that we recognize, something like move back to the top of the screen. So if I was to say other object dot game object or transform, because the collider doesn't have a transform. So if I say dot transform dot position equals new vector 3, and with this, let me just take wherever he's at right now. So I'm going to say other object dot transform dot position dot x, comma, and I'm just going to jump down just to keep this kind of easy to read. Well, actually, for y, let's just move them straight up.
Sure.
We know that we want them up at 7, right? So 7.0f, and then just to stay consistent, let's do this. Other object dot transform dot position dot z. Close this off like such. So again, this variable is holding a reference to our object, the enemy, and so we're just simply talking to him and positioning him accordingly to make him jump straight back up. But we do have a problem with this code, and that is, well, let's take a look.
Now, you want to scale the enemy up before we try this?
You want to scale him up?
Yeah, make him easier to hit.
Jumping back over, back off. I'm going to hit play and watch what happens.
Something.
Let's let him jump down. There we go. Good location.
Ooh, look at that.
What's our problem?
Well, yeah, they're not getting a random location.
The game's easy for me to play now.
Yeah, yeah.
Zach's happy.
We have buzz mode.
That's right. It's in buzz mode. So not good.
As long as you can hit that first enemy.
And this is something that we addressed earlier without really talking about it, because we said right out the gate, we want to make sure that he's got a random position horizontally.
And now that randomization is not being called on, because right now that only happens if he hits all the way to the bottom of the screen.
That's right. Now, if we were to jump into enemy, let's take enemy and just kind of drag him over here by a projectile. We want to basically do this stuff right here. Now, let me point this out to our viewers. What I'm about to demonstrate is something that kind of steps outside of the realm of beginner content, even though it's very easy. And it steps up a notch to kind of beginner intermediate content. I would like for my projectile to gain access to the instance of this enemy class, which is the actual enemy component attached to the enemy I just hit, and I would like to be able to call upon this myself from over in projectile. So a particular projectile calling upon a particular enemy's set position and speed.
Gotcha.
So
you can effectively do a real reset and get a new location.
Absolutely. So watch this. First things first, all of these guys are private since they've not been explicitly told to be public. I'm going to make this guy public. That means that I can now see him outside of this class. Let's go ahead and save this. Now, what I need to do is come back over here into my projectile. And all of this was great, but I don't want to do all of that. Instead, I want to just simply say, reset that position, set the position and speed, and be done with it. So to pull this off, I need to get the component that is on the enemy, the enemy component, because that's what we've called our script, enemy So we need the enemy component on our enemy. And to do this, first thing I'd like to point out is that other object has some functionality built onto it called get component. So with get component, I can turn around and get a particular component that's attached. Now in this case, what I'm going to do is I'm going to keep everything very clear. I'm going to step up to our game object. So here we are at the game object. Now give me a component. So get component. Now take a look at what we need to provide it.
A string?
A string type. Or we could say type of as well. Well, we'll get into that later. So string, what component type? Well, what is our component called?
We named it enemy.
Yep. We've seen components called things like a camera or a directional light or a mesh filter. This custom component, the script object, is called enemy. So that is the type that we are dealing with. All right. So here's how we can go about getting the type. But I want to store a reference to this so that I can then turn around and talk to it. So let's jump down here, or back over here, excuse me. To hold a reference to something, I just need a variable. Well, anytime that you set up a variable, you must first declare the variable. So when declaring a variable, what's the first thing you need to do?
You need to know its type.
You need to know its type. So int, float, string, etc.
Sure.
In
So
this
what
case,
type is this?
Our type is an enemy. We're defining the type. The class is where we're saying this type is a projectile.
Okay.
So coming down here, the type we know is going to be, and watch the coloration of it. It's type. Look at the coloration here. That's a type.
Yeah.
I have anybody else around? What if I jump down to the next line and say, make an int?
An int or
that's
string.
like string. Well, actually, those are the value types a little bit different. But anyways,
Right. But
so,
I see what you're getting at. It is noticing that should be a data type.
So here we are with our type, enemy. Now the next thing that we're going to do is give it just a variable name. I'm just going to lowercase enemy equals, and we'll do this. But there's still a problem with this, and that is what we're getting back is not of type enemy. And you can see this down here in the error in the box that's just popped where it says cannot implicitly convert type UnityEngine.component, because it is a component that we got, get component. It can't convert that to enemy.
So we got to cast it.
So we need to cast it. And casting is very easy. There's a couple ways. We could say all of this as enemy, or I'm just so used to doing this because I've been doing this forever. Cast type enemy. Now watch this. Boom, that went away.
Yeah, and this is why you were saying this wasn't like we're kind of going from beginner kind of up to intermediate.
Yeah, this is a little more involved.
Because I see what this is doing, but this is not the most intuitive line of code in the world.
It is once you get used to it. So let's jump back over here and let's take public off for just a second. Let's save this so I can make a point. So I'm going to come back over here. And now what I'm going to do is I'm going to say enemy dot, look at this. We can now gain access to all this stuff on enemy. A whole bunch of stuff here. So we're looking for the, what was it called?
Set position and speed.
So set doesn't exist. Again, it's private at the moment. We want to expose it. That's why I wanted to come back and show this.
Gotcha.
I thought this would be very nice for everyone to see. So public, let's save that out. Now let's jump back over.
Now IntelliSense should
Enemy.
pick it up.
Look at that. We're sitting right there at it.
Very
So
nice.
set position and speed. So let's just go ahead and call it like such. And, well, let's save and run. That's all there is to it. So come back over here and play. And hit. Whoa. Hit. Whoa. Hit. Use that wrapping.
I was gonna
I
say,
missed.
yeah.
I can't believe it.
I can.
I'll be quiet.
Sorry. I shouldn't laugh.
Ah!
There you go.
Oh, no. I have the worst luck in the world.
You do.
Okay. So, working well.
It is.
So we can see that we are reaching over into the enemy component and actually working with its data. Okay, so we're controlling its behavior, which is fantastic. So let's jump back over here. There's one last thing that we need to do, and that is the projectile itself just keeps on cruising.
Yeah.
And we need for the projectile to actually die as well. So to destroy ourselves, we're going to come in here and we're going to say destroy. Now, I'm going to just, again, to continue making a point every time I can. We know that I can say this, and that's referring to myself, but this is a component. Okay, so we don't want to destroy the script component. So we could say this dot game object like such, but instead we could just simplify this and say game object. We've been doing this all along with things like transform. Now in this particular case, we actually have a cache transform out, as we were talking just a little bit about iPhone stuff, but I think everywhere else, though, we haven't taken the time to do that. So here we are, just straight out talking to the transform and then going down from there.
Right.
So here, just talk to the game object. So destroy game object. And in this case, the game object that the instance of this class projectile is attached to,
is whatever laser we're happening.
Whatever just did the collision. Yeah. That's right. So let's go ahead and save, jump back over, hit play, and boom, and they're both gone.
Nice.
And it's starting to look like a game.
Yeah.
Like I said, I really felt that Casey did an excellent job. That was actually a nice compliment there.
That was.
He did an excellent job with the game that he picked to demo here in Unity.
Yeah.
Unity has so much power, and it's so easy to make sophisticated games, but by doing something this simple, it really does help keep a lot of the different topics that all go together in the creation of a game very concise, very clear. So let's go ahead and stop it. This is working beautifully, and with that, that's everything that I wanted to demonstrate in this video. Any questions?
No, I think we're good.
So the bottom line is we have set up the ability to have Unity call the onTriggerEnter. And for this to be called, the two objects that we are looking at having interact with one another, one of those, both of them have to have colliders.
Yeah.
One has to have a rigid body attached to it.
Yeah.
One of them needs the isTrigger checked on the collider. And then for us to be able to control things on the guys, that we're going to go in and say is kinematic on the rigid body and turn off the gravity, because obviously we don't need gravity.
Right.
So that is everything I wanted to demonstrate, and that is going to wrap up this video. Thanks, guys. So in this video, we're going to create our explosion effect that we will turn around and use on the enemy when the enemy is destroyed.
Time for special effects.
Exactly. So to do this, we're going to use the particle system that's built in Unity. And Zach, I'm going to let you pick out some values for me.
Okay.
What we're going to do is come up to game object. We're going to come down to create other, and we're going to go ahead and just grab a particle system. First thing I'd like to do is, of course, set the name. So this is going to be, we'll just call it explosion. Like such. Now, with explosion, we've got a few things that we need to set. You can see there's actually a whole bunch of things available to us. You can also notice down here in the game that with this guy active, our particles are kind of twinkling and moving. This is the effect that we have at the moment.
So by default, it's confetti?
So exactly, very good there, Zach. So if we were to come in and start out with a min size and a max size, and this is basically the size when the particles are spawned, they'll have. So if we were to set a maximum size somewhere around 1, I want to make these guys very visible here on the screen.
Gotcha.
And a min size of about 0.7. Okay. Now, let's go ahead and spend just a second with colors. So we'll start off with first color, and I'll just go with colors that are similar to what Casey had used. So I set up some sort of red, and then we can come in here and set up a reddish orange.
So you're just doing a spectral shift from, say, what, red to yellow?
Yeah. So I'm more of a brighter orange now. And then from there, let's go to a
purple.
How did you know?
So you do what? Red or like reddish orange, orange, yellowy kind of orange, and then yellow.
Yeah, so there's our fireball that's just sitting there just
yes.
That's kind of cool.
It does look kind of flamey.
Yeah, okay, it does. Okay, so now that we've got some colors set up, and of course you guys can spend all day playing, you get the idea.
Sure.
In this particular case, what we're looking for is just a single burst of these particles when they explode. Right now, as you can see, we're continuously expelling.
Continuously exploding.
We are continuously spawning these particles, and these particles are dying out. The minimum and maximum energy is going to determine the lifetime in seconds, and that's why we don't end up with just a crazy number of particles here, because they are dying out. But what we want to do is a one shot. So this is just going to be one shot of these. Boom. And now it's just repeating.
Okay.
And so let's go in here. I toned down my red a little. It's awfully red. But let's go ahead and make a few adjustments to give some speed to these guys. So first of all, tangent velocity. If we come down here to the tangent velocity, that is going to give us the starting speed, if you will, from the emitter surface. And for that, some values like 2 and in Z, 2. Don't need to really put anything in Y.
That's awesome.
If we did put something in Y, Zach's going to love this. Watch what happens up here.
Yeah.
Hang on.
With particles popping out at you.
So now we've got a nice shockwave type effect. But of course, we need more particles being emitted there at birth. So all we need to do is come to the min and max emission. And we're going to set it to something like 200 to maybe 250.
That's like a really glorious effect for blowing up one little enemy.
I like it. But of course, we're not going to do that, even though this is
so over the top. It's
darn
awesome.
Cool. So let's put everything back into the one explosion. So now it's not so much a shockwave.
Yeah.
And with that in place, let's go ahead and adjust our energy. So come back up here. Right now we're living for 3 seconds, so quite a bit of time. So let's go from 0.2.
I can't see the next enemy because the last one's still exploding.
Exactly. So 0.2 to, 0.2 to 1. Emission, we've got size, we've got some colors. Yeah, you guys get the idea. Come in here and play. Have a good time with it.
Yeah.
I mean, that's really all that we need to talk about here. Then in the next video, well, there is one more thing that I'd like to add here, and that is the auto destruct. So we can go ahead and turn auto destruct on so that when this guy finished and all the particles have died off, then the game object is going to terminate itself for us so that we're not responsible for destroying it. It's nice to be able to just spawn something and not worry about it anymore. And with auto destruct, this is going to give us just that.
Okay.
So in the next video, this was so short. I'm just looking right now. Maybe we just keep on going. What do you think?
No, well, I think at this point it's a good time to go ahead and let people stop. If they want to make an explosion of their very own, they can play with the particle system on their own.
You're doing really good at trying to make sure I do shorter videos. So fair enough, but it's very simple to work with the particle system. We've got a lot of effects here that we can manipulate, or a lot of properties. So feel free, see if you can make an explosion that looks like an actual explosion, not this little cute one that I've got. And even Casey's look better than this. This is quick, okay? So with that's going to wrap up this video. In the next one, we'll take a look at how we can package this up with a prefab, get some sound to it, and get it in place. So thanks a lot, guys. Okay, so now that we have created our very simple explosion effect, let's go ahead and get this guy packaged up as a prefab so that we can instantiate him during gameplay.
Oh, yeah, we got this hyper-realistic kind of explosion. Let's put it to use.
Very nice, Zach. So we'll start out by coming down here to prefab, right-click, create, and we'll create an empty prefab. And we'll call this explosion prefab. And then I'll simply come up here to my explosion particle system, to the game object, drag and drop it down here on explosion prefab. Of course, it's going to turn blue up here. I can simply delete this guy out, no longer need it. So with that done, next thing I want to do is take a look at adding an audio source to this guy. The same way we did to the projectile so that we could play the pew pew sound. Here we want to play the explosion sound. Now we could have added the audio source to the game object while we were working up here before we packaged it all up. It doesn't matter.
Sure.
Okay, just keep that in mind. So on our explosion prefab down here, we want to add an audio source component. So again, we're going to be creating a component. It's going to be an audio component, and it will be an audio source. So if we scroll on down in the inspector to the audio source, again, we have an audio clip, and we've already brought in an explosion sound. So I'll simply left-click and drag and drop it over onto the audio clip. This will be a play on awake, and there you go. That's pretty much that simple. So now that we've got this set up, the next thing we need to do is get this guy to instantiate. And in order to get them to instantiate, we know that we're going to need to set up a public field of game object type and then drag and drop this prefab into it so that we have the link there that we can use for instantiation. Well, that's a lot of words. Is it just that it's really late at night and it really wasn't a lot of words?
No, you're fine. You're fine.
Okay.
Just keep jamming, man.
So what I'm going to do is jump back over here into our projectile script, because it's in the projectile that is aware of this collision.
Right.
So that makes sense as the place that we would instantiate the explosion. So inside the projectile, let's go ahead and come up to the top, and what we're going to do is create a public game object. And this public game object, we can call it something like explosion prefab. Like such. And again, if I hit Control S, jump back over into Unity so that it compiles, and then take a look over on the projectile prefab down here. We will find on the script, the projectile script that's been added, explosion prefab. Of course, none at the moment. So this is really cool. If you really look at what we're doing, we're taking a prefab and linking another prefab to it. This is very powerful, and this is the way that Unity has been designed to work. But let me be the first to tell you, when you start working with complex games that have all of these, all of this linkage in place between prefabs and hierarchies of prefabs, and that's when things really start to get sophisticated. And if you do something to accidentally break the linkage, meaning you're working over in your script and one of your fields gets commented out or the data type gets changed or something that causes the linkage back in Unity to get reset so that none is now assigned, and you didn't catch that, and that prefab and that linkage is buried really deep, it can quickly become a mess and a complete pain to troubleshoot. So prefabs are very powerful, but when I work in a more professional sense, of course, this is just an excellent introductory game to get up and running with Unity. I will use prefabs, but as far as linkage and all goes, I try to keep that to a minimum. I try to handle as much as I can through code, the way I bring things in, et cetera, just for the simple fact that when I'm dealing with code only, if I break something in the code and then I go, oh, yeah, I meant to change that back, and I change it back, I don't have to worry about linkage that just got broke back in Unity because I'm now looking at my code and my code's right.
Right.
But if I forgot that I'd linked something over there, or if somebody else working on my team wasn't in my file and all of a sudden everything broke and they're like, what's going on? And they have to dig and find the linkage.
It allows you to look for your problems in one location instead of many.
Yeah, it really does simplify things. And I'm just throwing that out there, that this is based off my own experience with Unity, that when you start dealing with complex projects with a lot of linkage going on, this will show its head. I can promise you that. So anyways, so here we are with a prefab, and we're going to take another prefab and link it up there. So now we know that our explosion prefab is the explosion prefab. So now that we've got that set up, we can turn around. Oh, by the way, I know that you guys have been seeing this where we now basically have the random range has been depreciated.
Yeah.
I'm just going to point it out real quick. I'm just going to stick with the random range right now. Again, just following along with what Casey did, but we could simply switch over to random dot range instead. Anyways, jumping back over into Visual Studio. So now that this field right here is populated with data, we can turn around and instantiate this guy. So it comes down to, where do we want to instantiate it at? Well, obviously, when the collision occurs. Now, let's think about this. When we instantiate something, we need to set the position of it. So in order to set the position, I don't want to instantiate him after I reset the enemy's position, because our explosion would then be instantiated in the scene right above the top of the screen.
Right.
Not good. The
enemy would just disappear, and you might catch a few fringe particles up at the top.
I'm talking about with this crazy explosion, it would suddenly start raining debris from above. So, but you're absolutely right.
If you hit the target.
So, thank you very much. So, what we need to do is, I'm just going to come in here to it really doesn't matter where we instantiate as long as it's before this guy here. So I'm going to say grab my enemy, and I'm going to put it between these two lines just so that the code will read better. Meaning, if it's above this line right here, I'm going to have to refer to everything in regards to its transform and position as other object. It reads better if I simply say enemy. So between these two lines, after enemy has been defined, I can say instantiate, and we're going to instantiate what? Well, above, we called it the explosion prefab. So we're going to instantiate that. We need to give it a position, and this is what I was just talking about. If this line was above the enemy line above, this one here, then I would have had to have said other object. But instead, I can now simply say enemy. It just reads better. So I can say the enemy's transforms dot position. Okay, and then I can do the quaternion identity, or I could do the enemies, just to keep readability simple for somebody that's new. We could just come in here and say, take his rotation as well.
Right, so it's real easy to see that we're instantiating the explosion prefab, put it at the position and rotation of the enemy.
Precisely.
Booyah.
Yeah, and since we know our enemy doesn't rotate, we could have used the identity if we wanted to have quaternion. So all is good there. After we instantiate the explosion, then we have our enemy reset its position and get a new random X and a new random speed, and he begins cruising down once again, and we destroy the projectile that was responsible for this whole thing coming about. So with that, let's go ahead and save, and I'm going to, once again, do the very cheap way of injecting audio into this video by grabbing my headphones. And, oh, this is going to be tricky because I have to actually hit the guy here. So let's...
You said it, I didn't say it.
I knew you'd like that. So let's just...
That's awesome.
But not bad, eh? I mean, it's exploding. Yes, just for you.
Very nice.
Very cool, huh?
Yeah.
So we got a little game coming along. But right now, I can cheat all day long. I'm in God mode.
Yeah. If the enemies hit you, nothing happens.
So we do need to address the enemy hitting us. So it's another collision that we need to worry about. But I felt that this was kind of a good time to take a break in the next video and get a new system, so something new to look at. Get a new system in place that's going to work with all of this collision stuff, and that is score and lives.
Okay.
Now, Casey did his a little bit earlier in the project. I figured I'd wait till now. I thought this was a good spot to go ahead and introduce it so that as we are destroying our enemy, our score is climbing up.
Sure.
And then we'll turn around and worry about our player getting destroyed. So that is going to wrap this video up, and we'll see you guys in the next one. So in this video, we are going to implement our score and our lives system. Actually, it's not that it's much of a system. It's really just maintaining a couple of static fields that we will be able to set from anywhere inside of our game. So from any script, we'll be able to access these fields.
Okay.
So we'll create a lives field, and we'll create a score field. The interesting thing about this video is we are going to make use of the Unity GUI system. It's very powerful. It's very flexible. You're not going to see it in all of its glory because all we really need to do is just put some text up on the screen.
Yeah, just some numbers.
Yeah, show us our life and to show us our score. A little bit later on, we'll take a look at putting a button up and making that button function. But I would like to point out for those of you that are watching these videos that are planning to use Unity for iPhone development, you will want to avoid using the system that I am about to show.
Okay.
Now, why am I showing the system? Well, this is not a video series that is targeted towards iPhone-only development. When you are developing for the iPhone with Unity, or when you're developing for the iPhone, period, there are a lot of things that you need to constantly think about that you don't have to really think about when you're using something like C# and X and A to develop a game for the PC, or Unity for making a game, etc., where we're working on a machine that has a significant amount of power when compared to the iPhone, and a lot more memory and a much stronger graphics processor, etc. So when you're dealing with the iPhone, you're dealing with a little phone. So a lot of things you got to keep in mind. Now, the Unity GUI, the Unity GUI system is very powerful, and you should use it. You should take advantage of it when you are creating games for the Mac, the PC, the web, etc. You just want to avoid this when working with the iPhone. Now, that shouldn't make you go, oh no, then how would I go about creating HUDs and text that has things like score, etc.? There are still things that are built into Unity that you can take advantage of that will allow you to still do GUI texture type stuff, GUI text type stuff. But it's not part of this Unity GUI system, which actually revolves around a very specific function that we're going to be adding into our code in just a second. You've seen the function start. You've seen us override that. You've seen the function update. You've also seen the function, the trigger one that we used, the on trigger enter.
Yep.
Now we've got on GUI. And it's like update, where it's going to run every frame, but it can actually run multiple times in a single frame, depending on events that are occurring with the GUI controls and all.
Okay.
Because of that, you really want to look at, avoiding to use that system on the iPhone. You can use it. It will work.
Yeah.
Also, the draw call count can become expensive. And I know that's like draw calls, huh?
Yeah, what's that?
It gets way outside the scope of these videos. And it's something that we will cover later when we start talking specifically about iPhone development using Unity. But for now, just keep in mind what I'm showing you works fantastic, and I encourage you to use it for everything except for the iPhone. All right, so with that, first thing we need to do, let's go ahead and set up a couple of fields in which we can store our data, lives, and score.
Now, where are you going to put these?
Well, Again, I'm following along with what Casey had put together, so I'm just going to put these inside of Player. When we come back in another set of videos, another video set, and recreate this game using Objective-C, C#, more along the lines of the way you would use an object-oriented program to write a game. We're going to end up with a game manager, and that game manager is going to instantiate a single instance of a game, and that game is going to be where we're going to have our score and our lives reside.
I gotcha.
As opposed to sitting on the player. We're going to really compartmentalize all of the functionality to very specific classes and keep things as clean as possible.
But that's coming soon to a theater near you.
Exactly. But the nice thing about that system is we will also be using the built-in functionality of Unity. We're going to still inherit from mono behavior for things like our player and our enemy, but we're going to demonstrate how we can marry classes that do not inherit from mono behavior, meaning that they are not attached to game objects. We're going to show you how those can be instantiated and used to control things in a game. Neat stuff. So, all right, so like you said, where are we going to put it? In this example, since I'm trying to do my best to parallel with what Casey did, we're going to come over here to Player. We're going to keep it on the player. Now, if you are not a programmer, so you're new to this world, and you've seen me throwing around the word class, and we've talked about objects, and we've been talking about fields or our data members. Just a real quick recap. A class serves as a template for an object. When we take our script, which of course is a class and the way this is all being done, and we drag and drop it on one of our game objects, we've just taken that script object, if you will, and attached it as a game object, or excuse me, a component to our game object. What we've done is we have created an instance of the class. So you can look at the script, as I'm pointing right here to our projectile script. This is an instance. So think of this as an actual object. So you take the blueprints of something, think of that as the class, you create an instance of that class, and it is as if you've gone in and you've actually constructed what that blueprints showed you how to make.
Okay.
But the nice thing is then you can give it its state and take advantage of its behavior, the whole idea behind object-oriented programming. And we've done just that here. This projectile has a projectile speed of 10, but I could take this projectile script and drag it on another projectile prefab. If I want to create a whole nother one of these guys, or even if I instantiate one of these guys and then come in and set just his speed to something different, he's got a different state than the other guy. So they're each unique at that point. The reason I'm pointing this out is if I was to just do, your regular public float, or in this case, we don't even need to do float. So we're going to do an int, and I did score. And let's start score. We're going to initialize it right out the gate to 0. And if I did a public int lives, and I initialize that right out the door to 3. So we start the game off with 3 lives. What we've just done is we have set these up as instanced variables, okay, or instanced data members of my player class. That means if we were to have multiple players, they would all have their own copies of score and lives.
Right.
In this case, we want to make sure that everybody can access the score and the lives. It's just a single-player game. So what I'm going to do is I'm going to take these guys and make them static. So if I say public static, like such, we only have score and lives in existence once, and they belong to the class player. They're not instantiated with a player, meaning that when I drag the player script onto a game object, we're not going to be able to set the score and the lives on that game object differently than if we were to drag the player script onto another game object. So these guys stand on their own. Does that make sense?
Yeah, they're going to be kind of universal. The same fields will apply to all instances of this class.
That's right, because these don't belong to any instance.
Right.
They belong only to the class itself.
Okay.
So to access score, I would need to say player.score to talk to, and I'm saying player with a capital P. I would need to actually say the type dot score.
Well, you summed it up right there when you said that it doesn't really belong to the instance. It actually belongs to the class itself.
That's right. So that's what I wanted to point out. Using static methods, static fields, very helpful, and that's something that we'll get more into later on.
Okay.
But anyway, so now we only have a score and a life that's in existence once. And with that, next thing we need to do is let's start showing some stuff up on the screen. So with that, we're going to make use of the Unity GUI system that I was talking about at the beginning of this video. So we've got update, and up under update, we're going to create a new function. Again, this is already available to us in mono behavior. We're just going to override it. It's void on GUI, graphical user interface. Again, this guy is going to be called every frame. Depending on how complex your GUI is, it could end up having this function called multiple times in a frame, depending on events. So inside here, what I'm going to do is I am going to simply draw some labels to our screen. And there's a lot of different kinds of GUI controls that we can work with. Things such as the GUI button, the GUI label. We have a text field if we want to type in some text or have a user type in some text. We have a toolbar. There's all sorts of things.
So all the different controls you'd need to create a user interface.
Oh, yeah, there's a lot of good stuff.
Okay.
Now, Lee and I have designed our own GUI system that will work on the iPhone. And perhaps that's something that I can look at teaching people a little bit later on. But it's packaged up in such a way that you feel like you're working with WinForms, which is really nice because you can say button, my button equals a new button, and then you can set its parent and
very nice.
Set its width and height. When we work with GUI controls here, it's all in line, and that's going to make a lot of sense in just a minute.
Yeah.
So let's start out by using our very first GUI control. We're going to use a label. So here's how we do it. We start out with GUI dot. Now we tell it what control that we're looking for. In this case, we're going to do a label. Now, there's two key things that you're going to give to a control. You're always going to give it a rect and you're always going to give it its content, okay? And content can be several different things depending on what type of control you're working with. In this case, we're simply going to give a rect that is going to be responsible for positioning him and setting a width and a height. And the content is going to simply be a string. So let's put that together real quick. So the rect, new rect, and again, for those of you that are coming from the JavaScript world, you're not used to seeing the new, just like when working with the vector 3, we're always saying we're making a new vector 3 object. Here we're making a new rect, and you can see that Visual Studio is quite intelligent. It says, hey, this is what you obviously are going to use. And with this rect, we're going to be specifying a left, a top, a width, and a height for this guy. So starting off with our left, this is going to be in X, how many pixels? Say we want to move over 10 pixels. In Y, say we want to move 10 pixels from the top in Y. Now a width, let's say, I don't know, about 60 pixels will work. And a height for this guy, about 20 pixels will work.
And this may be one of those things where you might need to test it if you're using other words.
Yeah. And the interesting thing is, in fact, I'll see if I can work it in here in just a little bit when we start working with the button. All of these guys, when I'm coding, are actually variables are going to be used in here. Fields that we would then put in the class itself that would specify the width of something, etc. And you can, you can get even more sophisticated by using your content and figuring out what the width and the height of the text that you're going to use, and then have those numbers get applied automatically.
Just to help you with formatting.
But, you know, that gets a bit more involved. So we're going to keep things simple. So we're going to say about 60 pixels wide, 20 pixels tall, and we've given it 10 by 10.
Now that calculates from the upper left corner of the screen.
That's right.
Okay.
So now we'll go ahead and comma, and then go ahead and give it our content, which is going to be score, colon, space, and I'm just going to use the old-fashioned concatenation here. So we'll append to the end of this string player. So this is where things get interesting. Player dot score. So instead of just saying score, because we would be looking at ourselves like an instance, we're going to say the player, the class. And as a matter of fact, you can see with the pop-up tip right there, the tooltip, that we have class player. So the player score, because we only have that in place once, and before I terminate that, let's go ahead and close that off, then terminate it. So now we're simply saying, all right, on every frame, we're going to draw a GUI label at this position, and it's going to say score with whatever our score is. So let's go ahead and save this out. We could get even more specific and jump in here and say to string if we want it to be a little more proper here, just to go ahead and have that converted over to a string for us.
Do you have to do that?
It's a good idea too.
Okay.
So let's go ahead and save, jump back over here, and hit play, and you can see we now have score 0.
Yeah.
So that's working. Excellent. Let's now jump back in, and the next one, same thing, is going to be a GUI label, again with a new rect. And this guy, we've now moved down some, so still looking at 10 pixels over so that they are left aligned with one another. But now we're moving down 30 pixels. And again, we'll stick with 60, and we'll stick with 20. And for this, we'll say lives. Put the space in there, and we're going to append to the end of this string. We are going to do player.lives. And we'll go ahead and convert this over to a string, and we'll close that off. So,
but right now, these are just pretty letters and numbers. They don't actually do anything, right?
They don't actually do anything. Yes and no. I mean, we are referencing the real score and lives.
Right.
We're just not manipulating these guys yet.
Right. You've stored a variable and you're showing that on the screen, but that variable isn't being updated in any way.
That's right. Not yet. But as soon as we make this update, we won't have to do anything else on GUI right here.
Right.
On GUI, it's handling it. It's just going to take whatever lives currently is.
Because it's checking every frame to see if it should be changing that.
You got it. So let's save this out and make sure that everything aligns nicely. So come in here and hit play. And there we are with score, and there we are with lives.
Nice.
Good to me.
Yeah.
And, yeah, I guess with that, we can go ahead and take a look at getting everything hooked up. Now, the interesting thing is, how long is this video? Oh, wow, we're already at 16 minutes. Yeah, I guess we'll go ahead and cut it here. I was going to look at tying the two videos together. That's okay. So a quick recap. What's handling all of this for us is the fact that we've got this on GUI call. Mm-hmm. If we would have, here's just something interesting to note. If we would have tried taking these and coming up here into our update function, okay, so we're in update, which we know gets called every single frame, and save this out and jump back over here and run this, what you can't see is all the errors we're getting.
Oh, goodness.
You can only call GUI functions from inside on GUI. We can't put those over there. So we need to jump back in here. I just wanted to show that real quick. We've got to have on GUI available, and that is where we put our code. So buttons, labels, everything we would put inside of on GUI. Now check this out. I could have my own custom function, void build UI. And I can take this code and I can paste that down here. And inside of on GUI, I can call build UI.
Okay, that makes sense.
I just want to point that out because when we come back in and we redo this, for those that watch the next step after this video series here with the same game, one of the things we're going to do is we're going to create our own mini WinForms system so that we're working with screens and we're working with controls, but we're still going to be using the Unity GUI system, but we're going to be doing things like this. We're simply going to offload the actual construction of these objects through the call, these function calls, label, etc. We're going to be pushing those off to somebody else. All that's going to be hidden under the hood.
Sure.
That's what I'm getting at. So we will be able to, even with this simple system, do things like label, score label equals new label, and then give it a label dot bounds, or we could even say label dot x equals this, label dot y equals that, label dot text equals this, and that's all we just put that in one time.
But then later on in like on GUI, you could say like draw score and draw lives.
All of that will be automatic and will handle itself.
Okay.
It's a nifty little system.
Yeah.
But that's something we'll talk about a little bit later. It's very powerful, but it does make working with this stuff real easy. Not to say that the GUI stuff is complex. It's very nice having it all inline, but sometimes you may want to work with it not so inline. Just basically package it all up kind of like an object, pass it around if need be. So we've got this set up. So with that, we're going to bring this video to a close, and in the next video, we will, you know what? Hang on. You know, I'm just thinking about it, and we could just go in and, okay, no, I'm not. We'll get back to it. I so desperately wanted to just add more, but I'm looking at some notes that I've got written down, and I shouldn't be pushing it. So with that, we'll wrap things up right here, and I'll see you guys in the next video. And we're back. Welcome. All right, continuing on. You like that for a formal welcome back.
That was nice.
So in the last video, we took advantage of the Unity GUI system, and we had some labels that are now being presented on our game screen showing us our score and our lives. And at the end of that video, I was really itching to hook something up, make something work other than just the text showing out. And or showing up, excuse me.
And I'm over here like tapping my wrist, shaking my head, going, no.
And what you guys cannot see is exactly what Zach just said. And that's we kind of have a bet going that I've already lost about 8 or 9 times now.
And it has nothing to do with how well he plays this game, by the way.
That's right. It unfortunately has to do with how much I talk. And I know that there are those of you out there that may not care for my particular style because I can talk for a very long time sometimes. But I really did want to put something in, and I should have. So I decided in this video to have Zach tell me, how do I need to put this in? I want to increment my score. That's all I'm interested in.
Okay. Well, you're going to need some sort of event which can trigger the score changing.
Okay.
And you've already got the trigger event, which takes place when a projectile hits an enemy. That seems like a prime location to...
Where do I go?
Isn't that located inside the projectile?
That's correct. Let's go to projectile. Okay.
And you got the, on trigger enter. So now you're going to need to talk to player.score.
Sounds very nice to me. So let's just say that, right, we could put it anywhere in there, but let's put it right here. Nah, I'm so picky. Player, as you just said, dot score.
Now, do we need to set up like what we did before, where we've got to? I think of everything in analogy. So it was like we opened up the comm channel before we talked to the enemy. Do we need to do something similar here?
That's actually an outstanding question, because here's the comm channel as you're discussing.
Yeah, it's when we had to talk to the enemy, we had to do this really. I kept calling it the counterintuitive line of code,
and it's not counterintuitive.
It just seemed it's not something.
Keep trying to tell you
to.
that off camera. No, it makes perfect sense. But what we're doing here, we're storing a reference to that instance of the enemy script. What did I say about the score and the lives? They're static. They're not instanced variables.
Okay.
Since they're not instanced variables, I don't have to grab an instance to the player's
So you can talk directly
component.
to the class and that'll work
to the
just
class.
fine. Okay.
Absolutely.
All right.
So and you're doing that. You've already got that rocking and rolling right here.
Player.score is fine. So can you do what? Plus equals 1?
Wow, you don't want to give much for a score, do you?
Oh, you want to give 100. Oh,
Let's make it feel like, he was worth something. 1. Wow. So we're going to increment, and for those of you that don't know, player.score plus equals, this is the same thing as typing player.score equals player.score plus 100. But
was it okay? So the side of your jet fighter, it looks like you've killed a lot of bad guys, but
hey, man, I'm just, one.
No, you're right. You're right.
So we'll give it 100. So we've got that set up. Let's make sure everything now works. So we'll come back over here. We'll hit play and look at the score.
Okay, yeah, that was easy.
So everything just works. Destroy, just rain down projectiles.
And suddenly your numbers just disappeared.
Numbers disappeared.
Let me guess.
Okay, good.
Your rectangle is a little too small to hold that many numbers.
So what do I need to do?
You need to jump back to your score and increase the rectangle size.
So where's that at?
That's over inside the player.
Inside the player where?
Well, jump down. It's under your...
Darn it. Man, we're looking right at the function.
It's on your build UI.
Okay, so build UI, here we are.
So go grab your label where you're actually setting up the score. And let's see, you've set that to 60. I don't know, crank it up to 120.
Okay, we'll double it in size, hit save, come back over here, show my mad arcade skills. Oh, yeah. No! Oh, be quiet. I got him.
You did. You got him in the end. You like scaring him. It's scare tactics.
I'm going to scale these projectiles, these capsules, Tylenol capsules, as you were calling them, up in the end. So
looks like you're working now.
Now you can see we're fitting just fine.
So really, you just want to kind of get an idea of the biggest score a player could get, and just make sure you got that much space in pixels to plug your numbers in.
That's right. And again, there's things like styles and skins, and there's functionality in place that allows you to, grab a context and figure out how wide it is. I'd look at doing stuff like that. It gets a little bit more involved, but here, come in there and put 300 in. I mean, somebody's going to get one massive score before you run into any type of problem.
Sure.
And just to point this out, if the label height would have been larger, it would have wrapped around for us. So just point that out.
And, I would like to point out that if you just let the score stay at 1, it would have, really taken a long time to have that problem.
Oh, look at you at 3:35 in the morning. While I'm here, I'm going to go ahead and cut that. Put that back
Put
up
it back
here.
over here. Okay.
Because there's no real justification to calling the build UI. That function call doesn't need to be there. On GUI, do the GUI stuff. End of story. So let's go ahead and save. And with that, we are now incrementing our score system. And Zach did that all on his own. So very good job, sir.
I'm just thrilled I can pull it off. I can barely see the screen from
actually
here.
Contribute to. That's true. What you guys don't realize is Zach damaged his glasses the other day in the oddest of ways. But to say the least, right now he is not able to see, period.
So I'm not quite blind. Anyway.
So with that, that is going to wrap up this very quick video, just showing you guys how we can get score, something that's now being utilized by the game. Thanks a lot, guys. So welcome back, guys. This video, what we're going to do is set up the collision event between our player and our enemy so that when that enemy hits me, which seems to be quite a bit while I'm playing the game, my player will get destroyed. And on the destruction of the player, we're going to make sure that our lives get decremented. Now, I'd like to point out that we're not going to be deleting our player for real. We're going to do something interesting that is going to, we're going to get everything in place. And then in the next video, we're going to introduce coroutines, which are extremely powerful. And we're going to use coroutines to make our enemy vanish when we've been struck by an enemy, make our player vanish.
Yeah.
And then, so player vanishes and a particle explosion goes off, indicating that, yep, we just died. And then X amount of time later, like 1.5 seconds or 2 seconds, our guy will then reappear in the center of the screen. But we'll talk about that in the next video. Just want you to know that it is coming up. In this one, the first thing that we need to get in place is the on-trigger event. Just like we did over here in Projectile, we've got this on-trigger event that is going to be triggered by Unity when we have a collision occur between a projectile and an enemy. Well, let's go ahead and just copy all of this code just to make things a little easier for us. So highlight it, Control-C, and then I'm going to jump over to the player. And then on the player, let's just come over here and paste this because it'll work just fine. And we already have some stuff set up for us quite nicely. We are going to still need to get a reference for the guy because we are going to need to reset him. Makes sense. And with that, we don't need anybody destroyed. So let's go ahead and kill out the destroy line. As far as our explosion goes, let's just grab him real quick and cut, move him just somewhere out of the way because I'm going to comment him at the moment. And with him like such, of course, we have this not understanding who is our explosion prefab at the moment. We'll take care of that coming up here in just a second. So enemy, and we're resetting him. Player score, I don't think it should go up if you...
well, you did destroy the enemy.
If you get it true. But what we're going to do is we're going to tell the enemy, the player, that his lives need to decrement by 1. So we'll just simply do minus minus. So that's the same thing as saying player.lives equals player.lives minus 1.
Okay.
And we can say plus plus to increment by 1 as well. Now, just to reorganize this a little bit, or to organize it, let me move that up right here at the top. Very first thing I want to happen, boom, you've been hit and killed. Let's go ahead and decrement our lives. Let's get a reference to our enemy. Let's reset our enemy back to the top. Now, at this point in time, we're not doing anything with our player. We're not instantiating an explosion or anything. That's okay. We'll come back to that in a second. Let's just verify that the moment the enemy collides with us, we could even go as far as to do a debug.log and say we've been hit, like such. So we'll save that out. We'll jump back over here, and we will, are we getting hit? Let's see. And we are not getting hit. So let's take a look at what we are missing here. So with our player, and our player has a collide. Check it out. Remember the rules that we established earlier. First rule, at least one of the two objects must have a rigid body on it. We do not have a rigid body available on this guy. If we select this guy here, our enemy, we do not have a rigid body here. So we've already broke the first rule. So I'm just going to grab my player. With my player selected, let's go ahead and come up here to component, come down to physics. Let's apply a rigid body component. And then, as you guys have seen before, I'm going to take use gravity, turn it off, is kinematic, turn it on. By doing just that, now I'm going to come up here and hit play. He comes down. We've been hit.
Nice.
And by bringing this over.
See that in the log.
Yeah, we can see it over here, so let's get hit one more time. And the moment we hit, you'll notice he does not finish. I'm trying to hit just the corner of the player. He is indeed resetting to a random position with a random speed back to the top.
Nice.
Oh, wow, he just slid right down the side. Okay, so this is working perfectly. Let's go ahead and move the console panel off and stop. So let's jump back in here. Now, let's get an explosion set up.
Okay.
So I'm going to link up an explosion. So I need a prefab, so we can come back up to the top and do another public game object, and we can call this explosion prefab. Now I can drag the explosion that we currently have over, or I can duplicate it and change a few things just to make it look a little different than
Sure.
the enemy's explosion. We use a different kind of fuel.
Sure, change things up a little bit.
So we'll grab our explosion prefab over here. And then with our explosion prefab, I'll just hit Control D, and that's going to duplicate it. I'm going to change the name of it to Explosion Prefab 2. Okay. Now, we need to change some stuff up. Zach wanted purple really bad at one point, so we're going to give him his favorite color of purple.
Go from white to purple.
And another.
That way it'll be,
okay,
it'll be like really
I'm-
bright at the core.
Yeah, absolutely. So let's go back to a very hello. Let's go back to a very bright, almost white,
Yeah.
and then we'll just
And just to kind of gradate your way down.
yep, and bring it in and such.
Oh, it's turning pink now. It's okay. I mean,
I'm just afraid of how happy you're going to get.
an explosion of pink.
Yeah, exactly. So this should definitely come off as a different explosion
Different would be the word
than
for it.
our first guy. So first guy, those colors. New guy, these colors. Okay, so we have that set up. We could do something like our energy. Come up here. So we've got a min of 0.2. Let's change it. Maybe something like 0.1, and so we could go from 0.1 to 0.75. Just so we've got something different. Okay. Now we already have audio set up on this guy. So, and that audio is being told to play when this thing is instantiated, so on awake. Another thing I'd like to point out is that when you are creating your sound effects, make several explosions. So then you could have a different explosion in here too. It just really,
Sure.
keeps the game exciting. So with all of that in place, now what we need to do is our player, if we come over here to the player script, the explosion prefab, the field that we just added, the public field that we just added to the class player, needs something assigned to it. So let's grab Zach's explosion and drag it over here. So now that we have that in place, we need to do something to instantiate it. And we've already seen how we can go about instantiating these prefabs. So we can just come on down here, take we've been hit out because, well, we know we've been hit. And then we can simply instantiate this guy. But the position in which we instantiate him needs to be what, Zach?
Location of the player.
Needs to be location of the player. So that means I can just come right in and say transform dot position. As a matter of fact, aren't we caching this guy, or was that on something else? Projectile prefab, blah, blah, blah. No, it was over on the projectile, so we did need to do that. And then we'll do quaternion dot identity. So there we go. Let's go ahead and save. This is going to instantiate, make sure that is what we called it, explosion prefab. This is going to instantiate whatever has been assigned or linked back over in the inspector, which is explosion number 2. And it's going to put us at the player's position and no rotation whatsoever. We're going to be lined up with the world. So with that being the case, let's come back here and give it a quick shot. So we're playing. Let's get you killed. Boom. Oh. And we now have little purple puffs that come off.
That's not purple.
Pinkish puffs that are coming off. Very pinkish. So there you go.
Yeah.
Pretty simple.
Absolutely.
And let's reach over here for some sound and play with some sound. And yep, we're getting hit.
I hear explosions.
So excellent. The next thing that I would like to do is have him disappear, because I'm not a big fan of seeing him stay visible after I die. So that needs to be set up somehow. We're going to look at that in the next video. But before I sign off, I do want to point out that our player minus is indeed working.
Yeah.
Our lives are currently at -5, so and -6, as we just lost another.
Yeah.
So our GUI is working just fine, our little HUD here, and everything else that we've set up so far is working fantastic. So in the next video, let's see what we can do to make this guy disappear for a second and a half or 2 seconds and then reappear back in the center.
Okay.
So that's going to wrap up this video. Thanks, guys. So in this video, we're going to be taking a very quick look at coroutines. Coroutines are very powerful. Basically, a coroutine is a function that can suspend its execution for a specified amount of time.
Okay.
And we're going to be able to control the time in which the execution will resume within a particular function.
So instead of saying ready, set, go, it says ready, set, wait for it, go.
It's kind of an odd analogy, but sure, Zach. At 4 in the morning, that sounds fantastic. So now, this is definitely a much more advanced topic than the idea of just simply showing a simple game. And we don't need to do this. But again, I would like to take our player and have our player disappear for a predetermined amount of time and then reappear centered back up. And that's kind of how it is in video games, right, Zach?
Sure, sure. Well, I mean,
is it?
Well, I mean, in a video game, you're going to get hit by something, and then you're going to blow up, and then there'll be nothing for a moment. Usually, well, on these shooters, I'm used to, like, you see the player kind of slide in from the bottom of the screen, and for the first few seconds, they're blinking because they're invincible, and I always make use of that to get a few scores in before I can take damage.
So while he's blinking, you can still fire and move him.
In some games, yes. Some games, no.
But he's at that point he's
invincible.
Okay.
It's not like you can immediately die again if another enemy plows into him.
Okay, so it gives you an opportunity to get out of the way.
Yeah.
You were so unlucky as to spawn back in right as an enemy is about to collide in.
Right.
To your
So
location.
it kind of gets you back into the groove for just a moment before the action kicks back up.
Okay.
And some of them will even have like a message on the screen. So it's like while you're blinking, it'll say, get ready. And then as soon as you start playing, it'll say like go or something like that.
Well, how about once we get everything wrapped up and we have the screens and all that, we'll just append that to the end and we'll revisit this. How about we do that?
Cool.
Because we're going to change our geometry out in the end. We're not going to stick with a cube. We're going to put a real ship in here.
Yeah.
So how about have that ship slide back on and have them blink and allow you to move them around. And during the state, if you will, he's invincible.
Sounds good.
Okay. So starting out simple, though, we're going to use a coroutine to allow us to halt or yield execution until a predetermined amount of time goes by. So how do we set this up? It's actually pretty simple. It looks a bit different than you will find over in the JavaScript execution of the same coroutine concept. So keep that in mind. All we need to do is come down and create a new function here inside of our player class. And this function is going to be called destroy ship. Now you notice that so far all of our functions have returned void. We're going to actually return an interface. We're going to return an enumerator, okay? But that's all you need to know. If you're curious and you want to go and you want to look it up and see what the type is, have a good time.
Yes.
But this is what we're going to return back. So enumerator, and then we'll take enumerator and space. Let's go ahead and give our function name destroy ship. Now inside destroy ship, this is where we can put our code, including the ability to yield for a certain amount of time. So let me go ahead and grab some stuff and move down to it. So we're going to grab our instantiate right here. And you'll notice that at the moment, by the way, we've got this guy's underlined red, and you'll see that we have an error down here saying that not all code paths return a value. We haven't seen that before because we've always said that the functions have been void. They don't return anything. So I was just saying we are returning something back here.
But we haven't established the return yet.
That's right. We're going to see return pop up in a minute with yield when we halt execution for a given amount of time. So I'm going to take my instantiation of the explosion and cut that, move him down here. The reason I'm doing that is because I want to keep my onTrigger enter function very clean. All I need to do is simply call destroy ship, and I don't need to worry about it anymore as far as our onTrigger enter function goes. So we're going to spawn or instantiate our explosion. Now I want to hide my player, so it looks like we truly were destroyed. So the way I can go about that is I can just say, hey, game object, let's talk to our renderer. And on the renderer, what I'd like to do is disable this guy. So I'm going to disable an actual component here. And to do that, I can just simply say enabled equals false. So we've turned him off. So now what I'm going to do is jump down and center him up, because with him invisible, we can kind of sneak in there and move him around. Nobody will see anything.
So he's there. He's just not being drawn.
You got it. So I'm going to talk to the transform. On the transform, let's talk to the position. And then let's go ahead and generate a new vector 3. And again, we'll just spell it out. We want him 0 in X, and then we're going to put him back at our transforms position Y and our transforms position Z, like such. Okay? So we have centered him up. We've kept our Y and we've kept our Z values. So now that he's been centered up, I don't want anything to happen to him for the next, let's go with a second and a half.
Mm-hmm.
For the next second and a half, I want him to stay in this state. So I can, this is the cool thing about coroutines, I can actually yield execution of this function for a determined amount of time. So I'm going to do that by saying yield. There's my return. So now I'm about to return something. I am going to return a new, and then we're going to tell it that we're going to wait for a certain amount of time. So return a new, and how do we tell it to wait? By just simply saying wait for, I've got end of frame, I've got fixed update, wait for seconds. So that's time. So let's go in for wait for seconds, and I am giving it a float value that is, as you can see there, seconds. Let's just say 1.5 seconds. That's it. That will halt this execution. It doesn't halt the game. It doesn't halt the functionality of our player component here. But when 1.5 seconds has ticked away, then we are going to continue execution inside this function. And that's very powerful.
So this ability to wait like this is something that is a part of a coroutine.
That's right.
Okay.
So now I just need to come back in here and tell this guy that we are going to turn his visibility back on. So we're going to talk to the renderer again. And let me stay consistent with above. I was wanting to make the whole thing very clear, since this was the first time talking directly to the renderer by talking to the game object first. But talk to the renderer, and then we're going to say enabled is equal to true. Okay? So now we've made him visible.
Now, let me ask you this. Can the player still move the ship around while it's invisible?
Well, think about it.
It seems like they should be able to.
They can.
Okay.
Absolutely. And that'll play in well with what you're talking about with it blinking and still being able to move. We can use that to our advantage. But we can disable that if we wanted to. Now, what I wanted to show right now before we move on and demonstrate this in action is that everything looks like it would work just fine.
Mm-hmm.
But where does the whole idea of a coroutine come in? I mean, we're doing a regular function call. We've got a regular function call right here.
Mm-hmm.
But what gives? Here's what gives. It's not just a regular function call that we do. We're going to use some functionality that's in place with Unity called start coroutine. We've seen functionality such as destroy and instantiate. Another one that we have is simply start coroutine. Open parentheses. And here we are with our coroutine looking for an I enumerator and the routine that we look to call. So all I need to do is go ahead and put my closing parentheses in there. Notice, no errors with this, but there were also no errors with what we had a second ago. This is how we set that coroutine up. Let's go ahead and save, and let's come back into Unity and execute. So come in and we die. Look at that.
So nothing, and then boom, he pops back in. Very nice.
So now it does give us the sensation of being destroyed. I'm
not saying anything.
Yeah. Oh, we're going to change the game and put a mist. All right, fine. You're laughing. Let's put a mist up there real quick. How do I do it? Come on. Snappy.
Put a mist?
Yeah.
Which means, well, you'd have to.
What do I do? Come on.
When the enemy hits the bottom of the screen,
okay.
You're going to need to fire off something.
Oh, you're too slow, Zach. First thing we need is a field to keep track of this, right?
Sure.
Right, good. So what do I type? Good. Public static int missed.
I'm telling him with my mind.
He is. Okay, so we now have mist in there.
Okay, I wasn't sure the angle. I thought maybe you were going to put like a big message in the middle of this.
No, let's just put mist up there. I want you to walk me through what we need.
All right, we just need to increment
those people that don't like us, just jumping off on tangents. We're done with showing what we wanted to show. They can hit stop on the video. That's the power of a video player.
Well, over in the enemy, you had the if statement that was checking to see if they'd pass the bottom of the screen, didn't you?
Over in the enemy. Okay, so we're over here in the enemy, and we've got an update.
If transform position.y is less than some stuff, jump down under there and you need to increment your mist.
Look at you go. And how do I access that?
Player.mist.
Outstanding.
++.
Player.mist. Ooh, look at you go. ++. Okay, fantastic. This is going to make the mist value increment every time we miss him. Fantastic. Okay, so now what? Are we done?
I think so.
Think so? Stop. Play. And where's mist?
Oh, we're not drawing it yet. We got to give it a rectangle and a position and all that.
Okay, so let's jump back in here. Where do I need to go?
Into your on GUI. In your you're sticking it in the player.
We're going back to the player.
Yeah, actually, I expect it to be in like a game kind of class.
Thank you. That's why for this very simple example, this all works well. But when we come back in and tear this back apart and put it together with a different foundation, different infrastructure, you're going to find it set up just like that. It will reside. Actually, it's going to reside in a HUD, and the game will on an instance of a HUD, which is pretty cool.
I gotcha.
So
I would just grab one of those lines of code and duplicate it, and then you just
like the sound of that. I'll grab this top one since I seem to miss a lot. It's a little wider.
I was going to say we could just go ahead and set that value up to something like from 120 to 620 or something.
So we'll just come in here and put mist.
Yeah. And then you need to change your vertical offset to, say, 50? You're increasing by 20 each time?
So we'll take this guy, and let's go ahead and make sure that we are addressing the mist guy. And you said put him at 50? Now save. Well, the good news is this is showing me that you are indeed learning, because we now see mist, and we've missed one. We've missed two, so now we have a way of ending the game outside of... Well, every time you miss, we could slow the enemy down.
You apparently need help.
Well, this helps. So now we've got our HUD is all sorts of...
Eventually they start flying backwards.
We are able to destroy enemies. We are able to be destroyed. We disappear, then reappear in the center.
We have lives that are counting down. We have a score that's counting up.
So we have particle effects. We have sounds that are playing.
Yeah.
We've got a lot going on.
Most of the game.
And I know these videos have been a bit long, but I'm also doing what I do best. I'm doing a lot of talking and trying to just point different things out. But you could sit down and put this guy together in less than half an hour.
Sure.
Easily. I mean, there's no problem at all. It's just because it's so straightforward and simple. The beauty of working with Unity. But a quick recap. Thank you very much, Zach, for putting this together for me. A quick recap. The idea of this video was to demonstrate how we could go about implementing a coroutine, a special kind of function that has the ability to be suspended. That's not really a special kind of function, but let's just say it's a function that can yield execution, and in this case we are yielding it for a given amount of time. And it works towards our advantage because we're able to hide our guy, center our guy, wait a little bit while the game continues to run, and then show him. Okay, so with that, that is going to wrap up this video. In the next video, we're going to take a look at setting up all of our different scenes so that when a player begins the game, they can see some instructions as Casey had set up in his demonstration, and then they can hit a button to start the game. So that's going to wrap things up. Thanks a lot. Okay, so at this point, we pretty much have everything in place and functioning perfectly for our game. We're just missing a few things. We're missing our start screen where a player can, hit the start button. Right now we hit play and we're playing, period. But when we build our game, they're not going to have the play button that we have right now let me just jump back over here in the Unity editor. So we need to set up a screen, a main menu screen as I'm going to call it, that will give a few instructions, again, following along with what Casey did, and allow a player to hit the play button or start or whatever we're going to call it. And then the game begins. And then from there, We can lose by running out of lives, which is good. And we need a screen to go to say we've lost, and then the ability to hit play and start back up again. Right. And we also need a screen where if we win, so we need to come up with some sort of rule for winning. We have an easy one for having lost. And then we need to have a win screen show up, and again, the ability to hit start and start playing again.
Sure.
So then we've kind of packaged everything up, and it's a complete game at that point. So to get this in place, what we're going to do is we're going to take advantage of scenes. We are using a scene right now. If everybody recalls, back at the beginning when we kicked the project off, the very first thing we did was we created a scenes folder, and then inside that scenes folder, we saved the scene that was the default scene that started out. We saved it as level 1, which means we could then have a level 2, and we could have 2 guys coming down, or a different background. Right now we don't have much of a background, but you get the idea. You could actually have levels. If you're going to work in a game such as this, where here we've got just one player and there is no real concept of levels, or if the concept with levels was something really simple, meaning, you know, if you get 5 guys in a row, we bump it up to level 2. Now you've got to get 10 guys in a row, and then we bump up to level 3, so on and so forth. You could keep everything confined to a single scene. But if you were to turn around and create a first-person shooter where you have a level that you're running through,
yeah, it's like a physical stage.
And use Unity. Unity is a very powerful editor. So you'd have your level that's saved out, giving it whatever name you want to call it, and then come up in here and you start working with all of your geometry. You create your walls and you put all your models in. You light it. You get everything set up the way you want it. And you know you have where your player is going to spawn in and your enemies, etc. And then, in exiting out of that level and going to another level, then you really would want to make use of scenes.
Right.
Because that allows you to work inside the scene itself or the level as if you were working in any of the other level editors that are available today, like working with good old Quake stuff or Unreal stuff or Half-Life stuff, etc.
Sure.
So while Unity does allow you to come in and quite quickly build fully functional games, don't forget it's a very powerful 3D editor as well. So when we reanalyze this game and we put a different infrastructure in place, the entire thing will take place in a single scene. Okay, I want you to, just in the back of your mind, realize that we do not have to use scenes the way that I'm about to show you. I'm really glad that Casey did in his project just to show people how to jump from scene to scene. But when we redo this, we're just going to have one scene, and that scene, we're going to come up with a class type of screens, and we're going to be able to show screens based off of a given state that we're in. So states will actually have associated screens with them.
Okay.
And then these screens will basically encompass a bunch of controls. And then they're going to have their controls positioned properly, so you can have menu screens and your game screen, etc. But we'll be able to keep everything in a single scene. And the reason I'm saying that now is I just want everybody to keep in mind that we're not limited to just one way of doing something in Unity. We have multiple ways of doing stuff. But this way is going to show us how we can jump from scene to scene. So let's go ahead and come up here, File, Save our scene. Let's save this guy. So our scene, level 1, is currently saved. Now let's do a new scene. So coming up here to File, do a new scene. Here we are with a new scene. Let's go ahead and save this guy. I'm going to do a File, Save Scene, or Save Scene As, doesn't matter. And I'm going to jump into my scenes, and let's call this Main Menu. And we'll hit Save. Okay.
You're not going to put anything else in here right now.
So right now, nothing else is going to be in here. You'll notice over here, up under our Scenes folder, as a matter of fact, since we're done with pretty much all of our game stuff, well, we're going to come back to scripts. Let's go ahead and close up sounds. There we go. So nice and neat. I like that over here. It's very important. So scenes, we got level 1. We've got main menu. And let's go ahead, just keep things simple. We'll just work with this camera, and we can come in here, and if we want, we can make it a black background like such. Everything else is irrelevant to me because we're going to use this simply for GUI display. That's all. So now that we have set up our main menu, and I'll just go ahead and hit Control-S to make sure that our scene is saved. Now, let's come in here and do a Save Scene As. So we'll save it with the way it's set up. Back up under Scenes. And let's create a new scene, and we're going to call this scene win. So this will be the scene displayed to you when you win.
Mm-hmm.
And then file, save scene as, and let's call this one, again, back up under scenes, lose.
Lose. Yeah.
All right. So now we've got some scenes in place. So how do these guys all interact with one another? How do you go from one to another? Well, first thing is if we come up here to File and we come down to Build Settings. In the Build Settings, we have to supply the scenes that are going to be built into our game.
Mm-hmm.
Okay, so right now we are not specifying any scenes. So when we go to build our game, we don't have anything. So what I'm going to do is I'm going to come over here and I'm going to start dragging my scenes in. We're going to start out with our main menu scene. And it's not so much the order. We are going to, I'm going to start out with 0. So this will be our first scene that we're going to have. But the number that you see over here on the right-hand side, the index of each of the different scenes, that's the key thing that you'll need to remember. So that when you call upon an application, the application that you're in, and you have it go to another scene or load in another scene, you're going to be providing the index number. Okay. And that's how you'll get to those.
All right.
So we're going to start out with our main menu, and from there we'll be going into level 1, and then you may lose the game or you may win the game. 0, 1, 2, 3. So you can see our number increasing there. So, and you can also see just while we're in here how we can easily change this from a web player to a web player streamed, Windows standalone. I mean, there's all sorts of things in here. Mm-hmm. So now that we have all of that set up, at the moment we're still inside of our lose scene. And what I'd like to do is start working with our main menu. So this is our very first screen that we want to be presented with when the game launches up. So we need to make sure that that one is opened up. So I'm just going to come over here to Scenes, and with our main menu, double click it so you can see that we are now in our main menu scene. So don't get confused with that. It's very easy to do work in the wrong scene.
Yeah, just keep an eye on the top bar there.
Exactly. So here we are inside of the scene. Now, what is it that we want to do, and how do we actually apply code here if we don't have any game objects? Well, we do have a game object. Our camera is a game object with components attached, so we could simply attach a script object to this guy. So it would be our own custom script component that we've added. And that code will respect the regular start, update, on GUI, etc. So we can take advantage of that. So in this case right here, we need to create a new script. So instead of creating it here, just using templates here, let's jump back over the template that we created earlier. We'll do an add, and we're going to do a new item, and it's going to be a mono behavior. And this is going to be our main menu script. And look at that, how convenient.
Nice.
Okay, so now that we have this, do we have anything that we want in our start? Nope. Do we have anything that we want in our update? No. In this particular case, we're going to be working with on GUI. So I just will change update to on GUI. I'm going to take start out just to keep things, looking simple. There we go. Push this down, just being picky as it gets later and later. There we go, looks nice. So now let's start out by giving some instructions, the same as Casey had done in his example. And then we want to turn around and give a button, present a button that the player can press to begin the game.
Okay.
So first things first, let's go ahead and create a string variable that we can use, and we can do it in onGUI, or even better, if we were to do it outside of onGUI, we could just hold a reference to it where it's been created only once as opposed to being created over and over and over and over every time onGUI's hit. So back here, if I did a private string and we call it instruction text, and we go ahead and initialize this right out the door to instructions, colon, I'm going to do an escape character, so \n, so that's going to be a new line.
New line, yeah.
Okay. And now I'm going to say...
Press left and right arrows to move.
Thank you, sir. Left and right.
Arrows to move. Then you need a new line.
And then a new line.
And then underneath that will be press spacebar to fire, period, close quotes.
Press spacebar to fire, period, close quotes, and terminator. All right, so our string is set up only once as opposed to putting a local variable inside a GUI and having it set up over and over and over. Very nice. Now down here in the own GUI, we need to present this label. We're going to put it in the upper left-hand corner, so we're going to do a GUI.label. And we need to provide a new rectangle or a new rect for this. So new rect. And we need to go ahead and give it a location. So we're going to say, again, 10, 10, not 20, 10, there we go, by 200 wide by 200 tall. Make it nice and big. And now for my GUI content, let's just give it our variable. So instruction text, like such. Okay. Let's go ahead and Control Save.
That should work.
Jump back over. So you're happy with that?
We need some way to bring up that screen. If we hit play in here, we should see it.
So if I hit play right now, we're going to see it. And then
should think so.
I don't think so.
You
But let's
think
try.
so? Okay.
Hit play.
All right.
We're missing it.
What are we missing?
I'll see if you can come up with this one. Excellent question. And ladies and gentlemen that are watching this video, please keep in mind at this point it's now 4:30 in the morning. And as it gets later, our thinking ability diminishes.
Are you not rapping enough?
Well, let's get back to the basics.
Okay.
And so this is actually a very good example for anyone that's following along that's new. What's the basics? A game object.
Mm-hmm.
What is a script? It's just a component. So for a script to actually function, it needs to be attached
To some game object.
to a game object.
Okay.
We've created the script.
But we haven't attached it to anything.
You got it. So I can take my main menu right here and just drag and drop it over here on my main camera. That's all I've got to do. Now if we come in and hit play, we have text.
Gotcha.
And it looks like we might want to widen it up just a little bit. But this is great because it does show that it will
wrapping.
word wrap like I was talking about earlier. So let's just jump back over here real quick. And we'll take it up to 250, which I know will be plenty. Large enough. Play. And boom. So instructions, press left and right arrows to move, press spacebar to fire. Now we need a button. Something that we can start the game with. So let's jump back over into Visual Studio. And what I'm going to do is I'm going to set up some more variables containing a width and a height. Again, I can do these as fields or I can do these as local variables. Just value types. I mean, it's going to be cheap to throw them up on the stack over and over and over. But I'm going to set them up as fields. Once again, just so it's done one time in the story. So we're going to do another private. In this case, we're just going to have an integer, and this is going to be my button width. And I'm going to set my button width to 200, a big old wide button. And I'm going to set my button height to a value of 50, like such, okay? And putting the private in here, I'm just making sure it's very clear to anyone looking at that these are private to this class. So now, why did I do this? Well, up to this point, I've been just wiring in what's generally referred to as magic numbers. Now I'm about to start using words, these variable names, that describe exactly what kind of data they hold. And I'm going to use these in some very simple mathematical expressions to control how the button is positioned on the screen. We mentioned earlier that it'd be kind of cool to show how we could go about like centering something up. So this is an excellent place to do it. So for our button, let's go ahead and create it. GUI, not buoy. GUI dot. We have a button. Fantastic. Now let's go ahead and give the button its new rect. So I'm going to say new rect. Now, let's have a little bit of fun here. I want to center this guy up horizontally. So I need to know how wide the screen is. Up until this point, we've just gone and measured everything back in the back. But the game's not really been locked down to just a solid resolution or aspect of like 600 by 450 or whatever. And so at this point, as far as coding goes, I don't care what size you end up having the screen at. I just want to make sure that whatever size it's at, I'm centered up. So we can do that by accessing the screen. And then on the screen, I can access the width. And if I take the width and divide it by 2, that gives me the center of the screen.
Yeah.
But now I need to center the button. So to center the button, if I was to just leave this number right here and hit comma and move on to the top location, the left side of my button is going to start at the center of the screen. So I need to shift the button now to the left to center it up. But I only need to shift it by half of the button's width.
Right.
So I'll subtract away so that I am moving it to the left. So let's go ahead and subtract away from this our button width, divide it by 2, because I only want to go half of the width of the button. That will center me up. Now, with that, let's just give 200 down for the moment. We'll come back and visit height in just a second. We just want to test out our positioning horizontally. And for the width and the height, don't put numbers like 200, 50 in here because you know that that's the width and the height of the button. Use your fields. So I'm going to tell it that we're going to use our button width, and then I'm going to tell it our button height, and then that wraps up our new rect. Now I can say comma, and what do we want the text on the button to say? What do you think? Start game.
Sure.
So we'll throw start game in there. We'll close off the whole button GUI call, and there we go. Let's save. So it looks just like label, except we've now got a little fancy in here. Let's see what that gives us. So we come back over here and we hit play, and wow, my 200 down was a really good guess.
Yeah, it was a really good guess.
It's but it's still not centered. We have more space on the top than we do on the bottom. But look at the button itself. As far as horizontal positioning goes, we're centered up. Excellent. Let's go ahead and stop. And let's take care of centering the height as well. So we'll jump back over here to where we're just saying, look, position it down at 200. Let me jump over to the next line just to keep things looking neat. I'm going to say screen.height. I'm going to divide this by 2. And now this would have the button, the top of the button, starting at the center of the screen, and then it would be drawn downwards from there. So I need to subtract away from that the button's height divided by 2. So we move it up just by half of that.
And I know order of operations takes care of that. It's just when I'm writing stuff like this, I've always got to break it out into parentheses.
So to those of you that want to see it like such, you can. I'll just do it with just the one to show that, of course, order of operations are going to work just fine for us here. There you go. But, of course, multiplication and division.
Sure, always come first.
Then we'll have our addition and subtraction. So screen, the width is being taken care of, comma. Then the height is being taken care of, comma. Then we're telling the button how wide it is, how tall it is. That ends the new rect. And then we give it its content, which is a string in this case, saying start game. So let's go ahead and hit Control-S to save this, jump back over and hit play. And look at that.
Nice.
Oh, yeah. So now we're centered up. Looks beautiful. Now we need functionality. I need to be able to hit the start game. And by hitting this, I need for level 1 to be loaded. Okay. So I need functionality. Let's start with something simple. I hit the button and it sends out to my console, hello world. How appropriate. Let's jump back in. This is where we're doing inline GUI development, meaning we don't have an event that we're going to register to, so we're not establishing any kind of callback to another function, though I'm going to show you guys in the next series recreating this how you can set a system up so that you can then, if you created a new button, you could then subscribe to its on-click event and tell it, you know, this is the guy I want you to call if I'm clicked on. But in this case, it's all in line. And this is extremely powerful, and it's excellent and until, for me, you get into very complex UIs, and it becomes just a little trickier to manage. But again, that is just a personal opinion. So in this case, very simple, though. How do I check to see if you've clicked this button? In line, I can just do it like this. I can simply say, if...
And then put it in parentheses.
Put the whole darn thing in parentheses. And then let me go ahead and block my if in. There you go.
Gotcha.
Now all I need to do is say debug.log and then say hello world.
So buttons just automatically return true if they're clicked? Is that how that works?
You got it. So all set up. Save it out. Jump back over. Hit play. Drag this guy over onto the screen. Hit start. What do you know? Hello world. Ding, 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 ding. And there you go.
Do they just continue returning true as long as they're pressed down?
Hold it down. Nothing, 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 nothing. Let it go where I have actually completed a click.
Okay.
Very important. And why is that? Well, you can cancel your click operation. I mean, you can do it in Windows with pretty much everything.
Slide away from it.
Yep, and very important with the iPhone as well. The iPhone, the old touch up inside, basically you click on a button and you slide your finger off, then you lift your finger up and you've canceled the operation.
Right.
So here, if I press down, slide off, and let go of the mouse, I do not get another Hello World. I have to have clicked down and released on him to actually get that event.
Well, on a device like the iPhone, that would also alleviate the problem of telling the difference between somebody tapping the screen and somebody trying to slide on the screen.
Okay. Of course, but we wouldn't be using on GUI, so we'd be setting up a different system.
I know. But I would like maybe you've got a similar type setup in your game where you may be dragging something around or just clicking on it. So that alleviates that problem.
So next thing we're going to do is we're going to simply replace that code with the code necessary to kick off our game, which is level 1. And if you recall, that was the second screen that we drug into the build settings into our list box there, showing all of the screens that will be built into the game. All we need to do is load that particular number. So this is just very simple. So we'll take our debug out and we'll say application dot load level, and then we pass in the index level 1, which is referencing the level 1 scene. Okay,
our game actually.
Our game. So let's hit Control S to save this out. Come back over here, hit play, and let's see how it looks. All right, all's good. Button, everything's responding well. So let's go ahead and hit start. Up, we're playing a game.
Nice.
Well, no, there we go. We're dead. Oh, but I got the other guy anyway. Score's going up, and now I missed one. Great. Okay, but simple. That's all there is to it. Now we just need to set up a lose and a win screen, and we've completed the game. And then we can just come in, for those of you that can tolerate us just a little longer, with a few quick bonus things, such as replacing some of the models, maybe doing that thing Zach was talking about where we slide the guy in. There's a few things we can do.
Sure.
But that's going to wrap up this video. Thanks a lot, guys. In this video, we're going to get our lose scene set up because the rule is, well, quite simple to know if you've lost the game, and that is all 3 player lives have been destroyed.
Right.
So you should have lost the game, which means we will be showing the lose screen. So before we put the logic in place to load the lose screen, let's spend just a second and set up the GUI stuff for it. So first things first, I'm going to come over here, make sure that our current scene is saved, and let's jump down to our lose scene and make sure he is open. Next thing I want to do is come over here into Visual Studio. Let's create a new script. I'm going to right click, we're going to add a new item, again our own template. We're going to call this just lose. So now we have him in place. I want to come back to the main menu here. Let's copy a few things. I'm going to copy from our main menu, I'm going to copy our button width and our button height. Grab those 2 guys and jump back over into our lose class, and let's just paste them here into fields. There we go. Now let's jump back over to main menu, and I'm going to grab the entire on GUI function and everything in it. And let's jump over to lose. And inside of our functions, I'm going to get rid of both start, update, and replace them with my own GUI function. Okay. I do not care to display the text. There's no reason to display instructions.
Yeah.
At this point, the player is a loser, and he's very sad actually.
Yeah.
So at this point, all we need to do is let them know that they have lost the game. So we could say something like "game over." That's being very nice about it. Check this out. With a button, I can also use the escape character here to give me a new line, and then I can say press to play again. Simple enough.
Cool.
Now, if I was to, well, this guy's already set up. Load level 1. Well, level 1 is our level 1 scene, so that's going to load properly. But we will have a problem. And you know what? I'll show the problem.
Going to go jump straight back to game over?
Well, let's see. First things first, let's jump back here. and make sure that our new lose script has been applied to our camera game object. So now we know this code is going to function.
I see what's going to happen.
So I hit play, and very good. So now at this point, if I was to press it, we jump back into the game.
But now you have no way to call the game over screen again.
So we need to set that logic up. We need to call game over. And when is the game over, Zach?
After you've expelled all of your lives.
Exactly.
Expended all of your lives.
And where do we where are we decrementing our lives at?
Inside the destroy ship coroutine.
Okay, so if we jump back over here and we cruise over here to the player class inside of our destroy ship routine, this is where we are blowing stuff up. Well, we're subtracting our lives up here, but part of our death resides down here in destroy ship.
Okay.
So what we're going to do is cause the explosion, hide our character or player, center him back up on the screen, pause. Now, after pausing, this is an excellent place, logic-wise, to make a decision. Instead of if we are out of lives, if we have no lives left, then there's no reason to enable the renderer for our game object.
Right, no reason to go on.
So what I'm going to do here is simply throw in an if statement and say if our player dot lives is greater than 0. So if it's greater than 0, that means we've got some lives left. Then I am going to enable my renderer. Otherwise, I am going to do an application dot load level, and I'm going to load number 2. So 0 was our main menu, 1 was our level 1, 2 was our lose screen, and 3 was our win screen. So we'll throw this in, terminate. So that's all we have. Save. Now that we have some logic in place to present our lose screen when we do indeed lose, let's see what other problem we have. So we're going to jump back in here and hit play. Game over. Well, let's actually start all the way back from the main menu.
Start from the game.
So I'm going to make sure to save our lose screen. So now here we are back in main menu. We'll hit play.
Are we back in the same situation where it hasn't been attached to a game object?
No, I did that a minute ago.
Okay, all right.
So let's hit play.
Track.
And we're killing stuff and waiting, and 1 life.
1 dead.
Waiting a second and a half, and now here we come with 2 dead. And waiting, and boom. We get to see the beauty behind the coroutine showing itself here as well as earlier. Earlier we used it to wait a minute before showing our player again so that we do get the sense of our player being destroyed.
Yeah.
Here it makes a lot of sense because we get to finish playing out his explosion and death effect.
Right. Otherwise, it would just be like as soon as it touched.
As soon as it touched, you'd go to here, and that would not look good. So look at that. We just picked this up for free.
Gotcha.
But watch the problem we have. So game over. Nice little new line here. Press play, or press play again. So let's go ahead and press to play again. What's the problem?
Our lives are still at 0.
Our lives are still at 0. Oh, boy. And until
but it works because we haven't actually called our coroutine again.
That's right. As soon as we get hit, the routine gets called, and we know we have we have no lives.
Yeah.
So we need to fix that. And the way we're going to fix that is by jumping back over to our lose screen. And in here, once we have received a click on the play again button, but before loading level 1, since our score, our lives, since all of that is static, let's just talk to it. Say player dot. Let's start out with score. Let's reset him back to 0. So you just lost your score. Player dot lives. Let's give you 3 lives again. Player dot missed. Let's reset the number of missed items or enemies.
Okay.
So now we have reset everything, and we load our level. So it's saved. Let's jump back over, hit play, and let's start our game. Let's die 1, die 2, and die 3. And finishes off. Goes to game over. Let's press. Our score is back to 0. Lives are at 3. And missed back to, all right, so
it's counting out.
Let's
Here, shoot something, build up your score if you can.
Yeah, let's build up some score. And 3.
3 in a row.
Yeah, dead center shots. Well, almost. All right, so 700, 1, and 3. So or 4. Let's kill ourselves. And boom. Everything's been reset properly.
Nice.
Okay. Only thing we're missing at this point is a win screen and a call 1-800 if you have any technical issues with this game. So let's go ahead and I guess wrap this video up, and in the next video, we'll take a look at the win screen.
Okay.
Okay, so here we are, pretty much at the end of the simple game that was inspired by Mr. Casey Jones. In this video, we need to set up the logic for winning. So we need to determine what the rule for winning is, and we need a win screen. So that says, hey, you won, and then they can press a button and start playing again. Now, this is where I get my revenge, Zach. We've been working all night long, and you've been riding along as a student, and I've shown you everything you need, really, for us to come up with what needs to be in place to wrap up the game. So we have a scene. So what else do we need to do?
Well, everything seems to be in place. We need to establish what our rule is. Under what circumstances are we going to bring up our win screen? We don't know that yet.
Okay.
Let's say if the player gets a score over 1,000.
Okay, sounds good. All right. So do you want to jump in and put that logic in place first?
That's where I'd go first.
Okay.
And that's going to be over inside of player.
So look at you go. It's determination. Inside a player. I'm inside a player.
Now, we've already got a block of code that is incrementing our score, yeah?
Okay. That would be projectile related.
That's projectile.
That's okay.
All right,
so let's go over into projectile.
All right.
So in projectile, we get our own trigger. And here we are with score. So now we would want to...
Well, you just run an if statement.
Very good. So we'll just simply check the player.score.
Now, couldn't you check this inside the player?
We could check it in the player, but where do you want to check it at? In the update? We don't want to check it when the player gets killed, because that means I may have...
Right.
I could be on a winning streak, which I know is not going to happen with me, but I may be at 50,000 and haven't died once. And then the first time I die, it would go, oh, wow, look at you. You've got over 1,000. You've won the game.
Yeah.
We wouldn't want to put it in update, because if update's being called 1,000 times a second, you don't want to check that 1,000 times a second. You would want to check it in the
event of a collision.
That's right. In the event that our score went up.
Yeah.
So you're absolutely right.
Okay.
The joys of 5 a.m. and no sleep. So we want to check to see if we are greater than or equal to 1,000.
Sure.
Okay. So that sounds like a good rule to me. So if we are indeed greater than or equal to 1,000, then we would probably want to
application.load level 3.
Outstanding. So let's go ahead and application.load level, and we're going to pass in number 3. So we can go ahead and save that. So we've got rules in place. It's all looking good. Now, our scene. The scene for win, what does it contain right now? Let's jump back here.
Doesn't contain anything.
Doesn't contain anything. Yeah. For main menu, to have main menu actually show some stuff, what did we do? We created and attached our own script object to the camera.
Right.
For our lose screen, what did we do?
Same thing.
Same thing. So we've got, again, camera. We've attached a script. So let's jump into our win screen. Camera, nothing attached. So we now need to create a
game object?
A script.
A script, okay.
We got it.
Sorry,
We've got a game object.
Yeah.
So let's jump back over here. And we've got a lose script. Got a main menu script. Let's make a win script.
All right. Can we just duplicate all this?
Yeah. What I'm going to do is just come in here first, and let's just add a new item.
And use your template.
And I'm going to use my template and create, we're just going to call it win. So we've got them in place. Let's jump down into function. We don't want any of that.
No.
Because we are going to do just like you said. We can just come over here, and I'm going to stick with the same button size. Jump back over and come into fields and paste those. And then come back over to lose. And like you said, we can just grab own GUI is the only thing we need. So that's our function that's going to be responsible for drawing some stuff to the screen. So with this.
And we can still use a button to restart the game.
Oh, yeah. So we can,
all
like
this stuff is still valid.
Absolutely.
We just change the text on the button.
You got it. You're right there at it. So we'll just jump back over here. And inside functions, let's simply paste this in. And, yeah, all we need to do is change some text.
Maybe change game over to you win.
Sounds good. Nice and simple. You win. Yay. And press play again. Okay. And we, of course, want to make sure that everything has been reset, so that's all good. We want to make sure that we're loading level 1, which is our correct scene for the game, and that's going to have the scene reload where everything's going to be reset and it'll begin playing again. So let's save this off, come up, give it a shot. So we've got a, actually, well, and the funny thing is right now I am on the win scene and I have yet to assign my new script. So it's a very simple mistake, and as you can see as I'm demonstrating here by talking really fast, let's make sure we grab our script object and attach it to our camera, and then save. I'm just going to hit Control-S, save our scene, and let's go to the start of the game by bringing up, not this guy, I meant to actually double-click this guy, our main menu. So we'll go back in, play. So here we are starting up, instructions, start the game, and now I have to actually play for real. So, dun 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 dun, and we are playing. Can he do it? No! Oh no!
It's all that pressure.
Yeah.
There you go.
Look at that.
You win.
You win. So press to play again. So there you go.
There you go.
We have created a simple game from start to finish. Now, Casey did an excellent job and talks a lot less than me, so he pulled it off in about 90 minutes. Awesome. And without Zach here, this would have probably been a 20-hour video.
I don't know about that.
Unfortunately, it's longer than 90 minutes. But for those of you that were able to sit through all of this, I hope you've learned at least enough to get into Unity and start playing around. Now we're going to come back with a few bonus videos. We'll record these tomorrow, so we can go to bed now. But we'll take a look at switching out some of the geometry, maybe having some stars that are moving in the background, maybe a splash screen, to see if we can fancy it up a little bit, because all of that's really simple. And maybe Zach's 1980s way of bringing our arcade ship back into the scene, our player.
Yeah, nice.
So let's go ahead and click the you win. So everything is reset and is working. So thank you guys very much, and we will see you in the next video.
Good night.
Good night. Okay, so at this point, we've wrapped up our simple game that we set out to create at the very beginning of this video series. But there's no reason to bring things to a close yet.
I already had my coat on. Are we not leaving?
I know. Nope, not yet. Figure we can push things a little bit further. We've basically did a quick, rapid prototype of a very simple 2D shooter. Let's push things a little bit. With very little effort, we can make this quite fancy. We can bring in some start, win, and lose screens that we can use, as opposed to just black nothingness with a button.
But it's such a glorious button.
That it is, but we can make things look a lot hotter if we bring in some textures, And then from there, how about let's get rid of all of this black back here and put some stars in there.
Okay.
So there'll still be a lot of black, so no worries there,
sure.
but you'll have some stars, and let's make those stars move. Okay, so if we get a scrolling background in place, that would be cool. And then from there, how about the geometry? Let's change out our geometry.
But I like the balls in the boxes.
I understand, and at this point, if you do, then you can simply stop, package it up, and there's your game.
Yeah, call it balls versus boxes.
I think it would be really nice if we were to bring in a new model that we could use for our player, and then bring in a new model that we can use for our enemy, and set up some code so that each time our enemy comes down the screen, not only is it coming in from a different location and at a different speed, but perhaps a different scale, so we'll get a sense of different enemies, because we're going to use just a simple asteroid. So
Sure.
that makes a lot of sense to be able to do that. And let's have it tumbling as well. That would be cool.
Yeah, it would be really cool.
And then, of course, we can't wrap things up without putting in your advanced respawning system. I guess we could call it that. If you recall earlier, you had mentioned, but the character or the player, when he comes back in right now, he just appears, and you want to see him slide
into the view, and he's got to be invincible for the first few seconds.
So we got to blink to let the player know that he is invincible,
Exactly.
so you can get out of the way if there's something coming down. Besides, it's a good idea to revisit that anyways, because as you already know, we talked about this earlier for just a second, we still have the ability to move and shoot when we are invisible, because we're not locking that out in the player's update. So this will allow us to jump in there and do that. So there's a few things that we can do to make the game look much more polished than it is now.
Okay.
And we can do this with very little effort. So the first thing I want to do is bring in these textures that I was talking about for our starting, our winning, and our losing screens, and let's get them into place. So it'll only take a couple of minutes. So first things first, let's go ahead and create a new folder, and let's call this folder Textures.
Makes sense.
Then let's bring in some textures. So we'll start out with a lose screen. All I'm going to do is just drag it from a folder that's off screen on.
Yeah, so you guys can't see it.
We've got that one. We've got a lose screen.
So you're building up anticipation before you show them what these look like, aren't you?
You got it. And a win screen. Now, it takes a second because we're actually importing these guys, and there's a few settings that we can change. So I guess we could start out with the start screen. Look at that, huh? So with the start screen, I want to just come up here and simply tell it not to generate any bitmaps because we're obviously not going to need that, and I'll just hit apply afterwards.
Going to be at the same size.
So, yeah, exactly. So let's come over here to lose, same thing, hit apply. Later in time, we'll begin talking about all of the different properties that we have available to us when we import textures. And let's come down here to win, and again, same thing.
Just every screen has an explosion.
So, yeah, isn't that great?
It is great.
And it's a nice explosion, Zach. A lot nicer than the one we have at the moment. Maybe, but those were fast explosions.
Yeah, that's fluids, man.
So we have these in place as far as our project is concerned, but we're not using these assets in the game itself. And to do that, we need to revisit our screens that we set up earlier. If you remember, we have our different scenes, main, we have lose, we have win. Mm-hmm. We need to revisit the scripts that are driving these. So starting out, I'm going to come over here to our main menu, and let's jump in here. And there's been a change, so we'll just tell it to reload. Let's go ahead and come down to the on GUI section. At the moment, we are drawing out our instructions text, and we are drawing out our button, and if we click on the button, it's going to load our next level, which is the actual game level. I don't want that button there anymore. Instead, I want a texture to be drawn. And now we can take advantage of GUI.draw texture in order to draw a texture to our screen. Mm-hmm. But I'm going to hold a reference to that texture. That way I can go ahead and drag it on in, and that'll make it quite easy for us to draw it. So I'm going to come up here in our fields area, and I'm going to do a public, and we'll just do a public texture. And we'll call this background texture.
Now this will be available in the inspector, right?
You got it, since it's public.
So that would be really easy then if you decided you wanted another texture later to just swap them out right here in Unity.
Absolutely.
Gotcha.
So if I jump up here, and again, this is on our main screen, so let's make sure that we have our main menu loaded up. And if you recall, we had attached that main menu script to the main camera. So we simply select the main camera now that we are in the correct scene. And background texture is now available. And as you can see, we have no texture that we are referencing. So I'm going to simply come down and grab the start screen right here, or texture, drag and drop it in. So space shooter _ start. And then we can now jump back over to the code and make reference to them. So what I'm going to do, and see the order of these things that are being displayed on the screen, as far as these different GUI functions we're calling on, mm-hmm. It all takes place in the order in which you draw everything. So I want to draw my background first, so I'm just going to come in here with a GUI dot, and then it's just draw texture. And GUI.draw texture is going to be looking for some information, starting out with our rect. So I'm going to say new rect. But instead of coming in and typing in specific numbers, how about we start off at 0, 0, and we tell it, as far as the width and the height goes, let's just reference our screen. So I can say screen.width and screen.height. Like
so
such.
Technically this would be ready for multiple resolutions?
Yes, that's correct. Though keep in mind, up until this point, everything's been pretty much hard-coded.
Right,
because again, simple games.
But this one line is ready.
But this one line is now ready to rock and roll. So with that, let's go ahead. Also, if you remember, the button also took advantage of our screen width and button width and all that good stuff.
Yeah.
So now I'm going to go ahead and do a comma. And now you can see right there in this overload for draw texture, we're looking for a texture to draw. And I have reference to one already, the background texture field that we have set up a second ago. So let's go ahead and do background texture, close this off, just like such. And with that, I can save, come back over to Unity, hit play. Dun-dun-dun.
Nice.
Dun, dun, dun.
But now there's a button in the middle of it.
Dun, dun, dun. Yeah, that's not good. We need to get rid of the button. So I'm going to jump back, come back over into my code, take the button, and get rid of it. But you know what? There's one line of code I don't want to get rid of. So let's cut that out, delete this, and then I'm going to paste this guy back in. But let's go ahead and comment him because we now have a problem. When we come back in and we hit play, fantastic. Well, looks good.
But you have no way to start the game.
We've got instructions, and it says to start, basically we need to hit any key. Fail.
And nothing happens.
And nothing happens.
Yeah.
So we need to set it up so that when we hit a key, we're in good shape. And so let's go ahead and jump back over into Visual Studio. And to set that up, what we're going to do is we're going to simply take advantage of the input once again, and there is something built in that we can use. And all we need to do here is simply say if, and then I can put in input dot any key down. So the difference between any key and any key down is any key, once again, is constantly fired if a key is down, and any key down is a trigger one time when a key is pressed down. So we'll simply say any key down.
But where's the any key?
Any key. Any key on the keyboard. So I know exactly what you're getting at. So there you go. So let's go ahead and save. Jump back over. Play. So press any key, hit my space bar, and everything goes.
We're back to balls versus boxes. Hey,
Yeah,
look
that's
at that. 3 in a row. 4 in a row.
You like that, eh?
I'm impressed. You've been practicing.
Yep. So that's all we needed to do to get, that texture being drawn at the start of our game. Mm-hmm. And that obviously makes things look quite a bit nicer than what we had previously. So let's go ahead and use this same field. I'm going to copy this and put him on both my win and my lose screens, and then we'll link up textures on those objects as well. So we'll come over here to win, and again, I'm just going to jump into fields, and let's just paste this guy, hit save. Let's jump over to lose and scroll on up, and same thing. And we'll hit save. We'll come back over here into Unity and open up we'll just start with lose. Go ahead and tell it to save out the main menu, and then I can simply select the main camera because that is where our lose script is attached, as you can see here. Again, we now see in the inspector the background texture, no texture assigned. Over in my project panel, I can simply scroll down up under textures, find lose, drag, drop, done. Let's go ahead and hit save. And I guess we could lose real quick to take a look at the problem. Jump in, game over. So come in here and die, and die. And we're not getting anything at the moment because we're not drawing the texture and we have a button there.
Right.
So let's jump back over into here.
Well, all we've done so far is we've just specified a field.
That's right.
We're not using it yet.
We're not using it. So before, the only thing that we had going on was this button. And if the button was pressed, everything inside of it was needed. Mm-hmm. But we don't want that button anymore. So I'm going to go ahead and take it out and then do the same thing that we did over here in our main menu, draw our texture. So let's go ahead and grab this guy, jump back over into lose, and paste them in, and there we go. Now, I also want to make sure I do the if input dot, and again, any key down, and we'll block all this stuff in. We need
reset everything.
Yeah, we need to make sure that we reset our score, our lives, and missed.
Yeah.
Otherwise, we'll run into the same problem that we saw earlier. So go ahead and save that. This should put things in good shape when we lose. Let's go ahead and hit play. So, of course, we're going to see lose every time because right now what screen or level is actually loaded, or the scene, excuse me, and we have scene lose, actually the active one. So let's hit a key. So that worked. So death 1, missed.
Yeah, I didn't even think about it. I should have made the explosion pink for the lose screen.
Death 3, and there we go. So after the explosion completed, you lose, dare to try again, press the key to continue. All right. So that's looking good. Next thing, let's jump over and wrap up our win screen. So we'll just double click to open it up, select our main camera. We've already set up the field inside our script. So let's associate our texture. So I'm going to grab the space shooter underscore win, drag and drop. So with that in place, let's jump over into Visual Studio. and make sure our code is set up. Here's how easy it is.
So you can just reuse all that code.
You reuse all of this. So copy, jump over into Win, and then inside of Win, highlight everything, just paste right over it. Very good. Now we can do some additional cleanup in here as well, such as the fields allowing us to store numbers for a button width and a button height. No longer need it. So let's go ahead and remove those guys. Let's jump over here to lose. Same exact thing. So I'm going to come up a little bit higher, clean this all out, save it, jump over here to our main menu, and once again do the same thing. We'll leave the instructions there, though. They don't get in the way.
Sure.
So we'll get that saved. Come back into Unity. Now, let's go ahead and load up our main menu. Make sure that our scene gets saved. So with our main menu loaded, let's go ahead and hit play. All right, looks nice. Let's hit a key, and then we start playing. Woo! And 300, 4, 5, 8, and 9, and you win.
Nice.
So all we need to do, press key, and we're playing again. So very nice. That's all we were doing in this video, just setting up some simple screens. So in just a matter of a few minutes, we've made things look a lot more professional.
Yeah.
Okay, any questions?
No, I like that we don't have to click a button anymore.
Okay, yeah, that's very nice. You can still use your mouse and click, and it'll still work as well.
Groovy.
So with that, that is going to wrap up this video. Thanks a lot. Okay, we've definitely enhanced our game. Now that we've got some really nice screens in place for starting, winning, and losing, let's take the next step. And how about putting in a background that scrolls? I think that would be a very good next step.
It would. You know, there's that whole ongoing thing, though. When if you're in space, can you imagine how fast you have to be going to actually see scrolling stars?
Boy, yeah, you're moving.
The game would technically be unplayable.
But how many games do you find at the arcade that have scrolling stars in the background?
It's a standard.
It is.
I blame Star Trek.
Now, there are a lot of ways that we can go about implementing a scrolling background. We're going to take one of the easiest and cheapest ways we possibly can. All we're going to do is simply create two planes, have the planes scroll down the screen, and as one of the planes gets off the screen, it's simply going to snap itself back to the top. And that's going to give us the illusion that we are looking for. Again, the idea of these videos are to present the creation of a simple game, and now a simple / polished game, in the most simplistic way we possibly can, so that those that are following along that have never touched Unity before and perhaps their programming skills are still a bit lacking shouldn't have much trouble understanding what we're doing.
Yeah, well, conceptually, I already see what you're going to do. So.
Okay, outstanding. So the first thing I'm going to do is kick things off by creating a plane that we can apply our texture that we'll bring in just a second too. So let's go ahead and come up here to our game object, come down to create other, and then we're going to grab a plane. Let's go ahead and set the name of this guy. So stars. That looks pretty creative. Now, with that in place, there's a few numbers I'd like to set for position. So let's go ahead and zero it out in X. In Y, we'll set this to a value of 1. And over here in Z, I'm going to push him back. We're going to rotate him in just a second. Actually, let's go ahead and do that now.
Okay.
I'm going to bring him all the way around 270, so he's looking right at us. But I want to push him back a little. If we were to come in here and take a look at the scene, you can see how some of our objects are just kind of penetrating through. So let's go back, I don't know, maybe, and it really doesn't matter. We can go back 100 units if we want, because, again, this is an orthographic camera.
Yeah, there's no sense of depth.
So we're just going to push them back about 3.25.
Is there any particular reason why you didn't just set the rotation to -90?
We very well could do that. And that works fine. You'll find later that the number by Unity will get changed to 270 for whatever reason.
Okay.
So I just went ahead and stuck with 270.
No, it makes sense.
Okay, so now that we have this in place, let's go ahead and scale them up. And we'll go with 1.35 for our scale. And, of course, we don't have to do this all the way across the board, just only on X and Z, but we will. So there we are, filling out the entire screen that we're using. So we've got them rotated, we've got them positioned. At this point, we need some sort of material to apply to them. So let's go ahead and scroll up to Materials and right-click, and let's create a new material. Let's give this guy a name real quick. So M_stars. Now we need to apply it, so let's just simply drag and drop him up here. So you'll see that he is using m_stars in our renderer. Now that we have that set up, we can bring in the texture real quick. Now, let me point this out. We've got two textures. We've got our stars texture, and we have our stars_large texture. I'm going to bring in the stars_large. They have been created specifically for the training video, meaning the stars are larger than you would want them normally.
Yeah.
They look a little odd, but seeing how we are recording and then encoding, and during the encoding process we are shrinking the videos down, the last thing we'd like to see would be for the stars to completely vanish.
So if you're watching this like on the website scaled down, it might still be a little hard to see.
That's true. So let's go ahead and bring our stars large in. So I'm going to simply, from off screen, drag and scroll down, drop. And once again, with this guy, let's go ahead and come over here, and we do not need any maps, so we'll go ahead and apply that. So we have our texture in, we have a material, but I'm not going to assign the material yet, just because with this guy being bright white, it'll be very easy to see him moving down and then snapping back up.
Sure.
Because I'm not going to create both of the planes right now. I'm just going to create one and get them completely finished. Then all I have to do is duplicate them, move them up, and the whole thing's done. So it's very quick.
Nice.
So I'm going to jump back over into Visual Studio. Let's create a new script that we can use to drive our stars. So on scripts, I'll simply right-click, come down to Add, a new item, and then using our template, let's come over here and call this guy Stars, like such. Now from inside of Stars, there's a couple of things that we're going to need. First of all, a speed. And I'll go ahead and set this guy to public. That way, if we want, we can tinker around with the speed externally or over in the inspector. So let's open up fields and come in here with a public and then float speed. And yeah, that's good enough. So if I save and jump back over here, let's take this new script. So come down here, there's stars. And I'm just going to simply drag and drop him up on the stars plane that we created. There's our speed over here. So let's go ahead and start this guy off with a value of, I don't know, we'll just start with a value of 1. Now, let's jump back into Visual Studio, and it's time to get this plane moving downward. This is going to allow us to talk about something else that's quite interesting. One of the reasons I wanted to put this in here. Let's go ahead and kill out start. We don't need it. Inside of update, let's stick with the amount to move variable. So
the same thing we were using on the enemies?
You got it. Amount to move equals. Now we've got the speed, so let's just take speed and multiply him by, you know it, Zach, what is it?
Time.delta time.
You got it. Time.delta time.
See, I'd have gone over to the enemy and copy pasted.
Yeah, of course.
But I'm lazy.
So next thing I want to do is go ahead and move this guy. So I'm going to do a transform dot. Now we're going to do a translate.
For relative motion.
And in the translate, so that we can do relative motion, we're going to tell it a vector 3 dot, in which direction we want to move them?
Down.
Down. So we'll go with down. And we'll take this, we'll multiply this by our amount to move. But we're going to find that things aren't going to move exactly the way we think they are. Let's go ahead and save this and then jump back over into Unity and hit play. It's moving. Which way is he moving? He is moving away from us.
Because you rotated it, so now it thinks that down is along the y-axis, so it's sliding away from us.
You got it.
I gotcha.
Because right now, anytime we do some sort of translation back over here, we're going to be working in the object's local space.
Yeah.
And since we have rotated the object, its idea of now has been shifted such that we've rotated Y from straight up towards us, pointing towards the camera, which means down goes away from us.
It's kind of that whole enemy's gate is down mentality.
You
where,
got it.
We've decided that Unity is a Y up world, so downward is always negative Y. Except we've rotated the plane, so now negative Y technically slides it away from us.
That's right. So to fix this, it's very easy. All we need to do is come into our translate function, and by putting a comma in there, you can see space relative to show up.
Nice.
All I need to do is say space dot. Are we wanting to move down in our own local space, which would be self, or world.
I never heard it called self before. I'm so used to local.
True, but in this case,
But it
local,
works.
yeah, local, it works really well since we're in code, and generally in code, when you're referring to an object in that code, you
Yeah.
refer to it as this,
Right.
and that's like self. So let's go ahead and set up world, save this guy, jump back over, hit play, and hey, look at that. We are now moving down. Now we're going to get to a point where this guy is going to go off the screen. And it is at that point,
Goodbye.
get numbers up here. It is at that point that we want for him to snap back up.
Mm-hmm.
So let's just get a quick, where do we want him to move down to? So down to, just a little bit. So here we are at negative 6.3. Negative 6.3, negative 7.6 has us just off the screen. So yeah, negative, or 7.6, negative 10.76
Okay.
that is. So let's go with negative 10.75. We'll say that that's going to be the point in which we're going right off the screen.
Okay, now it's when we're going to want to pop back up.
Yeah. So let's jump back over here. After we have translated or moved our plane down, next thing is going to be a simple check where I'm going to say if our transform dot, and then we're going to talk to the position, and we're going to talk to y is less than negative 10.75.
Now, is this still going to check in the world space?
This is going to, yeah, this is the real deal here, because you'll notice back over here when we were moving that even though it's been rotated, look what numbers are updating over here. It's
I gotcha.
real y. It is the
Okay.
world space.
Okay.
So jumping back in here. So if we get less than that, well, where are we starting out right now? We're starting out at a value of 1. So for now, how about we just reset it to 1? So jump back over here, and we'll simply tell it that if it is indeed gone less than negative 10.75, that we are going to set up a transform position, new vector 3, and let's just stick with our transform position.x. For y, let's just go with 1, and then finally for z, we'll just keep z. Save this guy, jump back over, and play. So we're going down, and we've died. And I guess I could dodge, so, since the game could actually be lost now. Woo! So when he gets all the way to the bottom, boom.
Pops right
back up, fills out the entire screen, looks great.
Gotcha.
So with that in place, let's go ahead and get our second plane in. So with this guy, I'm going to, let's come up here to stars. I'm simply going to hit Control D. So I now have 2. And with one of these guys, I need to move him up. So moving him up in the world, a little bit higher, and
It's going to kind of
boom.
butt them right against each other.
It looks like 14 will do the trick quite nicely. And it does. Now look at this. If I hit play right now, they're both moving. Because we duplicated the guy that had the script on it.
So they both have the script.
They both have the script.
Now, are they both going to jump to position 1 when you're done?
They are. When each one is done.
Yeah, when each one hits its
That's right.
point.
So 1 is no longer where we would want it to go back to.
We needed to jump to further north than the top of the screen.
And so we have that number already. We want it to jump where this guy is right now.
Yeah.
So this guy is at a value of 14. Let's just come over
Change
here.
our value to 14.
Let's just change the value to 14.
We kind of get that conveyor belt effect.
We'll save it. And I'll leave, let's select this guy right here so everybody can watch what's happening. So we know we are indeed scrolling down, but watch what happens when we hit that magical point. So down,
There, and then
and pop.
Very nice.
So that's
And
it.
down here in the game screen, you notice no changes.
Nope.
Yeah, it's just a solid white sheet. So I guess now it'd really just be applying the stars to it. Cool.
So and here comes the other guy, and pop. So applying the stars, very simple. Since both of these planes are using the same material, with either one selected, I can just come over here and grab stars, drag and drop, and I got stars all the way around.
Nice.
So let's go ahead and just save real quick, hit play, and take a look. Actually, just so we're staring only at our play screen. There we go.
Nice.
Well, I guess I could move out of the way. A little slow there. But as you can see, we are now scrolling. Looks good.
So now we have space balls versus space boxes.
Yep.
Space balls.
Pretty straightforward, eh?
Yeah, real nice. I like the system. Easy to understand.
It's very, very easy to put together. I had another student. I'll take just a second to mention him. It goes by the username MacMag over on 3DBuzz. That was working with me. He's learning Unity. And he did a very interesting thing when tackling stars. He used a cylinder.
Yeah.
And then he mapped the stars to that,
it.
and then he animated it rotating.
Yeah, I was just thinking about that a second ago. You do it like a big odometer.
Yeah, and it looked great.
Yeah.
And if you wanted to, you could dupe that off and get a transparent material on there.
Seems like a lot more polygons.
And you're definitely dealing with more. But I mean, come on, polygons are not going to kill us
Sure.
with a game
Sure.
this simple. But still, I thought it was very creative.
Yeah, absolutely.
Wow, that's cool. Okay, so now that we have this set up, let me think. Anything else? Just, of course, a quick reminder. Setting your speeds. Now, both of these guys are referring to their own instance of the stars class, which means if I set the speed on one of these guys, and then let me go ahead and scroll back around here and hit play, we're going to have some separation, as you can see here. So, and to make it a little easier to see, let's go ahead and turn this off and hit play again and jump over. So make sure you keep your speeds at the same.
Right.
Make sure you keep them consistent with one another. So let's go with maybe something a little faster than what we had before, 1.25 and 1.25. So any questions, Zach?
I don't suppose you can do like a public static so that you could actually talk to the class on both those.
Yes, absolutely. The only thing to keep in mind is you're going to lose it over here in the thing. But I mean,
gotcha.
it does work well. If I was creating this as a real game that I was going to be distributing, I may use the inspector from time to time just to go in and play with values and watch and find a value that I like. But you don't see me creating, and this is just the way I like to work, you don't see me creating public fields that are going to show up in the inspector and for me to leave them there.
Is there more overhead?
No, we start to get into design practices. The concept of working with object-oriented files is you want everything to be private. You only want to expose things through properties. And that's something that we're going to be taking a very close look at when we do the next implementation of this game, and we're going to put a lot more structure in it, but it's going to be set up in a way that you can work with a large team of people and you can work with the ease, and you don't have to worry about things getting broke with linkage and stuff like that. Where here you already see we're linking things up.
Yeah.
And if somebody came in here and changed the name of one of those, like the background texture one, change that name, save it out, it's no longer linked to the texture,
Right.
and now we've just broke something. Then we want to try to prevent cases like that. That's not to say that an individual coming in and coding can't, rapid prototype a game by just, tossing up things, public things that are going to show up in the inspector and then linking things all over the place. That's not a problem. It's just when you start getting into complex linkage and you're really no longer prototyping, but you're actually working towards a final game, then you may want to consider a different approach for coding. But anyways, with that, to answer your question, absolutely. Just come in here and do a public static float speed. And then when you refer to speed, just down here, just simply say stars.speed and set your value in here. So it'd be public static float speed equals, 1.25.
Whatever you needed it to be.
And then you've got one place to change it.
Yeah.
Because you're right. I don't like the idea of having to change something in multiple places, and if you forget, you break something. So I would definitely not take that approach. But for this video, again, keeping things super simple, very small script with what we're doing, very simple system to implement, and in the end, very effective because you get the sense of flying through space. So with that, that is going to wrap up this video. Thanks a lot, guys. Okay, so the polished version of our game is really coming along nicely. In this video, we're going to take a look at changing out some geometry. Now, we've got our enemy and our player. They are using very simple primitives at the moment. So it's time to bring in something a little fancier.
Okay.
And we're going to start with the player.
I missed the box already.
Do you now?
I do.
He served his purpose well. Both of them did, actually. They stood as great stand-ins while we prototyped out a game. Now the game is functioning, so it's time to to bring in some nice geometry and see what the game's going to look like with that.
Nicer geometry, anyway.
Okay, nicer. I mean, hey, it's still a 1980s style, very quick arcade game, okay?
That's true.
Well, I guess we can't really graduate to that step until I have the more advanced spawning system of our player, you know, where we blink and slide back on screen. So Zach has put together a simple ship inside of Maya. Took him about 10 minutes to do. Once complete, he then exported it out as an FBX file and handed it to me. So I'm going to bring it in, but the first thing I need to do is to create a new folder, and I am going to close some of these guys up just to make it a little bit easier. Oh, actually, I'll close everything up. So let's go ahead and create, and I'm sure by now you guys have seen the create button and you know that you can create stuff in here.
I was wondering.
Okay, I figured you may be, but I am, you know, of such a creature of such habit, and I'm so used to right-clicking and just working with menus. So I'm going to go ahead and right-click.
That's what you do in Windows.
Create a folder. This is true. My folder is going to be called Models.
I think it's what you do on a Mac, too.
There you go. So we've got models in. Now let's bring one in. So I'm going to come to the folder off the side of the recording area at the moment, and there's simple ship. Let's bring him on in, drag and drop. So the ship has been exported, and if I expand models, you'll notice that another folder has been created underneath it called materials, and we'll go ahead and leave that folder there. This is the material that was exported out with FBX. Mm-hmm. And and basically everything that we bring in FBX, it's going to continue, it being Unity, to put all of the materials for the different FBX models inside this materials folder. It'll keep things nice and clean so that I know that my models that are inside of the models folder have their materials close to them inside this particular materials folder. So we'll leave all of that at default. We don't have the texture in yet. We'll get to him in just a few minutes. First thing I'd like to do is simply swap out our geometry and see what happens.
Okay.
So let's come up here to our player, and then I'm going to go ahead and focus up on him inside of our scene panel here. This is about to be very important so that you can see what's going to happen with our size. Now, if you recall, our game object has a bunch of components attached, and one of those components was a mesh filter. The mesh filter component contains the actual geometry. The mesh resides here. At the moment, we've got this cube. If I was to drop this down, we'll find simple ship. So let's go ahead and put simple ship in there, and he's there, I promise.
It's tiny.
He's teeny. If I zoom in, whoa, a little bit too fast. There he is. So, you know, the first thing you may think is, oh man, let's start scaling this guy. No, we don't want to scale him. Let's jump back down here to our project folder, come back down to simple ship, and what I'm going to do from here, up under the FBX importer, I'm going to simply set my scale factor to a value of 1. Now, if I were to scroll down in the inspector and hit apply, boom, much nicer. A little big, though. I mean, the box was big, without a doubt, but this guy's a bit bigger. So let's go ahead and select our player. Yeah, we can definitely see right there.
Compare it against the collider.
So I'm going to scale him down a little, and as I scale him, watch our box collider. So let's go with 1.2. You can see that the collider is adjusting with it now, but it's still smaller than the ship itself. It's very easy to reset the collider. You may think that you'd need to come down to that component. You could open up size, you can open up center, adjust the size, and then manipulate the center to get everything centered back up.
Kind of do the inverse.
A quicker way is just to come over here, drop down, click on the little gear, drop down, and hit reset. And that's going to simply reset the box collider to fit our geometry.
So like a bounding box.
You got it.
Gotcha.
So now that we've got that set up, let's spend just a second and talk about our collisions. Because earlier, having our cube represent our player, collisions, they worked beautifully. Because if we had a collision between our enemy and the corner edge of our player, it looked right because we were looking at a solid cube. Now we have geometry that is residing inside of our collider. What's going to happen if we get a collision that occurs in this corner? Well, we are going to get that collision. We will trigger our isTriggerEnter function in which we will determine it was an enemy and we will explode.
That's when you get players who are like yelling at the screen going, hey, that didn't hit me.
Exactly. But, you know, this is one of those things where you need to make a judgment call yourself. And here's what I'm talking about. While you're playing, if everything's nice and fast and your guy's jumping all around and you have a collision between an enemy and the corner, but as far as things look on the screen, you'd have to be looking really, really, really close, and it has to be a slow-moving enemy, and then perhaps you could see it. If that's the case, just go with something like the box collider. Using a primitive collider is far less expensive as far as processing is concerned. Switching this over to a mesh collider, on the other hand, will give us more accurate or very accurate collision results in this case, but at the expense of processing. Okay?
Now, by mesh collider, what do you mean?
Well, I could take this guy. So we've got a box collider, right? And come over here, and I can remove him. Now we have no collider. So if I was to play the game at this point, we simply can't collide. We don't get that function called for us. But with the player selected, if I come up to components, down to physics, and add a mesh collider, what we're going to get is a collider generated that is going to fit over this guy that will collide with other primitive colliders at the moment, not with other mesh colliders. We'll talk about that in just a second. So if I was to come back in here and hit play now, boom, we start colliding.
Oh, wow, you can see the collider too.
And so now much more realistic collisions. Well, already dead. I like that. So... boom. So as you can see on that one, it hit just right out at the tip of the wing. Here we go. Oh, so close.
So that's for like polygon accurate collision.
Exactly. So in this particular case, I think I'm still a little bit too far over. It is nice being able to pause the game and then simply step forward. And that is
move into it.
So close. Well, I can't.
Oh, okay.
So
it won't take it.
Let's go ahead and play again and see if I can. And it caught it.
Nice.
Okay. But we noticed we didn't trigger that up at the top. It was almost when the guy went off screen. So we got much better collision. But again, you have to ask yourself, do you really want to spend the extra processing power? Now, this is a very simple game.
Yeah, I don't think you'd need it for something like this.
In this case, yeah, flip it over to this guy. That's fine. But if you switch over to a mesh collider, just keep in mind things are going to get slower. If you got a lot of objects with mesh colliders on them, that can cause a problem.
Now, are you limited to just using the actual model itself?
The one that is generated? No, actually, I've got another very simple model that I can bring in right now. So let me go ahead and do that. So a simple ship mesh collider. We'll go ahead and bring that guy in over here. And then with him, before I use him, let's jump down here and set his scale factor up to 1. Jump all the way down. And you'll notice very simple representation of the volume of the ship. Let's go ahead and apply him. All right, so now that he's been applied, let's go back to our player. And with the player, just to demonstrate this real quick, if we were to take our mesh now, drop down, you'll notice that I can switch this over to different meshes. So I'm going to come down to the mesh collider.
Nice.
So take a look at that. So a little cheaper. It's still more expensive
than just a regular primitive.
That's right. But of course, with less polygons in here, there's less stuff to check. So it is cheaper on the processor. There's one other thing I would like to point out, and that is if this object here is going to collide with other objects that also have mesh colliders on them, you will need to make sure convex is checked. By checking convex, we can now collide with things other than just primitive colliders, meaning other mesh colliders. But there is a limitation that you need to keep in mind, and that is as far as the convex mesh collider is concerned, you're limited to 255 triangles.
Gotcha.
Okay? So just keep that in mind. So
now, I did want to say this, too. I mean, I know I've kind of been playing a little bit of the student role, though I did model out that ship for you. I also modeled out the collider.
That's right.
So I did want to say this. If you want to create similar models on your end, make sure that your collider box and whatever object you are colliding have their pivots in the same location, because FBX is using that pivot location actually from your file, and then it's being placed in your on your ship or on whatever object you're creating a collision for based on that pivot. So if your pivots are offset, then your collision mesh is also going to be offset. Make sure your pivots are in the same location.
That's right. Okay, so that takes care of... we can just leave him like that. That works fine. So that takes care of collisions.
You can leave him yellow?
Well, it takes care of the collisions. We might want to take a look at the texture. So we're going to need a texture brought in. At the moment, we only have our screens and our stars large. So let's see. Over here in our textures, there is, there we go. Simple ship. Nope, not that guy. This guy. So let's go ahead and bring in a texture. So there he is, simple ship. Again, we're going to uncheck the generate bitmaps and reapply this. And now all we need to do is apply the guy to our material. So if I just grab player real quick and then grab my simple ship, drag, drop, there we go. Of course, you may be thinking, he's yellow.
Yes, yellow.
He is. Let's just come in here and reset our color back to white.
Oh, cool. So you can kind of modulate the color a little bit.
Yes, you can. So now we've got a ship. Let's go ahead and hit play, and boom, collisions work. And as you can see there, he hit the wing. Oh, and there's the wing again. Very nice. So we are having great luck with collisions, far more accurate than just a cube around it. But we have a problem after I start the game back again. And that is, let me shoot the gun. Zach, can you see what the problem is?
Is our gun firing from like deep inside the ship?
From deep inside the ship.
I mean, you could argue that maybe the center mounted gun is kind of up under the belly.
Yeah, you could, though it does look kind of funny that the whole nose begins glowing green as it is
it's a really powerful gun
shooting this guy off. So that is something that we may want to take a look at.
Yeah.
Let's go ahead and jump back into our scripts. Now, in this particular case, we are firing from our player. So let's go ahead and bring up our player. So from inside here, let's see, back up to update. So inside of update, this is where we fire. And at the moment when we fire, we are, as far as Y is concerned, we are adding to Y the local scale of this guy. So that doesn't have us that close. We could change this over to our collider and use our collider's scale. So just to give you an idea of what that would look like, let's just go ahead. I'll delete all of this out and type in our collider dot bounds. Now we've got both center and size. So in this case, we want our size and we want Y. So this is going to get us a lot closer, but it depends on how centered the pivot is on the center of the geometry.
Right.
And if it's off just a little bit, which it is in this particular case, then we're going to end up with it still not being 100%
still being a little
perfect.
far back.
So by coming back in and hitting play, we're closer, but still we need to move up just a little bit. So a very simple way to do it, instead of even going through and doing all of this calculation in there to begin with, is simply coming up and creating a variable, a member that will allow us to put in an offset. And I can go ahead and make it public, and we can simply adjust it inside the inspector until we come up with something that we like. So we can just do a public float and call this something like projectile offset. Like such. So we'll go ahead and save this out. Let's wire them up too, instead of jumping over setting and then coming back. So back in here. Now we could tie this afterwards, but really.
If you're just going to offset it anyway, I just have one number.
You got it. Just have one thing and we'll take that calculation out. So now all I need to do is refer to my projectile offset. Simply add that to Y and good to go. So let's go ahead and save. Jump back over here. Of course, I have not offset it yet, so if we hit play, yep, we're shooting from deep in our ship. So now if we were to come over to our offset, so projectile offset, and let's move it up to, start with maybe 0.5 and hit play. And now let's just play with numbers while we'll try to avoid stuff. So 1. And let's not hit space when we're there. So real close. So maybe 1.2. And quick death.
That's better.
That looks much better. In fact, it might be. Oh, it's hard to tell.
Yeah.
I don't know. What do you think? Just go with that.
I just go with it.
So we've got a value of 1.2. So let's go ahead and jump back over here and take this guy and put in here equals 1.2. And I am going to switch him over to private because I'm happy with the way that looks, and I don't want to put everything as public. It's going to drive me crazy. All right, so we'll jump down here and just let's not do that. Wow, it actually, let's cut this back out again. Come down here and paste. Thank you, Windows. Okay, that was odd. So set back up, saved, come back in, hit play, and we no longer have the property over here to mess with in our inspector.
We've got it to the setting we want anyway. So
We've got it to the setting we want, and that looks fantastic.
Nice.
Okay. Very good. So I believe that's pretty much everything that I wanted to demonstrate in this video. We've got some new geometry in place for our player. We've gotten rid of that cube. That's excellent. We talked about the primitive collider that was on it, and we took a quick look at the mesh collider and even went as far as to bring in a custom mesh collider. Then finally we took a look at the problem that had cropped up on us inside of our player script when we shot off our projectile. We went in there and we fixed it with a very simple offset. And with that, that is going to wrap up this video. So now that we have given our player an upgrade, we've got some new geometry on him, it would be nice if we were to turn our attention to the enemy and do the same thing. So it's time to get rid of this red sphere and replace him with an asteroid.
I missed the red sphere.
I know. He's not even gone yet. You can miss him in just a minute. You should be missing the cube.
I'm preemptively missing him.
I gotcha. Now, just as with the ship, I've had Zach put together a very simple asteroid over inside of Maya and export the asteroid out as an FBX. So let's go ahead and bring him in. So I'm going to grab him from off screen, drag him over, just drop him on models. And then I'm going to come over to the inspector and in the importer for the FBX, I'm going to change my scale. In this case, I'm not going to set my scale up to a value of 1 because he's huge. What I'm going to do is I'm going to set the scale at 0.05.
I was trying to make the game easier for you to play.
Easy? He fills the entire thing.
Exactly.
So let's go ahead and set 0.05, hit apply, and with that in place, now let's change out the geometry. So I'm going to come up to our enemy. And then from inside the enemy, we'll come over to mesh, simply drop this guy down and grab the asteroid. And you'll see size is just about right.
Gotcha.
Perfect.
Still red, though.
So he's still red. Well, that means we need to get a material in place with a texture on it and assign that. Right now, we're still using the M_enemy material. So I'm just going to come down here and grab the asteroid material, replace that, which is going to be white at the moment because I have yet to bring in my asteroid texture. So let's do that. Off screen, I'm going to find asteroid. There we go. Drag them over here to textures. Bring them in, and then, as we've done before, let's go ahead and make sure that we're not generating any bitmaps for them. We'll apply. And with that done, now all I need to do is come back and assign them. I'll just grab up here, do it this way. Come down to asteroid, drag, drop, and we have color.
Nice.
Piece of cake. Now, if we hit play, everything's going to work all the same. He still has a primitive collider on him. You can see the sphere fitting nicely, and he still blows up, and he can still destroy us. Now, to enhance things even further, let's give the appearance of different asteroids coming down. Each time one resets, let's adjust more than just the speed.
Okay.
Let's adjust a rotation speed and apply that so he's rolling down the screen towards us. Let's also come up with a random scale, and instead of treating it as just a uniform scale, what if we were to the scale X, Y, and Z individually, so we generated random numbers for all three of those
So
axes.
you can start to get kind of oblong asteroids and whatnot.
So to do that, let's just jump back into Visual Studio, and on our enemy, I'm going to create a handful of private data members. So we've already got our current speed here, so let's just kind of jump up, put these guys right here. So let's start out with rotation. So we've got a private float, and this is going to be our min rotate speed. And I have come up with numbers already, so I don't need to set these as public and then go over and adjust things in the inspector, so I'm going to use these numbers. So our min rotate speed is going to be 60. Let's set up a max rotate speed and set this up to 120. Now let's take a look at what we need for scale. So we'll do a min scale. We'll set this guy to 0.8F. Let's do a max scale. Set this up to a value of 2. Now I need to create my current data members, meaning I've got current speed here. I need a current rotation speed and a current X, Y, and Z scale. So private float, and this will be my current rotation speed, my current scale X, and let's just copy that. So Y and Z.
Yeah.
Perfect. Now let's get these guys set. Now, if you recall, inside of Enemy, every time we needed to set things up in regards to a speed or anything in regards to getting the player or the enemy reset, we did this call to set position and speed. Let's jump on down to set position and speed and add some stuff in here for our new rotation speed and our new scales. So we've got our current rotation speed. So for this guy, current rotation speed is going to be equal to, and we'll simply set this to, you guessed it, random.range, and we'll take our min rotate speed, and our max rotate speed. Now we have these current scale X, Y, and Z, so let's set those guys up. So we got current scale X equals, again, a random.range, and we'll set this up to a min. And you'll notice, by the way, I am switching over to just simply using range as opposed to the random range. I said that I was going to stick as close as possible to Casey's implementation of this. And now that we've finished that, it's fair for me to go ahead and get away from the depreciated functions. Of course, when Casey put his together, you did not have 2.6 available.
Yeah,
so
they weren't depreciated yet.
So that's right. So let's go ahead and set up a min scale value and a max scale as the range I am looking to pull a random value from. And again, I'm going to copy and paste, and change this over to a Y and to a current scale of Z. And by having each of these axes have their own random range, then we'll get a different number for each, giving us completely different sized asteroids.
Now, while you're at it, do you want to go ahead and remove the random range from your previous scripts?
Yeah, absolutely. So we can go ahead and just pull that guy out. Good catch. That's going to end up getting rid of a warning anyways. Besides, before we're done with this entire thing, I want to make sure we have no warnings whatsoever showing up in our console. Now we have this in place. Before moving our attention away from set position and speed, let's use our scale information. We don't need to use our rotation information right now because that is something that is calculated while the asteroid is coming down the screen.
At runtime.
At runtime. This guy right here needs to be calculated the moment he gets snapped back to the top, which means inside this function.
Right, one time only thing.
Yeah, so
one time for each cycle.
That's right. So we can just jump down here after we do transform. We put him where he needs to be transform-wise, or position-wise, excuse me. Now we can just come in and say transform.local scale equals a new vector 3, and then I can just use my current scale X, current scale Y, and finally current scale Z.
Nice.
So let's save this because we can test. At the moment, we won't see any rotation, but we will see different scaled asteroids coming down the screen because we are indeed hitting this code, which is causing the scale to be set. So with everything saved, we'll jump back over here, hit play, and he's definitely larger.
Mm-hmm.
And it looks like a different one.
Yeah.
Looks like a different one. Going to stay out of the way here. Oh, look at that. Littler guy.
Very nice.
So this is working out quite nicely for us. It does feel like we're getting, look at the little guy. And all of them will kill us as you, that one looks dangerous. And it was. You'll notice also that the primitive collider is reshaping itself nicely to fit around our geometry.
Nice.
So let's get some rotation taking place. So jumping back in here. Rotation is going to be something calculated every frame, so we're going to go up to the update function where this is run once a frame. So let's jump down and set up a float for rotation speed. And you may be wondering, well, why do I need a rotation speed? Because we've already got the current rotation speed. It's because we're going to take current rotation speed and we're going to multiply it by time.delta time because we want to make sure that our rotation is based properly, the amount against a second.
Check your spelling.
Look at that. R-O-T-A-T-I-O-N.
Yeah.
That look good to you?
Yes, sir.
That's what happens when we record. Here we are again, by the way, on these bonus videos at just about 3 a.m. So the next thing we need to do is to use this. So I'm going to do a transform.rotate in this case. And it's looking for a vector 3 for Euler angles, which will be describing Euler angles. So this will be the amount that we're going to rotate around X, Y, and Z. And we're going to rotate only around X, but let's jump back over here into Unity and show you how we know that. So if I were to take my geometry and grab my rotate tool, you can see already that it's going to be X. I mean, you can see the blue, you can see the green. X is selected at the moment, but so you can see rotating around X. If you look over in the inspector, you'll see these numbers changing. So again, let's grab this guy and rotate him. Now we want him to rotate this direction. So if you look down in the game panel, he's rotating towards us. That'll make a lot more sense than rotating backwards. And that is going negative. And I know that by looking over in the inspector at rotation for X, and we see it going negative. And I can also bring my mouse over here, and you see how the arrow turns into little arrows pointing left and right. I can click and I can drag, and going negative is the direction we want to go.
Gotcha.
So with that understood, let's go ahead and we'll zero this guy out. Not that we have to, but
because we want to.
But that's just because we can't help it. So coming back over here, let's go ahead and make use of this. And here's how we're going to do it. We're going to do a new vector 3, and we want to rotate in X. We don't want to rotate in Y. We don't want to rotate in Z. But in X, we want to go negative.
Gotcha.
So we'll put the -1 in there. And now all I need to do is multiply this vector by my rotation speed. So there we go with rotation speed. Let's base this guy off. Save it. Okay, so with this setup, one would think, hey, everything should work well. We're going to run into an interesting problem. We've discussed this before with local space and world space. Currently, we are translating this geometry down, but we're translating it down in local space. As we rotate this guy, that local space is rotating. So Y, which was pointing down originally, is going to begin rotating up towards us.
Yeah, it's going to be moving in a circle.
So if I was to jump back over here, let's see if we have some rotation to begin with. So we definitely have rotation. Boy, wasn't kidding about it being a big problem.
Yeah.
And as Zach said, we've got a circle going on, and that's absolutely true. So we may want to fix that. Very simple fix. We'll just jump back over here, and we'll make sure that when we translate this guy, we want to move him down. So I can just come over here and say space. Let's move him down in world space. So I'll set that to world space. Again, save, come back over, and hit play. Ah, look at that. So now we're looking for different speeds, different scales. So nice and small little guy.
Nice.
Ooh, big guy.
Yeah, a little black.
Little squashed.
Yeah.
He's kind of squashed. We get some round ones. He's a lot more filled out, if you will. And they still hurt. But the good news is they can still die. Now
if you can hit him.
Now it's a lot more challenging. We're actually making a game.
Yeah.
So, yeah. Okay, this is fun. About to win, though, so... Yeah, you win! Oh, in your face. All right, let's go ahead and stop. That's pretty much all that I had lined up in this video here. We just wanted to make sure that we, gave the enemy the same respect that we did our player. So things are looking really nice. In the next video, we shall make things even more interesting by bringing in Zach's advanced rotation system.
Sure. Well, when the player's when they blow up, we don't want them to just magically appear right in the middle of the screen. We're going to have them kind of slide into the screen and then be invincible for a few seconds. And to show off that invincibility, we're going to blink the player.
You don't want much, do you?
No, not too much.
Okay, so with that is going to wrap up this video. Thanks, guys. So in this video, we're finally getting to Zach's advanced respawning system that he described earlier, that he said we can find in so many 80s style arcade games. Zach, if you could spend just a second and go back over how this respawning thing works.
Yeah, I wouldn't even call it advanced. I just call it conventional.
Okay, conventional.
It's just
fine.
kind of the way they work.
Okay.
So your ship's
it's advanced compared to what we've got
That's true.
now.
That's true. Well, see, what's going to happen is somebody like Buzz will be playing, and he will get hit by an asteroid, and he's going to explode. See, like if I were playing, we wouldn't even need this system.
Gotcha.
But anyway, so you're playing, you explode. Now, instead of just popping back up in the middle, you're going to slide into play. So it's almost like another ship flies into view.
Okay.
Now, the catch there, like the next problem that we're going to solve, because the whole thing is here, we're solving several problems at once. The next problem is that what if you get that perfectly timed asteroid that's right there, so that right as you slide into view, he just smacks you and blows you up. You get like the spawn kill effect.
Right.
And that's not fair. You don't want that to happen.
Right.
So you need to be invincible for a few seconds right as you first come in to kind of get your bearings and get ready to start playing one more time.
Okay.
However, the player needs to know that they're invincible, and classically, the way you would tell a player they're invincible, aside from music like do 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 do, you'd blink.
Okay.
So all in all, what's going to happen? You'll blow up, and then you'll slide into view. As soon as you're done sliding in, you'll blink for a few seconds to let the player know they're invincible, and then a few seconds later, that stops, and you're back into the original game.
Okay. Well, let's start out by jumping over into our code. So let me jump into player. So let's see. At the moment, when we die, we were calling upon on trigger enter. We were calling on the destroy ship coroutine, which took care of what we needed to.
Mm-hmm.
All right. The nice thing about what you're wanting here, Zach, is that we get to introduce state. And state is something that we will be working with heavily in the future with more sophisticated games. In this particular case, there's definitely a few different states that we're going to be in. And let me just comment this out as we discuss them. First of all, we're going to be playing. Having a good time, shooting stuff, destroying asteroids. All right.
Right. Having a good time.
Now, the asteroid hits us. We're going to explode. So I'm going to set this up as a state because during the explosion phase, we're going to instantiate an explosion and we're going to vanish.
Right, we're going to hide the ship because it's not like the ship really goes away.
Right.
This is all sleight of hand.
But we're invisible, and then but we shouldn't be able to shoot.
You pull away input from the player.
So we're going to pull away input from the player because there's another state, and that is the invincible state, where in the invincible state, we can shoot, we can move, but it's not a regular playing state because the enemy cannot destroy us, but we can play and shoot.
Gotcha.
So these are the three different states. So what we're going to do is create an enum. So we're going to create our own type, if you will, that we can use for representing state. So the way we're going to do this is we're going to do an enum. I'm just going to call it state. And the states I'm going to give this guy are going to be playing, not player, explosion, and finally invincible, like such. Now, to turn around and use this, what I'm going to do is create a private variable, or private data member in this case, of type state, since that is what we just defined, and I'm going to call it state. And I'm going to go ahead and initialize it. So I'm going to declare and initialize, because when we start off, when this is instantiated, if you will, this class, we are playing.
Sure.
Right?
So playing will be kind of like the default value.
That's right. So I'm going to do state dot, and then I can choose from which state I'm in.
Nice.
So I'm going to do playing. So now when we start out, we're in a playing state. Fantastic. So let's talk about how things will be a bit different in update and on explosion. So right now, inside of update, we are allowing our player to move the ship, seeing if we need to screen warp, and seeing if they've hit the space bar to fire. But do we do this on all conditions? Let's think about this, on all states. When we are playing, do we do all these things?
Yes.
When we're in a playing state.
Yes, we do.
When we are in an explosion state, do we do all these things?
We do none of those things.
We do none of these things. That's correct. And when we are in an invincible state, do we do these things?
Well, the answer is yes, but I don't think we fire. Well, I guess you could.
You could, yeah.
It's one of those things. It's just like, do you want the player to still be able to shoot while they're invincible? I think that'd really be a matter of choice.
So in this case, we're going to keep things really simple. So let's just go with, you can do all of this when you're in an invincible state. So at this point, we've determined that everything in here is going to take place if we are playing or invincible. It's just not going to happen when we are exploding.
We're too busy exploding.
So let's just wrap all of this up in a nice if statement. And we can say that if state is not equal to state.explosion.
That makes sense.
And then I'm going to jump down and put an open curly brace and then come all the way down here to the bottom of update and put a closing and let Visual Studio indent everything for me. So this means that if we are exploding, we cannot move and we cannot shoot.
Okay.
Excellent. So let's go ahead and jump down to the next area. On trigger, enter. So this is when we're dealing with death and destruction. We've been hit by an asteroid. So when can an asteroid kill us? Can an asteroid kill us when we are in a playing state?
Sure.
What about when we are in an explosion state?
No,
because we're gone and we're not there to be destroyed.
And really, the only way for that to happen would be if we had more than just one enemy, because you'd have to have one right on top of another.
What about?
But theoretically,
what about when we are in an invincible state?
No, you're invincible.
You're invincible,
obviously.
So another very simple if statement can be wrapped around this guy. And in this particular case, all we need to do is say that if, we don't even have to put that in there. We can just add on to this if statement.
Yeah, because you've already got that one. Check and see what hit you.
So if the other object, the guy that hit us, if his tag is enemy.
And if the state equals state.playing.
Exactly.
Gotcha.
If state equals state.playing, then let's decrement our lives because we just got hit and we were allowed to be hit. And then take care of resetting our enemy and then calling upon destroy ship. So far, so good. The next thing we need to do is adjust our destroy ship to accommodate everything else we've talked about.
Yeah, well, we needed to basically turn invisible, slide off the screen so that it can be moved back on, and then as soon as it gets on, it needs to blink for a while.
So all sorts of things that we need to do. There's also a lot of things that you just mentioned that I would like to have private data members that I can use to describe these things so that I don't have to plug in numbers everywhere. I mean, I've already got numbers plugged in that I'm not a big fan of, like 1.5 right here.
Sure.
It would be a lot nicer to have variable names or field names in here that represent exactly what it is we're looking at. So in this particular case, 1.5, that is the time in which our ship is invisible. So for example, we can come back up here and let's start setting up a few private data members. So that would be a float, and I'm going to give it a descriptive name, something like ship invisible time. And it was what, 1.5 seconds?
Yes, sir.
So let's set that. I'm going to copy this guy, scroll back down. So here we are. Wait for how long? Well, we're going to wait for the ship's invisible time. So that makes a lot of sense.
Sure. No, absolutely. Now you don't have to dig down through code. I don't get to code very often in anything that compiles, but I do a lot of scripting. And anytime I've got numbers like this, I always try to keep them closely together up near the top of my code.
So it's very quick to go in and make changes if need be. Yep. Also, and the other big thing is if somebody else begins working with your code at some point later in time and you have just numbers plugged in all over the place, they may wonder, well, what does this number mean?
Yeah, you've got to go back through and read what the code's doing to even figure it out.
So there's several other things that we can represent with fields here, such as once we get destroyed, we're invisible. Now we're going to at some point become invisible after become visible after our ship invisible time expires. And we're going to slide on the screen. So it would be nice if we can control the rate in which we move back on the screen. So we're going to do that with a private float ship move on to screen speed.
That's a long variable name.
Yep, but it's very descriptive.
Sure.
So with that, so move on to speed. Now this is how far we're going to be moving over 1 second time, because obviously we're going to be multiplying against time.delta time, so keep that in mind. I'm going to take this guy and set him to a value of 5. And we can adjust as needed. I've played with these values before we began recording, and these are values that I liked.
Okay.
The next thing is going to be, so he slides on the screen.
Now he's got to blink.
He's got to blink. So now let's set up a private float that is going to be a blink rate. So this is how fast is he going to blink on and off in seconds. And I'm going to set this to 0.1. Okay, so 0.1 seconds on, then 0.1 seconds off. So we get 0.2 seconds, and we'll be making a full blink cycle, if you will. Next thing, there are various ways that we can go about having this guy blink.
Sure.
Different types of systems we can set up. I'm going to be taking advantage of the ability to yield execution within a
coroutine.
A coroutine. And this is very powerful here. And I just felt that this was a really cool place to show this, where we're going to stay in a loop, executing the same code over and over and over, but we're also going to apply a yield to it as well.
Gotcha.
So the way I'm going to do this, a very simple system, is I'm just going to set up a field that allows us to specify how many times we're going to blink, and I'm going to set up another field that's going to simply keep track of how many times we have blinked.
I gotcha.
So private, and these are going to be ints. So this will be number of times to blink.
So instead of saying something like, I want you to blink for 2.5 seconds, you're going to say each blink will take 1/10 of a second, and we're just going to count the blinks.
You got it.
Gotcha.
Okay. So then from here, let's create the other one that I was talking about, which is the blink count. And I'm just going to let him be initialized to 0. So I'm not going to initialize him here. So now that we have these guys set up, you could simply say that all of these fields are used to describe the spawning of a player.
Yeah.
Okay. Now let's go ahead and save and then jump down to our destroy ship. Very first thing we need to do, let's set our state. When we come in here, first thing that happens is an instantiation of our explosion prefab. So right before this, it looks like a fantastic place for us to jump in and tell it that the state is now equal to
explosion or state
dot explosion. So now we're exploding. Outstanding. So let's see what happens if I save and we test it out, because we know right now that when update runs, if we are in an explosion state, we cannot fire, we cannot move. So if we're in any other state, we'll do these things, but if we're in an explosion state, we can't. So we should lose that ability. So let's run in here, hit play, and so running around, I get hit, fire, I can't fire now. I can't move.
All inputs are stripped now.
So perfect. That's working very well. So let's go ahead and jump back over here.
So the trick now is basically that by the time everything's over, we're going to have to switch back to a playing state.
That's right. Now we have our off-screen move. I believe that's if we jump back down here. We are telling this guy to looking. Where are we moving him off screen at? So transform position Y, new position. Give me 1 second. I am looking through code. Some of this doing just by the very seat of my pants. Well, right now I am taking this guy and transforming him to the 0. I'm just transforming him back to the center right here with this guy, but I'm not moving him off screen. I need to move him off screen.
Right.
So let's take a look at that. What do we need to move? And my apologies. For just a second there, I was thinking I was already moving him off screen. Getting ahead of myself here. Let's grab him. And right now we're at, I'm just going to clean this up, say negative 3.2. All right? So I want to move him off screen. So let's move him down. And I'm looking down at the game panel. And
right about there.
So negative 5-ish or so, negative 5.5. Just give him a little bit more room to play with coming up. That looks good. So let's jump back over here, and this is going to need to be changed, because here we were simply keeping whatever position we were at in regards to Y, which was the negative 3.2, simply keep it. So in this case, I'm going to put negative 5.5. This isn't going to be a number that's hard to figure out because it deals with a position. We're simply saying it right there.
Sure.
So now we are moving off screen, excellent, and staying there. So if I save this and run again, let's see what happens when we get killed. We come over here, get killed, we're moved off screen, but we can't get hit anymore, we can't fire, and we cannot move. So, but we did not see ourselves on the play screen. So now we just need to set up the logic that's going to have this guy slide back on screen, and then we'll worry about blinking. From this point forward, everything is going to take place in this part, the true part of our if statement right there. Because if we don't have any ships left, of course we need to load out of here with our lost screen. So I'm going to go ahead and block this in because we're going to end up with more than one line of code. Now again, I want to keep this very simple. The first thing that I want to have happen is him turn back on, because we want him to slide up and we need him visible when he's sliding
so we
up.
know he slides in, yeah.
And the way I'm going to have him slide up, very simple approach, is I'm going to use a while loop. And I'm going to say while the transform.position.y is less than or equal to, or we can just say less than, but that's good enough, negative 3.2. Okay. So while he's less than or equal to that, I'm going to take the equal. That's going to drive me crazy. Then what needs to have happen? Well, we need to move the ship up. So we're going to move the ship up by first coming up with float mount to move. And remember, we've set up a field that describes how fast the guy can move onto the screen. So let's use that. Ship move onto screen speed. And as I said earlier, we need to make sure that this guy is multiplied by delta time. And now let's turn around and use them. So we're going to use our transform.position. It's going to be equal to a new vector 3. As far as x goes, 0. We're not moving him left or right. And then as far as y goes, I'm going to take our current position and I'm going to add to that position the little bit that we just came up with an amount to move. And then finally for z, let's just keep z the way it is right now. So let's say that we get set to negative 5.5. And we come through here the very first time and our amount to move, let's just say, is 0.1. So when we go to reposition this guy, he's going to stay zeroed in x. Negative 5.5 plus a positive 0.1 means negative 5.5 just became negative 5.4,
right.
Then 5.3, then 5.2, and we're slowly heading towards 0, or we're heading towards the smaller number of negative 3.2. So that now has us going back up. This is great, but we don't want all of this to take place in one tick. Yeah, that's not good. So what I'm going to do is come in here and yield, but I'm going to do something different. Up here you saw where I yielded for a predetermined amount of time. This time I'm just going to say yield return 0.
And what does that do?
This is going to simply yield us for one frame.
Okay.
So on the next tick, we're going to come back in here. Now, since we are multiplying our amount to move by delta time, we're getting that fractional value, so we're going to move up in such tiny little slices, we're going to get a very smooth motion on the screen. So with this right here, we should be able to jump out now and watch ourselves slide back on screen. So let's go ahead and save, jump back over, hit play, and let's find somebody that's not centered, please. Hello. There we go. You work. So boom, off screen, slide back on screen.
Nice.
So that's what you're looking for, right?
That's exactly what I want.
All right. Part 1 done. Part 2, I can't move. I'm invincible.
You need to go back into a playing state.
So, well, close. So here we are. We've just come back on, but now we need to blink.
Oh, so you want to switch over to the invincible
You got
state
it.
first.
Now I want to become invincible.
I gotcha.
So let's change our state. So our state is now going to be equal to state.invincible. So the next thing, well, let's just go ahead and test. So by switching out our state right here, now we should be able to move and fire, but the enemy cannot hit us. Jump back over. Let's play. So destroy. Fire, can't fire, can't fire. Now I can fire.
Nice.
So as soon as I come back on, but let's try, are we invincible?
Yes.
Absolutely. So the only thing we're missing is the blinking. So let's go ahead and turn this off. Jump back over here. And we can do this with another very simple loop. In this case, while. So with the while loop, we're going to continue doing this as long as what is inside our open and closing parentheses is true, as long as it evaluates to true. So I'm going to say while our blink count is less than the number of times to blink, that means we haven't blinked enough. We need to keep blinking. So the first thing I'm going to do is I'm going to toggle my current visibility. So if I'm visible, if I toggle it, that means I'll be invisible. If I am invisible and I toggle it, I'll become visible. So to do this, I'll simply go GameObject.renderer.invisible enabled is equal to, and then I'll simply put a not in front of the same thing. And then terminate that, and let's talk about this. So let's say I'm coming in here, and this is true. Well, not true is false. So this would be set to false. Coming back in here the next time around, seeing how this is false, not false means it would be true. So that's true.
Right.
So we're toggling back and forth.
Yeah, we're cycling.
So keeping this nice and simple, all we need to do now is simply ask, okay, hey, did we just become visible? So if this is true, and of course I could take out the equals true and just leave the check in there. It's very simple, but we'll keep it very black and white here.
A little easier to read this
It
way.
is easier to read, I agree. So if it is true, then what do I want to do? Well,
Increase the blink count.
You got it. I want to increase the blink count.
Because you're keeping track of that blink count.
Yep.
So
And since that's the only thing that I want to do inside the if statement,
don't need the brackets.
nah, we'll take those out just to keep the code clean. Yeah. Okay. So now we're increasing with blink, but we need another yield. But the yield is going to go back to the kind we used before, where we were waiting for a certain amount of time. Because remember, we set that variable up at the top, that field, to tell us how long we're going to be on, how long we're going to be off, on, off, on, off. So let's just simply yield for that length of time. So I'll copy this line just to prevent from having to type it all out again. So still inside the while loop, the time that I'm looking to wait or to yield
Is your blink rate.
is going to be my blink
Yeah.
rate. So
Gotcha.
blink rate makes sense?
Yeah. That'll be 1/10 of a second. So we're going to cycle on and off for 1/10 of a second each time, and
So
keep track
we'll
of how many
go
blinks.
off for 1/10 of a second. We'll come back on for 1/10 of a second.
Yeah.
Off for, you got it. All right. So once we're done with this, let's make sure, this is so important, that we set our blink count back to zero. We need to reset it. If we don't reset it, blink count is still going to be at 10. And if it's sitting there at 10, what good is that going to do us?
Right.
So, because next time we come in, well, we're going to skip right over the blink part. And then the final thing we need to do is set ourselves back to playing, but we'll do that in a second. Let's go ahead and save, jump up here, hit play, and just see if we got some blinking action. So I'm moving around, woo, and now let's die. Death, slide on, blink, 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 and aha, very nice. And I can move, but I am still invincible.
So now you need to change your state back to playing.
You got it. Let's jump back over here. So our state equals our state dot playing.
Easy enough.
Now if I come back, hit play, everything should work beautifully. So let's find somebody over on one of the sides. Perfect. Death. Can't move. And now I can move and shoot. And I was invincible, but let's prove it. So
No,
death.
you're not.
And invincible. Yep. You saw for a second.
Awesome.
So let me die again. Oh, that's going to be the end of the game. No, with
You
that cool
lose.
graphic. All right. Death. Come back in. Blinking, and I can run over him.
Nice.
All right.
So, and with the timing of the asteroids, it's kind of nice because you get one free asteroid when you come in,
Yeah, you do.
and then that's it. You need to start playing again.
Woo! So, that's it.
Very nice.
We can do another quick video just to show how we can speed up our asteroids, but I think at this point we are just about to the finish line for our polished, simple game.
Yeah.
So with that, that is going to wrap up this video unless there are any questions.
No, sir.
Okay, thanks a lot, guys. Okay, at this point, we've pretty much wrapped everything up. We started out with the goal of creating a very simple game. What we're going to do is provide an implementation of Casey Jones' game that he did in JavaScript in C#.
Right.
We did that. We had a little bit of extra to it here and there. And then we polished the game up a bit by bringing in some new screens, by bringing in some new geometry, giving it a bit of flair.
Sure.
And we've done that. The only thing I think we're missing, which I'd like to throw in there real quick before we wrap everything up,
Oh, there's more? I
is,
already have my coat on.
I know, you're getting ready to walk out the door, but hang tight. That is making the game more difficult. The better you are, the harder the game gets. So making the game more difficult as the game progresses.
How are you going to make it more difficult? Are you going to give the asteroid shotguns or something?
No, that would be cool, actually.
Would be cool.
No, instead, how about each time you hit an asteroid, we increase their speed?
Okay, that would do it.
Now, if you recall, the asteroids have a minimum and a maximum range that determine their speed. So if we were to take the min and max range and just slide the whole thing up, we could even make it a wider range that both min and max grow, but the maximum grows by even more than the minimum does. So now it's a little bit more of a random feel for, am I going to get a really super fast one, or I still could get one that's relatively slow. But each time a player comes in and hits one of these asteroids, the next asteroid that is to come down the screen will be faster.
Gotcha.
So let's jump over into our code and set that up real quick. So taking a look at the enemy class, just a quick reminder that our min speed and max speed are both public. And with them being public, as long as I have a reference to the instance of this class on the enemy, I can access these guys. So where do we need to access them from? Well, the projectile is the guy that is responsible for determining that there was, or for reporting a collision between one of itself and the enemy. So when we get this collision, right now, once we determine that what we've collided with is an enemy, we then turn around and we get a reference to that script, because we use that to set the position and speed of the ship, so we don't have to retype all that code here.
Sure.
What if we were to just hold the reference at the very beginning? We could do that. And
Because
then
we only have one enemy.
we only have one enemy. I mean, if we had multiple enemies, then, you know what, to be honest with you, I don't even think we'll do that. We'll just stick with this. But let me finish with what I was going to do.
Yeah.
And that is, I was simply going to move enemy, just by itself, up here and store it as a private field. And then I was going to turn around and in start, take enemy and grab the reference. You know what? My apologies. I'm going to do it. There's a reason I'm going to do it, because it allows me to show one more thing.
Sure.
Let me do this. So I'm going to go ahead and grab this and move it up. So this is going to be a private reference that we're going to hold to enemy. Now let me come down here to start and cut this entire line out, because we're not going to grab the reference down here in the on trigger enter event. Instead, in start, we're going to grab the reference. So let's paste it, and let's take enemy out right here. So there we go. That enemy is now being initialized right here in start, but we have a problem. Other object doesn't exist right here.
Right.
Other object was given to us by the on trigger enter function.
So how do we get access to the enemy?
Now we need to find the enemy. But as Zach was saying a second ago, there's only one enemy. So that really works out well for us. So I'm going to turn around and use GameObject.find. And since I know the name of this guy, the game object itself is called enemy. I can simply say enemy, and it's going to find him. And then once it's found him, look at this. I can continue using dot notation to get the get the component enemy script.
So it's almost like an inline search.
I mean, we found it, and then we just continue drilling down to grab the component that we want. We need to make sure that we still cast this over to an enemy, return that back. The reason is that our GameObject.find is going to return, as you can see here, a game object. But because of the .get component, we're not really returning a game object, as you can see. We're now returning a component, but we don't know what kind of component, and this is going to cast it over to an enemy component.
Right.
Now, we can only get away with this because we have one enemy. If we had multiple enemies, we really would have wanted to have left that line down in here. And it would have still worked all the same, because after we grabbed a reference to the enemy, then I could have simply come down and done what I'm about to do now, and that is increase our min and max speed on the enemy. I am going to do this before I call on the set position and speed. The reason is I want to make sure that the new speed that he's going to have takes into account these new min and max numbers. So I can simply reach into enemy and go to his min speed and increment it by a value of, let's just start out with maybe 0.5. I can do the same thing for our max speed, and I'm going to increment it by a value of, let's go with 1, so it's an even larger range there. I just want something that'll be noticeable. Then we can come in here and maybe back these off a little bit. So we're setting these min speed and max speed values before we set the position and speed. So when we set the position and speed back over here, we're going to be using the new speeds that have just been set. So we are actually reaching through inside of our enemy class, and we are increasing these values right here. So let's jump back over to Projectile. Let's make sure we do a Control S to save this guy. Jump back, hit play, and let's see if we can speed him up. Yeah! Okay, well, I still hit him. Oh.
Yeah, he's getting a lot faster.
Yep. Okay, yeah, real fast there. I shouldn't have gone for that one. Hey, I was invincible. It worked in my favor. Yeah, and I win.
Nice.
Of course, we may want to go in there and change the 1,000 point cap on the game, but that's good enough for now. So we can hit one more time. Actually, let's have a lot of fun here. I want to increase by a speed of 1.2 to 1.9. So we can see that the game does indeed get harder real quick. And yippee-dee-dee. But darn it. And can I actually get up this time? Oh, two more. Oh boy, they are flying.
Nice.
Nope, just didn't work.
Yeah, I just couldn't pull it off.
So there you guys go. I think we've done a good job of polishing everything up. So now the game gets harder. Final thing I want to do here is just simply jump into my scenes, and let's just start it from the beginning. We'll make sure that this guy gets saved here. I'm going to maximize on play. Let's go ahead and start it off. Da-da-da, there's our game. Let's see, before we go much further, we do have one warning down here, and I did say that I'd like to get rid of all of our warnings. So if I was to drag the console back over, you can see that this has taken place in our enemy file. And we're using one of those depreciated random range functions. So let's jump over here and get that out. So in enemy, let's come on down. I guess I could have taken a look as to where we were using it. And looking. There it is. So on X, let's just take out random and save. Jump back over and compiles. And if I drag over the console, and you can look down here, all warnings are gone, so now the game is nice and clean. Let's hit play. So there we are, space shooter. Press any key to start, hit a key, and background is scrolling. We are destroying ships or asteroids, and they're getting faster. We have a score. We have lives. We're counting the number that we've missed. And now it's getting nice and challenging.
It's like it becomes dangerous just to get in line to...
This is where being invincible really works out.
Yeah.
Oh, and I hit the key already to start back over. But anyways, that's it. So I hope that throughout these videos, for those of you that are new to Unity, that you've picked up some things. I hope that you see just how powerful Unity is. Mm-hmm. It's very easy to come in and quickly prototype out a game. And then you can turn around and start polishing it, making it look really nice. And I'd like to thank you, Zach, for joining me.
Well, thanks for having me.
Of course. And there's several more things I would like for us to do in Unity. Again, we're gonna take this simple project, and we're going to present it again. And we'll start out with the students that I have in my small Unity class. And we're going to rebuild it, but it's not going to look anything like this as far as structure goes, because now we're going to handle everything through code.
Gotcha.
We'll still have game objects. Those game objects are still going to be driven by mono behavior, but we're going to put inheritance in the mix, and we're going to make things very interesting there. We're going to have a sound manager. We're going to have a game manager. We're going to have a game class. We're going to be using state pattern design. We'll be using a singleton. There's several different things that we're going to use. So it's a very nice look at how we could go about setting up a game for a larger scale production that will work quite easily with a group of people, a nice sized team. But with that, again, thanks a lot, guys. And that is going to wrap up these videos. Again, remember, if you are new to C#, don't forget, head on over to 3DBuzz.com. And we've got quite a bit of content over there that's absolutely free that you can find in the XNA class that applies to what you're doing here inside of Unity if you're working with C#. So with that, again, thank you very much. And that wraps up this series.
Thanks, folks.